Fantastic. Almost perfectly on time.
Nice.
So thanks for that. So we'll switch over to Alessandro in just a minute. I have put the URL for Theory Studios in the chat.
Nice. Thank you.
Blender loves Unreal these days, especially since they gave the Blender Foundation a mega grant for doing a whole bunch more development. So it's nice to see solutions happening between the two. So, but thanks, David. Yeah, awesome
No problem.
session. And with that, I'm gonna tell you to get some sleep.
Yeah, be a good idea.
Yeah, and I'm gonna transition over to Alessandra. So welcome, Alessandra. Thanks for joining us.
Hello,
Please,
everyone.
yeah, please introduce yourself and your interest in Blender, and yeah, let us know a little bit more about what you're gonna show today.
Okay. Hi, everyone. Thanks for inviting me. I'm Alessandro Tomparelli. I'm part of a create group that is a part of the University of Southern Denmark. And in this talk, I'm going to talk about topology-based design for digital fabrication with tissue. And let me share my screen with you. And yes, so can you see it, right? Okay. So
yes, we can see it perfectly clear.
Okay, thanks. So basically, in this presentation, I will talk about two main topics that are partially overlapping. And one topic is Blender, of course, and the other one is Create, that is the research group that I'm part of. And I'm gonna cover also the more interesting part, in my opinion, that is the overlap between these two areas. And before starting, I want to mention a few reasons why a computational designer that most of the time is an architect, but sometimes is just a maker or a designer or fashion designer, or I mean, someone that use the digital tools as expressive tool in order to develop some original ideas for design. And I think there are some features in Blender that are quite interesting compared to what is around here. And one, of course, is mesh modeling, because Blender, of course, is a mesh modeler, can do many other things, can do animation and other interesting things. But mesh modeling, I think that is one of the features that compared with other software that are used, for example, in architecture, it's quite powerful and gives you a lot of flexibility. And using other tools, when I work in Blender, I really feel that I can express much better what I want to do using Blender and the mesh modeling tools that are inside the software. And another important feature is basically the use of the modifiers that allows you to create some non-destructive workflow, meaning that you can create something that is parametric. You have some parameter, you can change them, and you can update your design accordingly. And of course, another important part are the vertex groups that allows you to modulate and calibrate the modifiers according to input information. And the last very important piece is basically the Python API that we have inside Blender that allow us to customize and to adapt the software according to our needs. And I'm going to start with one project that is not really related with the topology-based design idea, but I think it's interesting because combined together all those aspects that I just commented. So basically, we know the situation, the global situation with the pandemic. And together with WASP, I started to work at this add-on that basically is an add-on for easily customize some briefing mask, adapting them to the face of the individuals. So it takes as input a 3D scan of the face of a person, and it just take advantage of the feature that are already inside Blender. So like using some modifiers, using some vertex group in order to make easy for a person that haven't used Blender before to just open the software and use some few parameter in order to adapt the mask to the individual face. So as you can see, basically in this add-on, I use all those important features that we have inside Blender. Those objects that you see are basically coming from another file. They have already a set of modifiers on top of them that allows to interactively change and move around the element. And using the vertex group, you can easily manipulate and change how the effect is gonna behave with a different object. Then you have mesh modeling tool that you can use in order to adapt it. And I mean, everything is so easy once the add-on is set up for a specific case. So once you create the mask, you can calibrate some parameter, you can improve the fitting with the face. And around there, they were developing some different design based on different type of filters that you can put on those masks. So we started to embed also some of the filters that were already developed from the community. And a lot of people was putting a lot of effort in starting to find a solution to the problem that was affecting everyone in the world, basically. And it is currently still affecting. So, and also, as you can see, some of the filter are kind of parametric, so you can change some parameter. And those are possible thanks to the use of a shape keys that we have in Blender. So basically, you can use shape keys for making parametric objects. Once you have done everything, you can see a preview with the object that can be printed using a 3D printer. There are some features that you can still change. And at some point, because it's a custom-made object, basically you want to make it customized in order to make it easier to recognize your product, your mask. And for that, I just use some features that are part of the sculpting tools. So you can just use a brush with a text, and you can just type your name or your ID on the mask. So you can recognize your mask. And then you export the STL. And as I mentioned, there are many other projects around there. And we just added some of the existing filters that were developed by the community, and we add them to this project. So in doing this, working at this add-on, basically, I took some pieces of code that were coming from a bigger project that I'm working on that is called Tissue. And basically, Tissue is a set of, initially, it was just a set of scripts, function that I was realizing for myself. And then I decided to share them with the community. And that was actually a very nice idea, I would say, because I start receiving a lot of feedback about features that were working, some other features that could have been improved. And with all those feedback, I start to make it growing and become more complex. So some of the tools that are inside Tissue are based on taking advantage of the weight tools, basically the vertex group that we have in Blender. So some of them help editing a mesh according to them, some other generate other geometry according to the vertex groups. But probably the most important tool inside Tissue, and this is the one that I'm gonna focus more in this presentation, is the tessellate operator. Because basically the tessellate operator allows you to take advantage of the topology of a mesh that you have and repeat a component object that is another geometry, and you can repeat and adapt to all the quad faces of your geometry. It doesn't work only with quad, but with quad you usually have a better experience in doing those tessellations. And it kind of works similarly to another feature that we have in Blender that allows to repeat object with on top of all the faces. But the difference is that here, every component is adapted in order to fit perfectly the area of a face. Meaning that once you have done the tessellation, all the components can be merged together, generating a continuous object. And this is quite important if you are interested in producing and fabricating your geometries. And during the time, I start to add a lot of settings, a lot of parameter. And it may look a bit overwhelming at beginning, but I realized that there were much more options that I wanted to add to this add-on. So if you look at all the parameters, it can be a bit scaring at beginning. So I try to hide some of them. And when you use the tessellation, you should see just the more important one. And as I was mentioning, this works quite well if we are working with 3D printing. And for example, if you are experimenting with the geometries and with some materials that have some degrees of flexibility, you will see that you can experiment with the behavior of a material according to the differences in the geometries. Or you may want to print something that is 2D, but printing on top of fabric. So you can put a piece of fabric in your 3D printer. You can print some patterns that have been developed on a bidimensional surface, and then you can have the fabric that is moving with those elements that are sticked on top of the fabric. Or if you are a generic artist, you may consider to use a topology-based approach for developing your more generic designs. So I was always intrigued by the hard surface modeling, but for me it was a bit time-consuming, and most of the time it was a destructive operation workflow. There are many nice add-ons for that, and I wouldn't absolutely want to replace them, but I just wanted to try to guess what would happen if you use a topology-based approach for generating such object. So as you can see, the geometry, the colorful geometry in the back is basically the base object. And with all the faces and the different material, you can basically pick one of the components that you see in front of the two different figures and put on top of the final tessellated object. And the interesting thing is that you can easily just manipulate one of the component, and this will propagate the effect of the final object. And if one of the component, for example, have a separation between a glass surface and a metal surface, let's say, then you will have at the end an object that have two separated geometries, one for the glass and one for the metal. So it's quite easy to define details that are developed according to the topology of the object. And a similar approach have been used, for example, in this medical device, where using the different component, basically, I define a different feature of the object, like holes in some part of the geometry, and a seam that is separating the two shells with a detail that define this interlocking interface between the two different shells. And thinking at architecture, this is a workshop that I did in Dubai recently, and not that recently, actually. And here we basically work with a group of students, and they didn't have experiences in Blender before, but using tissue, basically it was for them, it was easy to experiment with simple geometry and get the complexity out of this procedural approach. So it was quite easy to experiment different shapes, to find different way to create components that were able to be interlocked to each other, building at the end a geometry that have a very high level of complexity, but based on very simple geometrical rules. And I recently joined the CREATE group, and the CREATE is a research group that is focused on emergent architectural technology, meaning that there are different research areas that we are working on, and they are all in different direction, but we are all experimenting in taking advantage of the technology, on the more recent technology applied to the architecture. And in particular, the research area where I jumped in is the 3D printing technology. Not in general 3D printing directly applied to architecture in this case, but I was interested in experimenting with formworks for creating concrete pieces for architecture. So the group already had some research going on with about this topic, and as you can see, you can basically 3D print a formwork that you can use for shape different concrete objects that have different features. So here you can see some experiment made by the group. We've tried to express different feature of a surface, trying to make something that is more geometrical, something that have more sharp corners, something that have more smooth surfaces, bigger, smaller details, different features. While another series of projects that we were developing are based on a system of modular structure that can be assembled and disassembled. Well, those projects are not made with Blender yet. And as you can see, once you have a system of nodes that have that can be assembled and disassembled, you need to make a mold. So there are some tools that are used, some procedures that are more common for this kind of approach. And you see that you make this 3D printable object, and then you can produce the concrete part. In this case, we see a more complex node with a bigger element and with reinforced element inside. And the challenge usually when you have something like that is that you generate a geometry that represents the node. After that, you need to make some choices about some details of the object. So you need to put some metal element inside the structure. So you need a positioner that help you defining the correct position for those metal element before welding them. And at some point, you need to make a mold element that basically contains the final concrete object. And this is usually the procedure that has been used. While working with tissue, we try to adopt a different method. And basically, we try to design a bigger structure, taking advantage of a topology of the object in order to articulate a series of features that are following the shape of the object. Some features are just ornamental, some other features are more functional and related with the fabrication of the object. So basically, the structure is a modular structure, have some symmetries, so some elements are repeated more time in order to reuse the mold that you can 3D print for producing the different nodes. And the problem in general when you make this kind of geometry is that you use often a method that is a voxel-based method, like the voxel remesh that you have in Blender. And the result of this method is to have a topology that is not really nice. And you don't have very nice loops that help you operating with a topology-based approach. You have some tools that allows you to do some remesh using the quad, but sometimes you will see that the direction that you get are not always consistent with the topology of the object itself. So as you can see here, some loops are longitudinal in some part, and then they change direction. And in general, it's a nice geometry, but it's not ideal for the purpose of working with the direction of the loops. So we had to come up with a topology that is more entangled with the geometry of the object itself. And working with Blender, you may start thinking about the wireframe modifier or the skin modifier, but none of them is actually good enough in this case because of the complexity of a structure. And we have a structure that doesn't have only a surface, but we have a structure that have connection inside. And we wanted to have a very specific topology that gives at the end longitudinal loops direction and transversal loop direction in order to articulate the feature of the object. So taking advantage of the API that we have in Blender, we start to think at a workflow that is basically based on a polyhedral representation of the geometries. We already have some polyhedral information for the generation of a shape that you have seen. And basically building a process that is similar to the wireframe modifier, but based on those polyhedra, you can come up with a geometry that is consistently representing your source geometry. So instead of starting though from different polyhedra that are combined together, we decide to merge them together. So imagine that you have different polyhedra that are close to each other and you use the remove doubles, you merge the closest point, and you have something that is completely connected. This is a geometry that you usually don't want to use. This is a non-manifold mesh, but working with this mesh that is internally connected allows you to more easily edit your geometries, playing around and deforming it in Blender. So you see now some polyhedra that are combined together. They are fused together, so we merge all the vertices. And you can see how you can use the regular tool that you have in Blender in order to manipulate this object. So you can just pull some part using the proportional editing. You can easily deform it. You can subdivide the segment if you want to obtain some curvature. And then you can define the thickness of the element. You can change, of course, the thickness and some parameter. And then using the subdivision surface, you can have a nice and smooth connection between all these elements that are propagating inside the volume of the polyhedra. And as you can see, the direction of the loops now allow to easily work with a component-based approach that allows to propagate some feature according to those directions. So imagine this just this simple component, and using the tessellation, because of the coherence between the indexing of all the faces, you can get this complex structure quite easily, just because the topology allowed that. You can change the direction of a component, and what you get is a completely different effect. And as you can see, it's quite simple to change something small and obtain something extremely complex. And again, the connectivity between the parts, because we are working with a non-manifold object, allows you, for example, to smooth the different element and to take advantage of internal connection. And for example, use the smooth modifier or some close simulation in order to create some more peculiar effect. And all that is actually possible using the Python API that we have inside Blender that are based on the bmesh object that are quite flexible and quite useful if we want to jump inside the topology of the object quite easily. Here you see just some example of how you can start from a polyhedra complex and generate the mesh topology and defining some component that can have different direction, longitudinal, transversal, or diagonal. You can get quite different effect. And this is quite useful if you want to experiment with different shapes and something that is called optioneering. So basically easily experiment different effect in order to pick the design that works better for you. And working with architecture, and actually because we wanted to really build this structure, it's quite important to think at the dimensional control. Unfortunately, the workflow that we are seeing so far doesn't allow you this deep control of the dimensions. So I had to add a series of more specific rules in order to get the planarity between the separation loops between the different elements in order to get the correct curvature of a surface. And this looks like a very small detail, but actually it took a lot of effort in order to make it working properly, because we wanted to use some metal element for connecting the different parts. But if the elements are not always the same, this can be just a bit more complex part to develop for the fabrication. So there are a series of steps in order to obtain some regular sections that are then aligned, and basically the regular section are propagated to the node in order to have some straight connection and not having just local deformation. And all those parts at the end gave a series of features that help changing, for example, the number of subdivision that we wanted along the strat, and obtain a geometry that is not perfect, but good enough for the fabrication purposes that we had. And something that it's really interesting in operating inside Blender is that you can still edit manually some points and just make some adjustment if you just see something that is not exactly how you want it. And this is just a fancy representation of a vertex group. So here, for example, I use the vertex weight proximity in order to get a visual feedback in real time of the variation of the thickness of the element, starting from the starting lines of the polyhedra. So I was able to just manually move some of the points in order to see what was the best configuration in order to obtain the correct thickness, but in the same time, a nice movement of a topology. And this is quite easy to do in Blender thanks to this visual feedback that we had. And once we defined the topology, we had to define the actual piece to produce, but also the mold. And what we decided to use, basically, it's an integrated approach of creating both mold and node together using directly the tessellation. Here you see how complex is this system. Basically, there are some arch elements that are those that are used for putting in position the plate element, the metal plates, together with the rebars. Once we have this frame that is assembled with the arches, the metal element, the metal worker can weld the core of the rebars in order to have a system that is continuous and connected. Once we have welded it, we can put the external shells together with some cap element, and we have a closed mold that we can use for casting the concrete. And it's a complex object But using the tessellation, we were able to embed all this complexity inside just a few components. So you see that those are the components that we have used. We use the multi-component feature inside tissue in order to use them in different parts of the object. And as you can see, we have a surface that is representing the shell in some part, and we have a surface that is representing the concrete. Then we have another component that is defining the seam connection between two different shells. When two shells meet each other, there is also an arch element, this light blue element. And we have half here and half in a different type of component. So basically, the component is actually combining together different elements of the mold. Once we define a mesh topology that basically is calling the different component in the different part of the surface, we get a tessellation object that have everything combined together. From this one, we can extrapolate quite easily the different arches, the different shells, and the surface of the concrete of the object. So these actually help basically studying together in the same time the shape of your object, the shape of the mold, and the shape of additional element that you need for defining this frame. So looking at the concrete, you can implement some design feedback and you automatically get all these elements together. So you can evaluate if everything is working properly in every moment of your design exploration. Of course, we couldn't do everything inside Blender. So for that reason, I use another add-on that I was developing that is called Mesh Sync. And it's a very simple add-on. It's just exporting as TXT some mesh information from Blender, sending them to Grasshopper, that is a plugin for Rhino that allows this visual programming editor through a node interface. And just using TXT file, we were able to move the mesh from one software to another, putting together all the information that we need. For example, like the vertex group or the connectivity between the different elements. And we were able to transfer as much as possible the information between the two different softwares. Here you see just a simple diagram of the fabrication process. So we have some elements that are 3D printed, that are the shells, the caps, and the arches. And we have some metal work. So we have to laser cut the metal plates. We have to combine metal plates and rebars together with a mold frame that is 3D printed. Then the metal worker is welding the center of the rebars. We can close the mold, we pour the concrete, and we extrapolate the final piece. Here you can see some pictures of the workflow. So this is one shell that we 3D printed. Here you can see the frame assembled together with the metal rebars put in position, ready for being welded. Here you can see the welding process. So as you can see, the position, the shape of the arches allows the operator to reach the center in order to weld the different parts. Then we put together the shells. And as you can see, there are some bolts that are along the arches, and those have been defined in Grasshopper. But it would be nice actually to see if in future it's going to be possible to just use the geometry node in Blender to directly create those elements, those Boolean elements. Here you see the mold assembled together. Here we are pouring the concrete. As you can see, is attached and suspended to this board in order to put in the horizontal position. And this is the final node extracted after 48 hours. And the workflow works fine. There are, of course, some small issues to fix, but this is just a prototype. And I hope to being able to show soon also the final structure. Of course, it's gonna take some time for developing and fabricate it properly. And I have a small to-do list related with tissue, and it was interesting to experiment with making this prototype and working at this project because I realized some limitations, some problem that we had, like the dimensional control. So I started to develop and implement a new feature related to the control of the dimensions. And I need to improve the documentation because so far, most of the features that I'm constantly adding are not properly and well documented. And some improvement can be done with MeshSync, like changing the name, because I realized that there is another add-on that is called MeshSync. And some other optimization are related, for example, with a polyhedra frame tool, like some code optimization and, for example, the cell merging option. This cell merging is basically a feature that I'm starting to develop that allows to fuse together the cells that are too small to get thickness. So instead of having intersection, if you have very small cells, basically it's a feature that should allow you to create a geometry that is like looks like a calcification of this trabecular structure. And yeah, and that's it. And of course, if you have any comment, I don't know if there are some questions.
Yeah, so there are more comments than questions, but thank you for finishing just about on time. So some of the comments we've had are beautiful, impressive. Alessandro, you are a genius. I'm currently cooperating with orthopedic workshops in Germany, and I must say, tissue is groundbreaking for digitally created orthotics.
Wow, nice.
How cool is that? Let's see. Yeah, I mean, Alessandro, nice diagrams. Yeah, I have to concur with that. You have some of the most beautiful presentation slides.
Thank you.
We've had so far. So thank you for putting so much time.
Thank you.
That.
Actually, it's everything is made in Blender, Freestyle, and Inkscape.
Oh, so, wow, that's fantastic.
Yeah. Now I started to enjoy Freestyle for this presentation because it's amazing for producing vector graphics from the 3D object in Blender.
Yeah, your diagrams and the slides. I was wondering about them. They look so
Thank
awesome.
You.
Very blueprint-ish.
Thanks.
So yeah, so feel free to. So thank you. In the interest of time, I'm going to transition to Matthias, but feel free to hang out in the Blender in the YouTube chat, answer any questions people have. I've put URLs to both your YouTube channel and your website in there. So
thank you very much. Bye bye.
Okay, bye now. All right, Matthias, are you online?
Yes, I am here.
Awesome. Okay, please feel free to introduce yourself. Let us know your history with Blender and tell us a little bit about your session.
Yeah, so my history with Blender, I've been using it for I think 12 years now. Started in high school in my free time, making models, just checking it out. And at one point, it just developed into a job. Well, I kind of made it into a job. I combined my love for history with my love for 3D art. And basically, I'm working on making that my career. So the talk I want to talk about now is related to a project that I've been doing for a client of mine from the south of the Netherlands. And we are rebuilding some historical houses from the late Middle Ages or like the Renaissance era, 1550, more or less. And we're developing that as like old villages that don't exist anymore because of a flood long time ago. And we wanted to reconstruct them. So let's share my screen to show you guys some stuff. First, load it up. Yeah, so what I'm going to show, I'm going to try to do a quick workshop to how I make a basic house. So if I see the shaders loaded, okay, share screen. There we go. Is it visible?
Yes. Yeah, okay. We can see it perfectly.
Okay. Great. So these are houses I made for a project for my client, and like they're basically none of these are like actual houses that exist anymore. So how we came to the conclusion that houses look like that, and for that I do a lot of research in the project, and we also contact historians and experts on the matter. But it's mostly made from from researching a lot of paintings out from the time. So if you can see, this is my board with a lot of different paintings, maps and stuff. And I search in museums and archives and stuff to find the different things. And then I cut out all the houses that I can find. So some of these are from the same painting, but then I specifically focus on different houses. And from this, I try to make a general understanding of what the average houses would have looked like from a village from the time, because we want to make it as generic from the time and region as possible. And interesting, sometimes things are really different than you would suspect, because, for example, the thing you might have known from before was from a specific region, and then you find out things were different in another region. From that, I would make like a reconstruction painting just to have like a concept art to work from, because it's a little easier to test things out in 2D than in 3D. And from that, I would work on a 3D model. So my idea was today to try to get something to make like the house. It's a little later area than the rest has shown, but it still has similar methods. So if we now put this to the side, so I see it on my second screen. Get a second screen, guys. It's amazing. It helps you so much putting your references and to stay looking at them. So there's another project I'm working on, some boats. I think I talked about boats last year or the year before, I don't remember. We're now going to look at this. So I already made a little like 3D sketch because I didn't have a 2D drawing this time. So we're going to see how fast we're going to model. So what I use for a project, I figured that the best method for building is to go back in the mind of the actual builders of the houses and construct it in the way you would construct a real house. So that way I first made basically like the raw materials of the house and made some prefabs like the doors and windows because they're more detailed, but you still use them often. And then you can work way quicker. So what I do, I have my preview house here. I put this on wireframe, so I can look through it. And then I just start taking a piece of wall like this one. Let's copy it over so we still have the example. And just start placing it roughly in spot. And the great thing about this is that I've also already researched what kind of stones would have been used in the time. I made the textures of this one, specifically one in Substance Designer, so they're custom-made textures, but you can also use photo textures from existing buildings if you want. So what I often do is I connect it up and then delete it. So I don't like to stretch things because I already kind of have an idea for the textures are already in the right scale. So I don't like to stretch things, and then later I will fix up the UV things. Also, what I did with the prefabs is that I already gave them some natural shapes to it. So it's not a straight square anymore. Like there's already a bevel modifier on it, but also I already gave it some shape that it's not a perfectly straight line anymore. So that's why I copied over. So these details stay the same size that I already tried out before. So what I do here, delete the faces in between, connect them up. You can also use bridge loops and then delete one of the two loops. And add the seams back for if I interrupt again. Those seams. So what I then do, because now there's some UV issues, what I do is I take this one and I take my preview set. Let's first this one. I deselect this one. No, this one. So what you get is you have the reference or the UV of the new thing is completely mixed up, and we still have the old one. And then I use the Packmaster add-on. It has a adjust scale to select it. Wait, I first have to unwrap it again. I think the wrong texture is selected because it's being stretched now. That's better. Someone walking in the room. Okay. Yeah, so I just scale to selected. Wait. I think I unwrapped the other texture as well. Okay, so I need to make sure I only have this one selected. Oops. So now this one is still on the right scale. So if I press this one, it will scale it up to exactly the average scale size. So the bricks stay the right size. So let's go with this top part. So what I would do here is roughly copy the same height over and top. Could stretch out the top though. It's the quickest way to do this. You know what? I'm just going to extrude it from here. I think that's easier. Extrude, deselect this part. At the same time, it's practice in speed modeling, doing it in a workshop. Select this one. Here, squeeze this a little bit. Let's reset these. The double vertices. So what I often also do, I don't do that. I don't think there's enough time to do it during the workshop, but I often would make extra smaller parts to like cover up the decals. There's still some double vertices. Yeah, there were still some double ones. And I would use smaller, thin parts basically as like a kind of decal to add like other stone or brick orientations for parts like this side of the building. So let's quickly unwrap this one. Do the same as we did before. So we only select these. Just scale. Oh. Here. All right. If there's some question while I'm working, Sterling, you can give them, and I can talk about it while working.
Okay, sounds great. I'll pass those along, Matthew.
So yeah, you can see that there's some like it's in the wrong orientation here. So what I would do later is add a little overlay on this side to hide this away and make the bricks go to the side. But for now, we'll just leave it like this. So I think it's also another important thing is like you can iterate on this because it's all made of pieces. So you can also always make things more detailed as you go on. So you have the basic walls first, but then you can later go back and add more detail to it or change it, make holes in it or whatever, extrusions, whatever is necessary. So this one up quickly. It's going to be under the roof anyway, so it's not much of a problem. We can stretch this tiny bit. Sometimes what I do is just I'll stretch this tiny bit this way and down. Then I will just go quick and dirty into the texture editor and just by eye squish and stretch it a bit. So it's not exact work, but it works for now.
So no questions so far, but we've got some comments here. The textures and subtle hues create a wonderful aesthetic. We've got modular houses, exclamation point. Yeah, the boats. So people are really enjoying the session.
Yeah, so about the modular houses, the interesting thing is to find a bit of a balance between if you make things too detailed, then you start reusing things too often and you get more similarity between things. While often in the past, houses were often built one by one, like it would be hard to find the exact same house twice. So I think this method gives a nice balance between prefabbing some stuff, so you already have some basic ideas of what you want, but then also to work faster. But then also you can let's put it on this side. I've got my line of text. Yeah, also you can make every house you make more unique and stuff. So I think it's like a nice balance between that. And what I also like about this method of working is that because if you do it this way, is that you already work with textured pieces. And I like to work with like the what you see is what you got method. So if you do it this way, you're already working with a model house. So while you're busy, you're not looking at, like if you would be looking at this gray models and then texture it later, it's a little different workflow. And I really like this here as well. So let's add a little bit of a wiggle to the house because it's old. So sag down a bit. And we'll have to extrude this upward a bit so we can fill in this part that's sticking out. So on the roof, I have a subsurf modifier. Let's see how far we have 10 minutes. Let's connect this up. I always still think that it's already a year ago since it changed from remove double to by distance, but I still pressed the wrong button a lot of the time. Okay, so we now have our roof. Let's make it stick out a little. I don't think it's centered. Proportional editing, always a great tool to keep using. So we have our stuff here. Now we're going to add in some windows. So we'll look at a reference and we see that there's a staircase here and then there's a door over here. So, and the door has a window above it. If I drag in the reference, there's a door here and the door has 2 windows above it. And then there's 1 window to the side. So what we're going to do is we're going to grab this one with the side pieces. So it's not very, like if you see a little bit of difference, this door is a little more shady, more like a barn door, and this one is nicer for like a front door of a house. So we grab this one. It already has a cube in it for the Boolean. So we're going to bring it to our house over there, rotate it 180 degrees.
Hey, quick question. We have a question. Is the modular system used internally by yourself only, or can we find it somewhere?
This is currently only for my own use, but I am thinking about I'm thinking about making proper assets with like historical dates or date ranges, so people can download them from my asset store. My store is store.mrtherich.com or .art. I don't think it matters which of the extensions. I already have some historical assets on there. But yeah, so I'm thinking about making a library of all these assets, but I think it's also smart to just do my own. Like they don't take me that long to make. And if you do it this way, like I mean, these planks are just bars with a little bit of a wiggle in it and stuff. And then the textures are also made in Substance Designer, but you can also just use stuff from textures.com. It gives more your own character to things. And you can always combine it with things you buy from stores and stuff, like assets. But I think it's also smart to make some of the stuff yourself, so it sets it more apart from other people's work than if you directly copy it. Anyway, let's do the Boolean for the door. So I have the Bool tool add-on. I think it comes with Blender. You just have to enable this. You press difference and oops, it cuts it out in the wall. We only have to move the order of the tool. So it uses the bevel. So you can see the edges are beveled now here. And one thing, if we move the wall a bit more inwards, the door. You can see there's some issues here with with the stone. So a quick way to fix that is to give your actual shape here to also unwrap that in the texturing mode, because it copies over the UV. So you see there's stones here now. And if you want, you can put the effort in to make it the same scale like I did with the other ones. So now the stones are also inside this. Go a little inwards here. Already, like it's very tempting to make things too detailed already, but we're speed modeling now. So, and then we have the little window to the side. So I think it's a window like this with the glass in it. So we take this one, bring it over there. I think for this one we forgot to make. I forgot to make the Boolean cube, but we can just quickly take a piece of this and then just quickly scale it in the. There we have a window next to the door. We can also see that there is a little overhang. So I haven't made this one prefab. Well, I could, but I haven't done it. So what I just do is grab some of these pieces of wood. And we can quickly prepare some stuff. We have the planks here. Let's move it in.
Couple of other comments while you're working. Yeah, we have like people are admiring your UI theme. We have comments like nice, I'm liking this. We have what a great idea to work with textures on, much more enjoyable and indeed change the workflow. And somebody said, in order to work with the textures enabled, do you need a powerful system?
Not at all, especially if you don't have too high of a resolution of textures. Like you don't really need to go above 2K for working with this. And Eevee is just so powerful. Like that was one of the best things about like when Eevee came out, is that you can just work with textures and it looks great while you're working. I have HDRI enabled. You can download more from HDRI Haven for free. That was the most exciting thing about when Eevee came out, is that you can just work and see what you're working on, and it looks great all the time. Like that's the thing as an artist. Like I like to look at great things while I'm working, not just only in the end. And I think that also helps because if you're painting, like you always have something to look at while you're making the painting. While in 3D, you're often only looking at this, and then only in the end it looks interesting. So I think it makes it a little more like the traditional arts, I would say. So okay, I could do more windows, but I think this makes the point. We have 5 minutes left. Let's add some roof tiles to this top part. I have the length enabled, so sometimes it's a bit blurry with all the numbers there. Scale it down a little bit. And this method, like I also learned this from like level design in games, because in games you would often have the assets beforehand and then you would construct things. So I watched a lot of YouTube videos in my free time or while walking on the side, working on the side. And I would watch these people just make amazing scenes while not having to pay attention to all the details. And they could focus a lot more on how it looks and what kind of story is told with the scene, instead of having to focus on vertices and faces and stuff. So it helped a lot. So for the roof, what I'm doing, I made some, are hard to see, but I made some pieces that have like, some roof pieces that have like these details cut out with an alpha map. So I can put these on here. Also prefab, so I can put this with, let's see, align the targets. I can put them on here with the snap tool to just give it a little more, because otherwise it's super flat and that looks a little weird. like this, and I have also one pieces for the border here, so we can put these on here. Could also do it for the other side, but oh, oops, going into rendering mode. So we have some stuff for the side here. Let's see what we have. We have 2 minutes left. What can we make in 2 minutes? Maybe let's see if we can make a staircase in 2 minutes. So we grab some of the longer beams. I also like to work like, let's put them here. I also like to work like in real life on construction and stuff. And it really, like, it also gives you insight into how things are actually made. Like something you might forget in 3D. It's a little longer now, but it doesn't really matter. Like, and you learn about how things work together, like how construction could work together. Go to the right side.
It reminds me of the 3D artists you hear about that are so dedicated to creating the human form that they take medical school lessons and start dissecting cadavers and so forth.
It's like a fun hobby. Yeah, so also distances, if you want.
By the way, David Barron says, take your time, my dad. So if you run long,
okay,
it's a little bit okay.
Okay. Yeah, David was already struggling to get his half hour full, I think so. What he said. So the reason I have different size planks is because now I can scale them a little more. Actually, I should maybe have a shorter plank version as well, without having the textures to stretch too much, without having to dive into the UV to fix it. One thing that's important about to get things look realistic is to get the skills right. And there are easy ways to do that, to just pay attention while you're working at the site. So staircase steps are often 30 centimeters or like a foot height and difference. So what I do when I place them is I just copy them over and I just type 0.3 in the height and it's 30 centimeters. And you get steps that have a realistic spacing. Maybe this one on the bottom doesn't need to be there. So yeah, copy these over. Select this one as well. So now I put this one on the place of the last one and then put it 0.3 higher and scale it here. Now for the last one, we'll just make I think the stair can move a little bit because it's. Oh. Sometimes you press random buttons when you're going fast. Let's not press the delete button though. And important thing, don't forget to save. Blender has this funny moments to want to crash. So we now have a platform here. So one other thing, you see that these are now repeating. So what I can do, because I already made the seams in my prefab, so I don't have to worry about these. I can now select all these planks, apply the scale. So the scale is on 1, and we can just select them, UV unwrap, and they will be placed. Let's select the right texture because this is a long one. And they will immediately be unwrapped here. Scale them up a bit. And then I can place them at random spots. So the texture would look different. And if I didn't scale them up, I wouldn't even have needed to do that. For example, for these, I could just go here and then move the texture and I have a different pattern. So there's less repetitiveness. I can't handle these long beams. Wait, I'm just going to scale it down for now. Should be fine as it's. I rotated the model instead of the. Are there more questions or?
Oh, sorry about that. Finding my mute button. So there is a question here. You mentioned painting, and your work looks very painterly-like. Do you paint?
I don't actually paint, but I did study a lot of paintings. Like my hand-eye coordination to actually like paint by hand is not the best. This isn't squishing right, but who cares? But I do study a lot of paintings, so to see like how the lighting goes, and let's take this shorter one, how lighting things work, and how to get the right colors and stuff to make it look painterly. But it's interesting because the paintings of the past were made on based on like real life, so they tried to make it as realistic as possible. So there's a part of the paintings that are actually just very realistic. So it's trying to find that balance between making something look romantic and cute versus having more realistic looking things. And often it's not mutually exclusive, so you don't have to make things you don't have to make things look super unrealistic. Let's add a couple of windows just for fun to the side here. Oh, I still have the rotation on. That's not handy. So you can see how quickly it is now to add windows. So if we add one here, let's put it in the wall. And because I already have this Boolean block here, I can just select the wall, press on difference, then put this on fast, move it up, and we have an extra window in our house. Let's make one that's standing open. So we have this. And then because we already have one Boolean in this one, what I can do is I can take this one and just join it to this Boolean, and it will automatically also make the hole in the wall. So that goes very quickly. Open this window and then add this. I like to put these frames, probably willow branches behind it, so people just can't just climb in your house, or like birds won't fly in or anything. Glass was very expensive at the time, so they wouldn't always put glass on all the windows, like only a couple, like above the door or next to the door or whatever, just for a little bit of light. And then the rest they would, like, only when it's nice weather they would open the shutters, and then otherwise it would stay closed. So yeah, maybe as a last touch we can add the chimney here. So I have a set of chimneys, different chimneys sizes here. These ones are specifically actually made for the houses I was working on, so they weren't specifically for this project.
So I have a question. You and I ages ago talked about, you sometimes put these models into Unreal Engine, and we talked about using some of the Unreal Engine real-time ray tracing features. Did you have you ever played around with that more?
I haven't had the time to do a lot of Unreal yet, but I am trying to think of a method where I can use these assets in a quick way, import them to Unreal Engine. I think I can already do it like this because these textures are already, they have all the proper PPR textures and stuff, so I could just import them. But when I port it to Unreal, I also would like to get some more detail in and like bake the textures in or something. I still have to look at that, so I can add a little more character to some of the detail. Let's change this a little so it's not super straight. Like, it's important also to not overdo it, because unless you want a very cartoonish look, but they did have rulers and like, how you call this, lats, that you have a heavy weight on a rope that you drop down. So they did have these things, so they know how to make a straight thing. It's not that they weren't able to make things straight. Sometimes it's just like the character. Sometimes they put it on soft ground, so the buildings would slowly sink over time, but then they would have been straight in the past. So it's always interesting to keep these things in mind when you're working on this. So again, here we take the chimney, just scale. And we have the correct scale for the chimney. The reason why this we have to apply it. the reason why there's all these streaks and stuff on here is because in the material that I also pre-made, we have the original texture, which is clean. If you look here, there's no dirt on it. But then I use a couple mix nodes, and I mix in a different noise texture with a white color. Or I think, I use the plaster texture. So I think that's let's see. I mix in this plaster plaster texture with like a noise, just a general noise texture, some color ramps to change the intensity and stuff, and that adds some like dirtiness to the house and gives it some character. Also, I think those things also help with the painterliness of the model. So I think this is like okay for now. Maybe it's a tiny long thing. If you're okay with it, David, I can show what I meant with this reference, because I do think it adds a lot to a building, even though it's a tiny detail. So what I would take this ridge, and then scale it in a little and make it a little wider. And then extrude it, but don't extrude it yet. But then you use the shrink flatten modifier to expand it inwards. Like normally I would add a little more, because the angles are here quite sharp. So normally add a little more topology, but I think for now it's okay. So I would scale that inward. Let's extrude it so it's not in the same model. And I think I have some issues here. Move these. Yeah, okay. So now you see it also. So I would use this, and then if I get these seams right, this one, I should be able to unwrap it like this. Seam here. Yeah, like this. So now all I need to do is get the scale right again. Selecting this other part. Okay, so now the scale is right at the stones. And then you can see now it has this stone ridge. Sometimes I would play around a little to get the correct. It's a little dark now, but let's change this. So I could like move it around a bit, so I have a nice, where there's not too many seams. And what you can also do is you can make a special texture of this one that has the stones in a row instead of shifting half stone. So then you get a nicer edge for this part. And then I could just copy this over to the right side. Doesn't fit perfectly, but I get the point. But things like these do add, they do add a lot of, I think the texture is upside down. That's better. Yeah, it's also turned. Oh. They do add a lot of character to a building like this, because in real life, they would also often do like differences in stone and stuff. And if we look at some of the buildings I made here, oops. Let's see this up close. For example, for this one, I made the stones go inside in triangles, something that was often done. Or you see above the windows, I would add this little bar of stones diagonally. That would make it a little stronger for the white area. I think one of the houses, even this one, I have like an arch that is like inside a little. And yeah, also on this. So I would add that detail, because in real life, I don't think it's on this specific example in the house we're making. I think on this one they just put on cement, something that you can also do. But anyway, I think we made a nice house.
Yeah, it looks fantastic. I would live there.
So
awesome. All right, so just doing a quick time check. So David Barron, feel free to unmute. I think probably time to pass the torch to give David his 20 minutes so he can finish the session on time. But yeah, it looks amazing, Matthias. Well done. We're getting all sorts of great complimentary comments in the chat, you people are like fantastic and no sawdust.
Things do go a lot faster digitally than in real life.
They do. So thanks for that. And again, like if you want more, want to see more artwork from Matthias, the URL in the chat.
MrTheRich.art or MrTheRich.com, and you can see some historical assets of mine on store.MrTheRich.com. Awesome. Or you can find me on ArtStation, Mr. The Rich, basically Mr. The Rich everywhere you find me.
All right. Thanks so much for joining us, Matthias. Feel free to hang out in the YouTube chat and answer questions.
Sure.
Yeah, just post your socials in the YouTube chat, Matthias.
Mm-hmm.
Yeah.
You can share them.
Or I could do it for you, Matthias. Just let me know. So
that's fine.
Thanks, David. Thanks for joining us. Welcome.
Yeah. Well, thanks for thanks for getting a little bit of time. I have a kind of a flexible presentation, so I can just pull some things out or push some things in. Well, I really enjoyed Matthias' presentation. Always like his very hands-on approach, and it's very kind of like intuitive way of working. I have a couple of cases I want to pass drop by. I'm gonna have my share screen. If somebody allows me to share this screen. I think this is visible as it is.
Yes, we can see it. Great. Thank you.
Okay. Yeah. Well,
yes. We see a slide said review of a busy lockdown here.
Yeah, correct. Yeah. A heads up for the new Blender Meetup Day logo header.
Thanks.
Yeah, short background of where I come from and what I've been doing. The Blender Meetup Amsterdam. Well, no meetups. I've been totally neglecting it for the last year. Sorry for that. There's also meetups that actually do have virtual meetings. Ton Roosendaal, on the other hand, was hosting our meetups, and he's very much about meeting people physically and having a beer. But also this World Blender Meetup Day is a little bit of an incentive for me to perhaps organize a Zoom version of the Amsterdam or local meetup. I'll show you some ongoing Blender use at the Cubic group. There's one particular fun job that it's just been delivered, I think yesterday, and I've been working on a nice side project for a local radio station that you see on the background before. Where I come from, I always like to show this picture. This is not my fitness device. This is what I actually went to school for. This is like a camera that's been used in printing stores in the time of the Romans. So anyhow, I've been using all kind of software since the first 368 processors, and on a certain point 3D. I picked up Blender after called Dream 3D was discontinued, and that's the learning curve is always very steep. So I still have the idea that other people know a lot more than I do, which is usually the case. I've been organizing the Blender Meetup together with Matthijs for many years. So we've been coming together, like 3-4 times per year on the creative locations. Lately, the Blender Institute in Amsterdam North. Unfortunately, I didn't organize any meetups or any gatherings so far. But like I said, this is also a nice incentive as a reminder. Like, hey, perhaps you just have to, because I'm really curious what other people are doing, and I miss some of you people very much. I work for the for the Cubic group. Cubic group is an international design and project management group, and we do big exhibit, international events and environments. Actually, together with Matthijs, kudos. I think it was in 2015 where we kind of introduced Blender as a tool to visualize and to combine all the internal and external softwares. And since then, it's been kind of used as a bread and butter tool, or at least in an Amsterdam office. Last year, the Corona year for this type of business everything came to a screeching halt as far as international events and exhibitions. All the tenders and pitches that are out there for international or national shows you cannot do a little bit. You have to really go all out in your presentation and your budgeting. So that means that I've been really busy last year with, amongst others, visualizing. Cubic is kind of like an agile organization, so we also started to offer some hybrid platforms for clients. There's still a portfolio of museum projects internationally, and that's usually project that already had some budget allocated. So that's stuff that's still happening. So all in all, we're gonna survive, and we are really anticipating of opening venues and trade shows somewhere in in beds with like a bottle of wine, I think, when they're gonna be opening up. This is some stuff from last year. I got a couple of colleagues who are typically working SketchUp. SketchUp models are being converted to objects with some textures and stuff included. This is from a few years ago, but this was fun job also. Kind of proud to work for bigger brands and also to see it executed. To really see that how this transparency might look like on the fabrics actually became like an eye catcher because they didn't come up with that stuff unless you wouldn't show it. This is another big client, DSM, chemicals and nutritions. This is also stuff that's just been built in a big international trade show in this Madrid. Some stuff for last year. What we typically see is shows are getting smaller. So there was some small exhibit for the Dutch trade section for, in this case, agricultural shows. Horti Asia, this is actually being awarded and it's very much focused on environmental use and sustainability. So all the materials are plastic based as far as possible and either recycled or recyclable. For the visualization of this kind of shows, I'm kind of still leading on two legs, like EV versus cycles. Even though, I still feel more secure in cycles to give it like a more photorealistic look. But since EV is also still moving forward, it's such a fast tool. This is another show also for the Dutch Ministry of Funny Walks. No, this Ministry of Foreign Affairs for a modular stand where we were get our inspiration of Dutch landscapes and skies and very wide, very much with picture on their current house style that resulted in this set of visuals. Don't know if this is going to be awarded. Also here we are really working on modular setups that you can break down in sections and also use for smaller shows or only like a hybrid environment where you can do webcasting. That is something that's being requested more and more often to integrate in our shows. So it's also like a smaller setup and an even smaller setup. So hence these all cycles. One really crazy show, a crazy job that came up was there is a big mall being just opened in yesterday in the Netherlands, the biggest mall in the Netherlands. And one of the tenants is the museum. Still have 10 minutes, 9 minutes. The museum is, I don't know if you can call it a museum, but it's a place where mostly an Instagram museum where it's all about you. So you have this funny, crazy rooms where kids with their socials can make pictures of themselves. And you got a whole set of rooms, the laundry room, the maze room, and there's also like little pass sneak throughs where you can take pictures and etc. It's just being built. But one of the rooms was the checkered or the maze room, and you see that on the right-hand side. And that's something that was sold, but we didn't really know how to execute it if it wasn't for a Blender. These are some other rooms. So, it's just a fun place for young people to, being self-observed, to take pictures of themselves and post on the socials in all kind of creative manners. This, for instance, like a scary room where you made a whole bunch of scary dolls. Sorry, none of this is Blender related if it wasn't for that the maze room. We got some other impressions. So this just been delivered last week. This is going to contain 100,000 rubber balls, but this is a maze room. It was sold as some like op art room where the walls and floors had optical illusions. it was an idea of the client, and it's something that you want to sell first. So you're going to pull some pixels of internet and throw it on a little presentation. And the client bought it, and he asked us to price it and to execute it. Now, if you go on online, you see this kind of references, and yeah, there are usually pictures that you find on Pinterest, but only very few are actually printed in a 3D environment on like a wall or on the floor. The most are just funny pictures. So the most extreme shapes you find is like the one on the left bottom. This like actually being made in tile, but none of them actually are wrapping around the whole room. The initial idea was to have all the floors and the walls all matching up. But the tile size was of the tile size of next door's rooms should match the tile size of the floors. But the bigger the tiles are, the less topology, the less effects you can put in. Well, first is some test with proportional fall off to see if you can actually make something work and make it convincing. Then I made some animations and to give the client a little bit impression. Hey, how would it actually look from eye height? The client wants to have something more extreme, but I also want to test because the client wants to have more like this kind of specials, which look great, but they don't necessarily always look great from different perspectives. So what I did was making a couple of simulations. Then I might have to switch screen, but I basically had a camera fly around and show the client that some of these things don't work on a wall if you're passing by, only from one particular perspective. The final production was really easy because you only have to just render in a decent print resolution, which is for large format printings, 7500 dpi. So if you just set in full HD or ×2 or 4K rendering and in Eevee that runs like a fly, of course, then you can just send it to print and have it printed on stickers. Well, I can show you what the blend file, or else you don't even believe that I'm a Blender user. So this is kind of like the rough setup. I guess you can see my Blender workspace right now. I don't hear anybody, so.
Yes, we can see your Blender setup.
Yeah, great. Yeah, so I made a controllable tunnel basically from like an edge loop at the front, and then extruding it to the back, putting a couple of modifiers on it, and have more control on it by linking it to an empty, because the front obviously had to be as straight as possible to make it renderable to a flat space. So I made a couple of sections, a couple of walls. Some are actually just a proportional fall off in 2D, like this, obviously this one. I decided on the floor and the ceiling to put a more subtle pattern, and the walls more extreme patterns. So I made like a little zone with Taurus. What is plural of Taurus? Is it Tori?
I don't know.
Which is very simple. You just have throw a camera in there, and you can just start rendering out. You just select. You have just two materials: a black and a white material. Or this is actually what am I looking at? And you can just checker select and checker deselect, and then giving it a black and an illuminescent material. So I gave it an emission because the world environment is dark, and then you get just more more contrast. I was actually quite happy, and that even the smallest details, like I made like a super Tori with another warp in it, that I was concerned if it had such small topology that it wouldn't come out rendered and printable, but it actually looked really, I was really happy with it. There is a little video on it online, but I'm going to skip it. So this was just a fun example of something that, you got colleagues that are working with SketchUp or, with 4D Cinema, you could also do this, but within our organization, this kind of things wouldn't be possible if it wouldn't be for Blender. And you can easily sell this kind of crazy solutions. Another thing that I've been doing last year is setting up. So these are just some very rough renderings. Initially, you had the idea to make all the floors and the wall tiles match up to each other, but obviously you cannot do that here. Yeah, so there's a couple of videos already of the manager walking around here. So it is an eye catcher where it's going to be a lot photographed. Last year, one of the biggest achievements for my own feeling, I did the Montesa Sinave Miss Matissa, his real-time motion graphic course, which I can really advise for everybody to do. And that ended up in creating a whole set of video loops for DJ shows. The fun thing about the Montesa's course is it really learned me to enjoy working with Blender and again, you know, like after doing all this kind of, no, don't say boring stuff, but it's, you know, you can just don't be afraid. And if it comes out a bit different, then you're just going to play around with it further. Point was, I ran into a DJ at a nightclub a year and a half ago. It was just before the lockdown, and we started chatting. He asked me like, "Hey, can you make a logo for me?" And like, yeah, you know, if you were a sucky DJ, I would charge you a lot of money. He was a great DJ. We got friends, and it was very easy to make, you know, animated logos, keying it to music. This is not very difficult. It's just easy. Some a curve. What do I call it? Yeah, it's just an extrusion that you key to your F curve to music. So this can be used in VJ shows. Here, just have a random material linked also key to curves, F curves to the beat of the music. Then he came to me, hey, I also have another gig, which is like a radio station in Amsterdam. And I didn't know this, which is a radio station which exists for about 35 years. There used to be a radio pirate, but now they're a web station. And they also need to have like a logo rehaul. Initially, to be honest, I'm first sketching things in Adobe Illustrator. It's very proprietary, but it was just necessary. And then I started working it out in Blender. I also have all kind of animated versions from this. But what I noticed is that yeah, they didn't have any video content. So one of the DJs happened to have like a really good quality short throw projector, and it ended up in yeah, me creating an endless amount of video loops. My wife throwing it together in a live mixing in Resolume. There was also a learning curve, so I purchased the license Resolume Arena. No, the other one. It's proprietary. It's proprietary. It's very picky with codecs and alphas, so we had to learn a lot. But it ended up in very nice Friday night shows that we are allowed to join, because of lockdown you're not allowed to bring your friends over. And for the last minutes, how many minutes can I still show?
Yeah, we need to be wrapping it up a little bit just because we have a tight schedule this morning.
Yeah,
but,
thank you, Matthijs. So yeah. It ends up in shows like this. So I'm just going to tune it in until I'm being thrown out. Oh,
all right. Yeah. I think in the interest of time, we should probably call it there. But we've got some great, we've got some comments in the chat room. Like, my room is starting to spin. Yeah, there was one question there. Yeah, there was one question there.
I'm involved in very disorienting stuff. So also the VJ shows are mostly meant to, disorient and give people a good time. So I hope that showed a little bit of the versatility of Blender as a Swiss Army knife that's been used more often. And yeah, to learn to be more playful and creative with it again.
Yeah, it's awesome stuff. Thank you for sharing, David. And for those that didn't know, David Barron and Matthias were both part of prior World Blender Meetup Day coordinator crew. So we want to thank them for all the effort they put in. So at this point, I think I'm going to transition over to Daniel Bicet. Thanks, David. If you could mute up and stop screen sharing. And Daniel, are you on the line?
Where's my
screen I sure am.
All right. So for those who don't know Daniel, he reached, I think, Blender celebrity status after making some Blender EV demos, such as his EV Tiger and Goodnight Claire, which kind of captured us all. So, Daniel, why don't you do a quick intro of yourself?
Yeah,
describe what you do and what you're talking about today.
Yeah, I'm a senior character artist, and I've been like working in VFX for film and TV and doing cinematic trailer for games, like over, I don't know, 10, 12 years, something. And recently switched to game development 1 year ago. So now I'm working at Embark Studios here in Stockholm. And I used to work with, standard 3D softwares. And then I got interested in Blender back in 2015, 16, something. And I got sold big time. And then I contacted Ton and the crew at Blender. Name escapes.
Blender Institute.
Yeah, exactly. Blender Institute. Thanks. And just wanted to sort of pay back a bit. So I made a couple of demos and stuff for them. So that's been really rewarding for me to see that take off and stuff. And I'm here today to talk about general modeling tips, and especially like procedural workflows that I think that people that are new to Blender doesn't really perhaps discover so easily. So I will start sharing my screen. Let's see here. All right. Do you see my screen?
Yes. Yeah, it's coming through great.
Okay, cool. So yeah, this is an unfinished model, but one thing I wanted to show here is like these little red doodads or things. It's like how I made these. So I wonder if I can close that down. Oh no, how do I get rid of this stuff? Okay.
It's okay. Like classic demo gods.
Okay. Yeah.
All right, there we go.
Right. Yeah.
Right.
So I'm just gonna go ahead and like remove that for a second. So basically what I start out with is that, what you usually do when you do something like this is you just start doing a polygon thing and then extrude, but then you start moving all the other pieces around and they don't match up, right? So that's really cumbersome to keep track of and stuff like that. So what I do here is that I have just gonna create a little first off, I'm just going to duplicate this. And as you know, you can shift duplicate, which is just like a copy. But then you can also alt duplicate, which creates an instance. So the data, the polygon data, are both tied to these two objects, basically. So what I do is just select some vertices here. I'm just going to create a new vertex group. Call this padding 2. Then press Control G and assign to active group. And here's my modifier stack currently. So this is just like just a plate with no thickness at all. So I add a solidify modifier to it to just get that thickness, which is nice. And what I want to do then is add a mask modifier. And then I'm going to take this padding. So what happens here is that these will be the only thing that is left. And now I can create another solidify modifier like this. And you can see that it goes inward, like in the inverse direction of the normal. So I'm just going to set the offset to 1 so it sort of extrudes along the normal instead. So if I just reset the position here with Alt-G, it goes back to this position. Now I can just add a little subdivision modifier as well. Just gonna add some, take that red rubber material. Whoops. So you saw there that this piece also got that material, and that's not what I want, because right now the material is tied to the data of the object. So this and this is sharing the same polygon data, right? So what I want to do is change this so it goes, so it applies materials per object instead. Cool. So now we have that. And the interesting thing about this is now I can, like, if I move the first object, the red rubber part will just follow along. And I can start like, select these vertices and assign them to the active group. So get one down there as well. And then I can select these, assign to active group. So it becomes a very like non-destructive workflow. And I think this sort of stuff is great. Just like having objects that just tags along instead of keeping track of these two and have to line up this edge and stuff like that. Good. So the other thing I wanted to show you is working with decals as well. There's a lot of like different cool add-ons that you can use, which I guess is more streamlined to this workflow. But I'm just gonna use like vanilla Blender for showing you how to do this basically. So what I have is a, let's see, decal source. Yeah. So I have this texture. So this is just like flat object modeled in Blender and just rendered from a orthographic view into a texture. And then I can like just have some a grid like this, which has a couple of like divisions, and just duplicate that, match it into some shape that I like, perhaps that one. And you see it's black, and the reason for that is that the shader is currently using the vertex color. Oh man. You see here? So this is the vertex color, and we can find that down here. So see, it's looking for that attribute basically, and it's missing here. So what I need to do is go into vertex paint and select some color. Let's do a off-white kind of thing. And now I just filled it with, I think it's like Shift K. It's muscle memory, everything. So here, vertex color goes in here and into the base color of the shader. And now I can just add a shrink wrap modifier. And this is one lovely feature of Blender, is that you can easily snap, as long as like your object is modeled so that it's facing in the positive Z direction, you can snap this to the surface of other objects like this, and also like align rotation. So that's great. And in combination with the little shrink wrap modifier, so here just picking my target, selecting this, and you can see it starts intersecting, right? Because they have different density in vertices. So then I just do a little offset like this, and make sure it's outside of the surface. Shade smooth as well. So that's like a very simple and yeah, fast way of texturing your model, basically, like fake texturing. Because now I don't really have to texture paint or something like that, and it's like it's nice to just use as a way of planning how you're going to texture your model and stuff like that. Yeah, so I had other stuff as well. Let's jump to this sci-fi thing. Let's see here. I built this little guy. So here's something I really wanted to show. Let's see here. Just gonna check my notes. Yeah, panels. So one thing that is really tricky, generally in hard surface design and modeling, is to keep like a continuous smooth shape like this, but doing cuts. And the normal way that people do this in other 3D applications is that you have your, some type of object, you have some subdivisions, perhaps two, like that, and then you start like cutting into your model. You say, oh, I'm gonna have like a door here or something, and then you do, yeah, delete that, and then you start pushing and pulling stuff, and oh no, it's not lining up anymore, and then you have to go like and it's just horrible. Why would anyone want to work that way? You just don't. So then you use Blender instead, which is great for this kind of stuff. So I'm just going to show you the modifier stack here. So this is the actual topology and model of that object, and it doesn't look much to the world, but those panels, like when everything is turned on, I have these panel that goes here, but the nice thing is that it's all procedural. So if I smooth this, every vertex is like sitting, is connected to each other, right? So no proper cuts. So what I have done instead is actually using the what's it called, the mark sharp. So that's basically a way of tagging edges to tag them to say like, should this edge be shaded as smooth, like in this case, or should it be shaded as sharp, as in this case? And then I turn on an edge split modifier. And right now we don't really see what it does. Nothing seems to happen. You can see here that I had using sharp edges. But then I turn on a smooth modifier, and then I start smoothing. And now you can suddenly see that the procedural result of the mesh is just like it's doing these cuts. And then I just add a subdivision to this. You can see, oh, here I got some gaps. Wouldn't it be better perhaps if I just move this up a bit? Slightly. This is probably due to the fact, never mind. We'll just ignore that for now. So then I just have a mirror modifier as well. I guess I was modeling on this side. And then, what the mirror modifier does is that it just mirrors the object. So I could perhaps add an empty instead, call that Origo. And then if I use this locator as a center point, we'll see what's happening. So it just, doubles the model basically. And looking at topology, so like if I start rotating, some really interesting stuff happening, and it's all to the bisect So if bisect is off, it just duplicates the geometry on the other side of the axis that I've chosen, like from positive x over to negative x. But if I press bisect, it will just cut the model in half first and then duplicate it over to the other side, which is really cool. Whoops. I should go back a bit. Okay. Now, then I'm using this mask modifier. And that's something I used before on that other model, right? So if I have, so here I'm using a vertex group called mask. So we could just inspect which vertices those are. So it's these. And whenever I activate the mask, it will procedurally remove all of the polygons that are connected to these vertices. So just turning off, let's see, like that. So that's cool. And then I use the solidifier. And so solidify just makes sure that there's a depth to the shell. And by default, it has only rim off. So it creates all these faces on the inside as well. And that's kind of like, if they are not visible, they're just taking up memory. So I'm just gonna just not use that. And then we have bevel angle. This is just filtering out all the edges that has an angle over 69 degrees. So I think like per default it's 30. And what I don't want is like things over here might have, like if I drag that down very low, it starts beveling these edges as well. I just want to bevel those sharp corners. So yeah, turning on and off just for visibility. And I have some weighted normal going on as well. So that can sometimes just fix some shading issues and stuff. Cool. What was the next thing? Cables. Oh yeah. This is also great. Like all of these cables are just, this is just one curve, really. So if I want to, and I just love working with curves in Blender compared to other applications. So the way I created these cables are just creating a path like this. And then I have this thing. Let's see if I, this is basically the extrusion shape. Let's see. Oh no, I start forgetting which is which. Oh yeah, bevel object. Okay. So you have to go to bevel object and then pick that shape. And it just, nice, copy the material as well. Select this one, Control L material. This is so easy to work with. It's like magic. And yeah, so another really great thing is the twist as well on Control T, where you can just start twisting cables like this. So it gives it a bit more like personality and stuff. All too easy. Yeah, so that's just how these cables are set up. What else? Snapped surface and align rotation. I think I covered that, but let's just talk about it for a second. So these little things, I'm just going to duplicate this and show you a bit. So when you have a very curved surface, like if I snap an object to that curved surface, and the new object has a flat base, it's not gonna match up to the curved surface that you want to snap to, because there's gonna be gaps here and here, right? So what you can do is add a vertex group on the lower side, and then yeah, so that goes here. Just select these vertices and assign them to their vertex group. And then just add a shrink wrap node. Sorry, not a node. We're not in Houdini. Blender. So then I can just pick this surface that I want to snap to, and then I can be like super sloppy with how I place it, which is, yeah, it's just really nice. And then some bevel just to catch those highlights. We have more shrink wrap vertices group to surface. Yeah, I think we got that. Here's just like another helpful thing, I think. Like this little neck thing I did. It's nice to, sometimes when you model, you're not sure how you want to position stuff. And then just doing some simple, almost rig-like things can help you with that. So here, I've just used a hook modifier to the head. So just selected this boundary edge loop, and you can select something first, and then select this. Oops. And then you just press Control H, and then you got a hook sort of thing. So you can select hook to selected object, and now it remembers this offset that was when you assigned that hook as well. Yeah. Let's see, what do we have more? I got 5 minutes. Let's make it, yeah. And oh, I can show you here as well. Like, it's always complex when you need to mirror a lot of stuff. What I usually do when I'm modeling is just put all the stuff that I want to mirror over to the other side. Just put that in a collection, and then so that collection is called mirror stuff. So then I can just add Shift A and add a collection instance. So mirror stuff here. So a collection instance is just an instance of all these objects that exist in the collection, and it's using the origin of the scene as the origin of this new object, right? So now I can just reset the location, hitting Control M to mirror, bam, over to the other side. And then when you want to, later on, you can convert these to real objects. And so that's in the Control A menu, and make instances real. So then they would be instances to, like, this object would be an instance to this one. 3 minutes. Will I be able to do the wheel as well? Let's see. This is so here we got our little friend again. So he's just a collection instance from that other scene I was working on. And here is a procedural wheel. So yeah, doing this kind of setup is really fun. So I'm just going to show you real quick, if I'm able to, how I did that. Let's see, the wheel. Right, okay, yeah. Gonna start with these things. Okay, I'm just gonna go to the first frame. I got it keyed like this, so it's a bit easier to see. So I'm just gonna turn off all the modifiers so we can have a look at how it works. So this is the model, and this is the base of the wheel. So it first has a mirror modifier with bisect in the axis positive C. And then I just create an array like this. And this array, we could break that. Delete the driver. So just basically create new copies of these and using the constant offsets. And the reason I'm using constant offset is that I want to have the same offset on this object, but also on this object as well. Otherwise, it's going to use the bounding box of the object, like if you use relative offset. Then we have simple deform. It's just a bend, really. And the cool thing is that when you increase the count of the array, it will just like adjust itself to the bend. So it's always 360 degrees from this point. Okay, and then I have none of these pieces are welded yet. And you can actually do that in the array, but then it wouldn't align the first piece with the last piece. So I do that with a separate modifier afterwards. Then just a normal solidify modifier. Like that. And then just use bevel based on angle and a subdivision surface. And then it's just basically the same setup with this one. Simple deform. Now here we see an issue, right? Because now this array does not match this array. So the cool thing is that I can just right click and copy as new driver. So that's the count on the array module modifier on the wheel here. And I'm just gonna like, oh, it's keyed. Probably, I know I'm running out of time. Just gonna show this.
Actually, Daniel, I was just gonna mention, so we're still waiting on our next speaker, and people are really keen to hear more. We're getting comments like, great stuff, Daniel. Cool trick. What? Another great trick. You make it look easy. Donna biscuits. Yay.
Yeah.
So why don't you keep going until our next presenter joins.
Excellent. Just stop me whenever. Okay. So cool. Then I can breathe a bit. So what I did was selecting this. So I will sort of treat the base of the wheel as my driver. So right click this, copy as new driver. So for you people coming from like Maya, drivers is like the ultimate combination of set-driven keys, expressions, and channel connections. Now I just need to go over here and paste that driver. And now it's just like, yeah, just copies that value from the other thing, which is great.
Great. And I see our next session presenters join, so maybe just finish up the one last thing.
Yeah. And then it's just a shrink wrap, solidify, and a bevel on top of that. All right. Okay. Thanks for having me. This went by much faster than I expected.
30 minutes is not a lot of time, but
Yeah.
it's really clear that, all the people that are watching right now are really enjoying the session. So we want to thank you, Daniel, for joining. I've put your social media links in the chat, and also a link to your ArtStation so people can
cool.
find more of your work. But yeah, it's been a real pleasure having you. And
yeah, it was. Thanks for inviting me. You guys are doing a hell of a job. I can't understand how you are able to run this 24 hours.
caffeine and baton passing.
Yeah.
Secret there. So, all right. Well, yeah. Enjoy the rest of your afternoon in Sweden, right?
Yes.
Yes, in Sweden. And yeah, we'll maybe catch you on the next year's one.
Yeah, absolutely.
Cheers.
Okay.
Cheers, Daniel. And so at this point, I'd like to welcome Dimitar. Dimitar, are you on the line? If you are, you're muted. So Dimitar, and I'm not sure if I'm pronouncing your first name correctly, I'm sorry if not, is joining us from London, and he'll be presenting on Blender for architectural design. Take it away.
Can you hear me?
Maybe introduce yourself, your connection to Blender, and then what you'll be presenting today, and go for it.
Yeah. Hey everybody, my name is Dimitar, and yeah, I'm a Blender user for quite a while. I use it for architectural design. I'm an architect based in London, temporarily in Bulgaria because of the whole lockdown thing, but it's actually a good thing for now. So yeah, I'm really excited to show all the different ways that I can use Blender for architectural design. And really one of my passions and my goals is to show more of the architect and designer community the possibilities with Blender, especially small to medium-sized practices, because we kind of get locked into the subscription packages. And it's not only the companies, but it's the education resources as well. So the new students coming in, they only know these things. And I think that's the only thing they can know about it. So I'm really on a mission to show all the ways that Blender can be used for architectural design. So let me share my screen here.
I'll let you know when we can see it. And yep, can see your slides.
Cool. Okay, yeah, so as I mentioned, this is about Blender for architectural design. I'm Dimitar. I'm a US registered architect, and you can visit uhstudio.com or my YouTube channel, UH for more information. So just a little bit about me. I really love architecture and design and how it can transform any city or any area in the city. It's funny, I think most people, we have like a love-hate relationship with our profession. For me, it's like every 5 years I have to reconsider it, and then I'm like, wow, I mean, it can really change lives. So I'm quite passionate architect. At the moment, I'm working as a project architect in the UK, on projects in the UK and worldwide. And I typically work on medium to large projects. And the typologies consist of mixed use, so residential, hotel, and office, high-rise, cultural, arenas, and urban design. And I tend to work typically on earlier phases of projects, so I'm quite design-oriented. So with architecture, we have the design-oriented profession and then the sort of construction-oriented part of the profession. And London tends to be like a global architecture hub. So a lot of the practices that are London-based, we sort of do designs all over the world, especially the Middle East. And then we have local architects that help with the later phases of the projects. So if I can quickly describe myself, HOK is the company I'm currently working for. It's a global architecture firm. It's an American firm, and we have offices throughout the US, London, and Hong Kong. I also have Studio. That's my own brand. So it's very experimental. It's the things that really want to scratch the surface. It's the things that I'm really passionate that sometimes at work I don't get to do. And with that, there's also Studio Design Academy. And it's really teaching about architects how to think and do. And I'm actually focusing quite a bit of energy at the moment at Studio Design Academy. And then of course there's life, right? So dad and a husband as well. So I mean, as many of us know, it's really hard sometimes to juggle all these things together and which one gets more and which one doesn't. But that's in essence who I am. So my idea for today is to really quickly run through a couple of examples that I've done with Blender all over the place, really, and then show you a super quick demo on like the typical design process. There's more videos on YouTube and things that show it better, but I just want to show you in a gist what can be done. So yeah, so here's some examples. Here's some more examples. These are from A3K project. So arena early concept, and then actually the this is being built at the moment. This is Abu Dhabi Arena, Etihad Arena in Yas. So this is from like 5 or 6 years ago. Some images. So all these things are designed with Blender. I should say. Actually, these are not designed with Blender, but they're represented with Blender. Although with the section where we're thinking about the skin with this tool, and all these spaces were also designed with Blender. This is actually just doing modifiers. This is for competition, and this is a theater proposal in the UK. Now, recently I've started thinking more about how I can show architects in the typical architectural language, you know, which is a lot of axon diagrams. So I just released actually a video on this. This is coming up shortly, so video series coming up soon. And this is a personal project. So one of these UH Studio projects, I actually cycle by here every day in London, and it's called Little Venice. And there's a little island that I always thought would be nice to put some sort of tower. So I put one in there. So you can already see the architectural concept live, and I'm gonna have a more broken down process of how I actually did this image with Blender coming up. And then I've also started releasing some courses. So there's a course that really takes like a step-by-step process of how Blender can be used for architectural design. And so the difference between design and visualization, which is what we see on one side, is that with design, we actually, let me take my breath here. Actually, we have to really think about the space, right? We have to think about the scale, the space, and all these kinds of things that usually with these kinds of images, we don't understand that, right? So the architects, as architects, our first step is this really. Actually, a lot of these drawings, they get sent off to different companies. There are very few architects that actually can do good visualizations. And this is not the best by any point. I actually sent this to a friend of mine who has a rendering agency. I always check up with him on images. And he was asking me, did you pay for this or did you do it yourself? If you did it yourself, it's a good image. If you pay for it, it's a bad image and you got ripped off. But anyways, I will have a course on this as well, because I think it is also important for architects to sort of learn how to visualize our ideas, how to represent our ideas. So that's it for the presentation, really. And now I just want to take you really quickly on my typical design process. And I'm taking a few shortcuts because I am mindful of the time, and it's going to be a very quick overview. But essentially, we always start with a sketch, right? And typically the sketch has some sort of constraints. In this case, we will not worry so much about the constraints, but I'll show you my typical process with Blender. I always put a little person for scales, just so we know the kind of project that we're doing. So this is a tower. It's not a tower, it's too short to be a tower, but let's say some sort of culture building. Let's call it a library, right? So it's got 3 parts and it's sort of stepped down, and maybe there's some light that comes down from these sides. And let's now jump into Blender and see what we can do with it. So again, in Blender, I also cheated a bit. So I have a context kind of already lined up for this, and it comes from a recent file, just so I can focus a little bit more on design and show you the typical design process. Let me turn on my screencast keys. Okay, so the first thing I always do, and now we have our lovely primitive tools, we can actually block it out with the primitives, is starting with blocks really, and just thinking about like what the shape is that we're trying to represent, how big is it, like where does it go. And it's really important in architecture to always do that with a person in mind. So when I don't have a live person, I just make a sticky dummy figure really quickly. So let's delete these vertices, extrude this 1.8 meters up. And now let's make it just a bit skinnier. So 0.4. So there's our scale figure. It's the most important. It's the most important thing for architecture. And I think actually a lot of artists can benefit from that as well, because if we don't have the right scale of our image and understand like floor to floor heights and things like that, then the whole thing can get thrown off. Okay, so with these 3 boxes in mind, the first idea is always to have an idea of the shape, of the concept, of how big it is, the proportions of the space, thinking about like where a main entrance would be. So it's a lot of these kinds of things. And let's say that we're happy with the massing right now. So the next step is to actually rebuild this completely. So I'll start with a plane and scale it up. And the idea is to now start to rebuild this with a little bit more detail. So then the next step is to subdivide that. And let's get rid of now our cubes. In fact, do we want to join them? Yeah, sure. Let's join them into one and say concept 01. So how much time do I have? 15 minutes. Cool. Awesome. I'm tend to be a last minute kind of guy, so I like the pressure. So let's see what we can do here. So now with these 3 elements, let's select our faces. We'll just extrude. Let's take these 2 now here and extrude again. And let's take this and extrude. So I don't think this is a library anymore. I mean, it's pretty big to be a library, unless let's make it a little bit smaller maybe. Actually, I'll take the whole thing. Let's snap to, where should we snap to? There. Put our cursor there. Use our lovely 3D cursor. Select the whole thing and now scale it down. Okay, maybe it can be with nice little trees on either side or something like that. And I think I want to make it smooth. So we're going to be using subdiv for this. And I tend to use subdiv quite a bit. And for me, that's the idea of Blender in Blender that shines. The typical architecture software for 3D design, for more design-oriented objects is Rhino, right? We have SketchUp and we have Revit and we have AutoCAD and all these kinds of things, but Rhino is the one that allows you a little bit more free-form shapes. The problem is that Rhino is NURBS, and with NURBS, you sort of start with like lines and then you have to extrude, and it doesn't work as well as having a box and then just turning on the subdiv modifier at some point. So I think I want to kind of step it in another direction as well. So let's get rid of some faces here. In fact, let's get rid of all the bottom faces. So if we step, 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 so we can get rid of a lot of faces here. So let's get rid of these and these. So yeah, we're going to step from here and then we're going to step from there. It's going to be nice. So let's extrude that down. Let's join these. At first or last, the other way around. At last, make a face here. So what do we want to do here? Let's extrude this face. Oh no, we don't want to extrude that. Let's extrude this face. At last. Is that right? Yep, that's looking the way I wanted to. Extrude this. So yeah, I mean, most buildings, when you think about it, especially when they start out as a concept, they tend to be pretty simple. So now let's do our subdiv magic, and it looks like a shoe, or I don't know what. It doesn't look good. So let's start adding some loop cuts to start kind of tidying up the shape. We can either use loop cuts or smooth edges. So now let's look at it in the context of the size of our person. And I'm going to sharpen this just a bit. And these probably here a bit too sharp. So let's move these back slightly. And actually this step is a little bit misunderstood. To get even a really simple building looking good takes a huge effort. So, you know, in 15 minutes, we won't get this to look perfect, but hopefully you get a sense of the typical process that we sort of go through as designers. What can we do here to make this seem a bit cooler? Maybe this wants to be shifted quite a bit down that way. And how about, we have a lot of loop cuts there, so we can't do it. But on this side, how about we start to shift all of these down? So maybe we get that whole row. Got 12 minutes. So it sort of like slams down. Yeah, so from one side, the building looks huge, right? From the other, it looks a little bit more tame. So maybe here we have to have like some sort of big trees, or the neighboring buildings are quite large. And on this side, they're a bit smaller, you know, so maybe residential. So the context maybe is not, what if we turn the building around? We have some shorter buildings here and some longer buildings there. And then let's select everything and sort of scale it a bit. Let's see, how does that look? Now, the thing is that this is a bit too fat for a building, but it could work actually for a theater, performance venue of some sort. Yeah, so that's what we're doing. A performance venue. And actually that works quite perfect, because in performance venues, in theaters, we need to have a tower at the end. And that tends to be a taller object. In some theaters, it's quite an ugly thing, you know, they just really like extrude a box up. But in here, let's make it a bit more sculptural. Sort of like that. And now, so if that's a theater, that's back a house, that's where people are sitting. So this is our entrance. So with that, maybe we just want to pull it up a little bit. That's starting to look all right. I kind of like that with one angle sort of pulled up. Let me get rid of this edge, and let's do the same here. Why don't we pull that up? Let's get rid of this edge. So we kind of have that rhythm going on from all of them. So let's get down now. Now, the thing that I love about Blender, I mean, we're all Blender lovers here, but sorry, a bit nerdy, is being able to set up cameras and being able, oh gosh. All right, so I think that was it. My Blender crashed. And did I save my file? Maybe I did. Let's see if I can recover it really quickly, but I'll keep talking for a second. But the thing that I love about Blender is be able to adjust the user interface. So we can get all kinds of different views when we need them to. I tried to do that and now it crashed. I think I just installed a new NVIDIA driver today, so maybe that was the reason. Let me go to my local files really quickly.
In the meantime, we have an adorable picture of your kids, which is wonderful. Hey, while you're bringing it up, just a couple of comments and questions we're getting from the Teams chat. So we've got a bunch of complimentary compliments from people like Epic Spaces, Bravo, really good stuff. Go Dimitargo, I'm your biggest fan. The curved wire trick is fantastic, incredible. And somebody asked, have you tried the Blender BIM add-on for architects?
I have not. I know about it very well with Mode. Mode sort of set up OS architecture, which is a great community. But actually, I really haven't tried it yet. I'm still maybe one step before that, where I'm learning how to do. Let's see if I can find my Blender file.
Yeah, no worries. And
nope, it doesn't seem to be here. Anyways, so forget about that. You saw a little bit of the process. Let me bring up the presentation again. So I have not tried Blender BIM yet because I have a huge list of things to do. So one of the things that's on my list right now is FreeCAD. FreeCAD is an excellent piece of software, very complementary to Blender in many ways. And for me, it's actually important for small. It's complementary for smaller practices as well, because maybe Blender BIM does provide a lot of documentation, but we still need like a traditional package where we can itemize everything. So I believe Blender BIM probably does a lot of that, but FreeCAD is the one that I think has more of that tool set that sort of replaces Revit. And Revit is a sort of a BIM software that we typically use in architectural design.
Great, thanks.
Yeah, I think I changed my temp folder location at some point, and I'm not sure where I put it, so can't find my file. But that's all right. I think you guys got a sense of it. I was gonna basically insert a few loop cuts in there and start to open up a space and then do a really quick render on it. But my computer thinks otherwise.
No worries.
Does anybody have any more questions?
Just a bunch of more complimentary stuff, like you know, Alessandro says go Dimitar.
Thanks, Alessandro.
Yeah, Blender couldn't handle your praise. Blender got excited. But no problems at all.
Okay, I found my location. Oh, maybe it saved it. How much time do I have? I have 5 minutes. Let's see what else I can do in 5 minutes.
You have 6 minutes.
Nope.
And like if we run a few minutes over, that's probably fine.
The file saved, but the building is not there.
Oh dear.
Oh, it crashed again. Anyways, things happen like that, as we all know. I was actually having trouble because I was trying to save my file beforehand, and then, yeah, every time I saved, Blender would crash. So that's why I restarted my computer right before the presentation. I was hoping it would fix the issue, but sometimes it doesn't. Yeah, so I'm actually really excited about this video. So I just finished this space, and that's really cool space when you think about it, because if you see how small the people are, and they sort of go through this, and there's a waterfall. So I had a lot of fun designing that. And of course, this is all done with Blender. It's going to be a 2-part video series because it couldn't fit in one video. I mean, I tend to make videos less than 15 minutes. I think in UT people, they don't watch it that long. So quite excited about that. And yeah, diagrams
can you go full screen on your slides?
And with Blender. Oh, yeah, that's a good idea.
There we go. Thanks.
Whoops. Yeah, and with this space, I can talk about this forever. And this was a lot of fun designing, actually. This was just free-form design. I mean, there's some logic about the actual design. It's actually related to my thesis, where a lot of these are synthetic fibers. They're dipped in resin. And so it's actually a really lightweight structure. And that's why we have like a wooden stair to sort of like act as a beam to hold it all together. And that's why it has to be sort of porous, because if it's so lightweight and there's wind, it's sort of, you know, going to blow it over, but now sort of the wind can pass through. So it doesn't require as much energy and a strong footing to ruin the context.
We do have a question in the chat. Is Blender used by other colleagues at HOK?
Yes, I teach him, but not only that, we have a really kind of cool global design tech team, and they sort of look into alternative ways. I mean, one of their priorities is saving money as well, but not only, they're explore tools. So, I mean, these guys, all they do is like explore different ways of using new tools. That includes absolutely everything you can think of, right? So Blender is definitely one of those things. They use a lot of Unreal, Unity, and so many other softwares that I haven't even heard that are quite specialized, right? There's one that's called TestFit, which helps kind of shape buildings with algorithms. So it's useful for like really early processes. But in London, I also teach my colleagues. So whenever I have a team, we usually, we have like a lead architect or lead designer, a very senior designer, project manager, and then we have a junior staff. So whoever's working with me, they basically need to learn Blender. So I basically teach them. So I've taught quite a few people to use Blender.
That's great.
And
there's another question.
They're quite happy with it.
Yeah, so somebody asked, to use Blender in your everyday work? It certainly sounds like it.
Yeah. So my everyday work is pretty much Rhino and Blender all day, back and forwards between the two. I don't talk too much about Rhino because there's a lot of people already talking quite a lot about Rhino. It's amazing. And the McNeil guys, they actually, they're really cool and down to earth. And they organize a lot of events like all over the world, like in London, Barcelona, Seattle. And the nice thing is that they're not switching to subscription-based software. So I always think, if architects need to start a company, the only paid software they'll probably need is Rhino.
Excellent. All right. Fantastic. Well, that's it for the questions in the chat.
All right.
Is there more to your presentation, or are we all good?
We're all good. Yeah.
Okay.
I was really hoping to do a live demo in 30 minutes or 20 minutes or whatever it was, but yeah, I'm not going to try it again now.
I know it's tough. Well, next year at next World Blender Meetup Day, we'll give you a full hour. How about that? And I want to thank you. I want to thank you for joining. I've dropped all your links in the YouTube chat. So if people want to go find more of your stuff there, if you have additional Blender tutorials and stuff, they can always find you out there. But I want to thank you very much for joining. It's been an excellent session.
Thank you. And thank you guys for hosting it, and yeah, for doing your marathon run. Appreciate you. And appreciate you inviting us.
Of course. Yeah.
Cheers.
Have a great rest of your evening. We'll see you later.
Thanks, you too.
Bye now.
Bye.
Okay. So at this point, right on time, I'd like to welcome Jason Van Gumster. Jason's going to be talking to us. He's joining from Atlanta, talking to us about studio workflows for individual artists. Jason and I were just talking the other day about how we've been drinking beers together at past SIGGRAPH conferences. Fun fact, when I started Blender about 10 years ago, it was Jason's Blender for Dummies book that got me started. And I think there's still some version of the book's recommended project folder structure in my workflow that lives on somewhere. So welcome, Jason. Go ahead and introduce yourself, what your interest in Blender is, and kind of what you'll be talking about today.
Yeah, I can talk about all sorts of fun stuff. Yay! And I had a different webcam set up, but that one for some reason wasn't playing nice. So now we're slightly sort of sepia toned.
Yeah, it's good. It's very retro filter. I love it.
Yeah, well, I mean, it's a retro camera. I think this camera is probably 12 years old. But so yeah, I get to talk now. Yay! Let me see here. I have screen sharing to make. Let's see how well this works for me. I'm doing this through fun things. Share. Can we see that?
Yes, we can. And if you can move the mic any closer to your mouth, that'd be great.
Hello.
Even better. Yeah. Thank
Perfect. You. Not to sound too grotesquely sultry or anything, but all right. So this is talking about collaborating with yourself, trying to involve studio workflows for individual artists. That's sort of the idea here, because well, we'll get into that, because that's what this whole talk is actually about. And just to give you a sense of it, I should probably put my mouse on the right screen. Hi, how you doing? I'm this guy. This is me. Video and photo of me doesn't get out as much nearly as this particular picture. So that's me. I'm Jason Van Gumster. I have been kicking around the block with Blender for quite some time. I'm the author of Blender for Dummies. I'm the lead moderator on blenderartist.org. I started right-click select, and I still moderate it I need to moderate it slightly a little bit better, so you can kick me in the shins about that one if you feel like it. And I have this itty bitty podcast called the Open Source Creative Podcast that I have an episode that I've been sitting on for a while, and I really need to get it out, and I'm apologizing now for that. But yeah, that's what I've been up to. And recently, I've started working with some stuff with CG Cookie, but not quite yet. I'm just a little bit nervous here, because it's been a while since I've talked to people, been sort of locked up for a bit. So we're just talking, we're having fun, we're having a good time. But what we're getting at here, we're talking about collaborating. But you might find yourself saying, I just work for myself, or I just work on my own projects. I don't collaborate with anybody. There are, I mean, I'm judging from here, there are people here who are working by themselves, and there are people who are working with other people. But even if you're working by yourself, or if you're in a studio environment, even more so, but especially if you're working by yourself, it's not true that you're not collaborating with nobody, because you, current you, are collaborating with both past you and future you. And I guarantee you that at some point in time, current you has cursed out past you for not thinking about future you. Think about that one for a second. Yeah, yeah, there we go. Yeah, so what it comes down to is, if you don't set yourself up with good practices, if you don't give yourself good structure, what's going to happen is, I mean, a lot of the stuff that we do in 3D, we're reusing stuff. Sometimes we're doing little one-offs here and there when we're having fun, or doing a weekend challenge or that kind of thing. But if you're doing serious work, oftentimes you're doing stuff that's going to be reused. And if past you wasn't kind to current you, you're going to be cursing it. And so you should really be nice when you are past you, to be nice to future you, so they don't yell at you in the past. Yeah, I'm doing a lot of time travel talk here. Hopefully that makes a lot of sense. But the long story short is, when you're working on a project, you come back to it a month later, a week later, a year later, and you look at your file like, oh no, where were my rig controls? What were they supposed to be doing? What was my model supposed to be doing? How did I even think about setting up this node network for my materials? I am in a world of hurt now. And that's the moment right there where you end up cursing out past you. So let's be nice to future you. That's what this whole talk is really about. So one thing I like to talk about, I am a gigantic proponent of version control, and it's not just for people who do software development. So if you're not familiar with it, the whole idea of version control is like a save state. So imagine you're playing a video game, you get to a save point, you save, because you have no idea what's going to go happening in the next door, and you might die. So you save at that save point and continue going forward. Your 3D work, your Blender work, is exactly the same kind of thing. If you're going to have yourself working on a model or a rig, and you're like, I want to make this change, but I'm not entirely sure that that's the change. It's going to look good when I'm done. And maybe I'm working destructively. Maybe I'm sculpting. Maybe I'm not working with geometry nodes or those sort of things. I'm going to work a little destructively, and I want to play with it. You kind of want to give yourself a save state, a place to go back to where this is before I screwed everything up. That's what version control is helpful for. Now, we've got a couple good things here. Blender actually has version control built into it. It's very naive. It's very simple. But you ever wonder about those little blend one files? This is a little bit intro stuff, but bear with me if you already knew this. If not, I'm going to blow your mind just a little bit. And I'm pointing at a camera that you guys can't see me pointing at, but it's going to happen. In any case, so the blend.1 files are Blender's version of simple version control. Here's the way it works. So when you save a file, it's myproject.blend. That's your most recent save. That's your first save. So I work on it a little bit more, and then I work on it, and then I save again. Well, what happens is myproject.blend gets copied to myproject.blend.one. That's your previous save, and then your current save is myproject.blend. And then you save again. You could, it's not set up by default, but you could have blend.2, or sorry, .blend2, .blend3. This is an automated way of, and we've all done this, my version 1, my project version 1.blend, my project version 2.blend. So now if you end up doing that, you end up having your own personal naming convention version control and Blender's built-in version control, and it can get really annoying, and you have a bunch of superfluous files floating all over. Just use the one that's built into Blender, or turn it off. But that's the built-in version control that Blender has. And if you run into something and you screw up, guess what? You automatically, the last time you saved, that was your save state. You can always roll back to your blend 1. Or if you want to go and have more blend, you could actually set up 32 different versions of incremental saves if you wanted to. I'm going to show you how to set that up this way. So you're here on Blender, and I'm running Blender on a sort of a machine with an Intel video card. So I'm not guaranteed that it won't crash on me. So I'm going to just do it with slides here. I got a couple of the things later on where I'm going to experiment with actually using Blender on this machine, but we'll get to that in a second. This is pretty easy. All right, you're in Blender, you jump over and you open up your user preferences, drop on down to the save and load section here. Look here, say save versions. See that one? That's blend 1. You can easily set that all the way up to 32 if you feel like it. Upside is you get 32 individual save states. Downside is you get blend 1, blend 2, blend 3, blend 4, blend 5. So it's a very sort of naive way of doing version control, but it's better than nothing. And it's automatic. It happens. If you slide that up all the way to 32, you're going to have a lot of hard drive space taken up by this. But hard drive space is basically cheap. Your stuff you're creating, that's harder to replace. Use the hard drive space, get your versions through. Now, that said, maybe you want to have something slightly more sophisticated. Now we're starting to talk about tools that are more akin to what software developers use, and they're very, very handy. My personal favorite happens to be Mercurial, or HG, because Mercury, HG, they like their puns. So Mercurial is a distributed version control system, much like Git. These are things that are typically used for software development, but you can use them for your art. I actually prefer to use Mercurial over Git simply because, one, Mercurial handles binary compression slightly better than Git. It's not great, not perfect, but it's slightly better than Git. And also, I kind of like the interface with Mercurial a little bit more. Git has this this explicit staging area, so every time you want to commit, you have to say which files you want to add to your commit session. It's one less step, and I'm lazy. It's one more step and I'm lazy, so I like to go with Mercurial. Plus Mercurial is built in Python and I know Python, so if I want to play with it, I can. But Mercurial and Git aren't the only thing. In a lot of studios, you'll see people using Subversion. Subversion has actually been around for a long time, and it actually has, I would say, superior binary compression than the other two. What it isn't is decentralized. So the problem is that if you're running Subversion, unless you do some really, really interesting things, you basically have to have Subversion running on a server and you're checking things in and out from there. Now it has a bunch of flexibility that you don't get with a distributed system like Mercurial or Git, but those are some key parts in that. And if there's time at the end, which I'm already 10 minutes in, so who knows how much time I'm going to have at the end of this thing, but if there's time at the end, I can actually go into some detail about each of these things. Of course, there's some closed source things like Alien Brain and Perforce that you can play with. Now here's really the advantages of using proper version control versus naming your files, my file version 1, my file version 2, my file version 3, final, plus I promise really it's final. Don't tell me you haven't done that, because I know everybody has. So the advantages of that, especially even over Blender's automated system, is you have one file and you have many versions. So the idea here is that you have a file and the version control system, Mercurial, Git, Subversion, whatever, will track the changes on that. Just like if you're in, I won't say just like, but similar to like if you're in, say, Microsoft Word and you turn on track changes, the database understands, the version system understands that this file is different from the last time you messed with it. And you can either roll back to the earlier version, or if you commit or push it in, then you have saved that state. And the other really cool thing, and I don't actually have that as a slide in here, is that one of the biggest advantages of a proper version control system over, say, an implicit one like what Blender has built into it, is that you take notes every time you commit something. So this is my save state. These are the changes that I made, and this is why I made those changes. Future you will be very happy with present you if they can look back at your notes a month later and say, hey, oh, that's why I made that change. And that's, that makes a lot of sense now. I will be able to remember that. That's one of the best reasons for doing that. The other reason, which is a little bit more, I will say, software-y, but it's actually pretty useful, is branching. So say you're working on a model or a rig or an animation. And you say, all right, the character, let's talk from the animation perspective. The character could move this way, but maybe this character wants to have this other kind of flourish. And I want to be able to look at both of them, and I don't want to have two files for it because that's annoying. I want to have one file. Well, what you can do is you can take your file and you can branch it. And so from the version control system, you can say, this file, I'm branching it, I'm working with it, and this is, you work on it, you take that technique, that animation, that character movement as far as you can go, and you're like, hey, okay, I kind of like that, but I still want to explore that other one. You can roll back to before you started animating that particular set of the scene, and then go down the other road. All right, how does this route look? You pick one you like and you continue down that branch, or merge them together if you really feel like it. But branching is one of those things where, again, if you use the video game analogy, you come up to a save state and you've got two paths you can go down to. Or if you're old enough, you remember Choose Your Own Adventure, where you had the book and you're like, oh, I can go down to this page or go to that page. Which one am I going to do? Well, you can read both and test them out. That's what branching is really all about, and really, really handy from that. The other thing, of course, is that it's easier for collaboration with other people. If you have, especially if you have something like Subversion, where it lives on a server somewhere, but even with a distributed system like Mercurial or Git, it allows you to collaborate with other people if you're into that, right? So if you're not, if you're an individual, then that other person is going to be you. But if you're working on a larger project, like an animation or a game or these sort of things, then version control is going to give you the tools you need to work with other people. Because again, if you're taking notes every time you make a change, not only will you thank yourself in the future for making those notes and making sense of what you're doing, but somebody else coming into the work is like, why did he do that really dumb thing? Oh, that's why. Okay, well, I still think it's dumb, but now I can change it and make my own notes. That's one of the really nice benefits of these things. Those are like the core tenets of version control, and why it's, I think, really, really handy to try to integrate that into your own personal workflow. And I'll probably, that was my dog, he agrees with me. Uh, I'll probably end up making some sort of tutorial about this, because I'm very passionate about version control, because I think it's important to be control of your data. But version control is not the only thing you can do to be nice to future you. You could use linked assets. Now, we all know, hopefully, that you can append from other blend files into Blender, but you can also just link, and this is a pretty common workflow. So what you end up doing is having some kind of reusability. Again, especially if you're working on larger projects, or you have a character that has to be in multiple scenes, or you have a prop that has to be in multiple scenes, these kinds of things, you want to be able to take them in, and maybe you don't want to make the same change in every scene to that one file. That's destructive and painful and annoying. So what you can do is use linked assets, especially for larger projects. So your basic version of how to link. Well, I'm going to show this. I only have 15 minutes. We'll see what I can do. All right, so here's what linking looks like. All right, I got this funky little thing here, and it's already set up as a group. So if I make a new file, general, yay. And we're going to move this guy, because I might want to keep that floating around. And I'm going to save it. I'll use a menu, because menus are fun, even though hotkeys are faster. So I'm going to say this is home.blend, because I want to call it that. And then I'm going to link in something. I'm going to link from this. Oh, let's go back into here. We're going to take this guy here, take my group collection. Sorry, I'm using old Blender terminology. Collection. I'm going to use this little thing here, and it's already in there. Yay! I have linked that in. And the cool thing is that I could go back and say, all right, let's go back to my previous file and say I want to, I don't know, take this and move them over here. Now, this will be a little bit easier in the future, and I could save that. Actually, what's going to be, make these more dramatic. Let's just move these guys farther away. So I save that all out, and then I go back to my home file. Where'd it go? Actually, Control-Shift-O, home, and look, my changes happened. So that's the advantage. If I use the same image on a bunch of different things, yay, then I only have to make that change once. Of course, like I was showing here, bouncing between files is a hassle. So what you should use is the Edit Link Library add-on. Disclaimer, I am the original author of this add-on, but it's built into Blender. So if you go here to our, well, that's my thing, edit, and we say preferences, and I already have it sitting out here. Type in edit linked. Turn that thing on. My mouse is going all crazy, isn't it? Close that out. So now, if we look over here, we got this edit link library thing. Oh, look, edit link library. So over here, this cube, not linked. This cube is not linked. However, this here thing totally is. And I can just say, click, and it opens it. And I can go, all right, great. So maybe I was really dumb and I wanted to put these guys back. Yeah, maybe there. That's fine. That's happy. Cool. So I like that. And then I can go back here and I can say return to my original file. Boop. And my changes are saved. And I don't have to manually open and close file. This edit link library tool does all of that fun stuff for you. Isn't that wonderful? And so that's how you use that. And it is, if you use linked assets, it is so handy. And I'm not just saying that because I wrote it. I've used it a lot, and I'm a big proponent of it. All right, so the other thing, I'm gonna have to blast this one stupid quickly. Actually, I got 2 more points on here, and then I have something I should have teased earlier at the beginning because I have a little special announcement to throw at this. In any case, project organization. Basically, rule 1: be consistent, like annoyingly consistent. You want to have things, you want to prefix all your renders with, for instance, these are conventions that I use. You don't have to use them, but these are the ones I use. So all of my renders, I have a folder called render dash and whatever I'm rendering. Maybe it's the file name that I'm rendering from. Maybe it's the scene, but be consistent. Also, you want to have a sensible folder structure. What do I mean by that? So for instance, maybe you have your project folder, and then in there, again, this is kind of thinking in terms of animation, but you can sort of manipulate this if you're doing ArchViz or anything else like that as well. I have a subfolder for my characters, and I'll link those from there. I'll have my sets in one, props in another, and then maybe right in the root of it, because I'm lazy and I don't want to have a shots folder, I have a shot 1, shot 2, shot 3, shot, and go like that. So it's super helpful to have that kind of structure and stick to it, right? You don't just want to have things dumped in any random place, because then you have to try and track it down and find it again. And granted, things like having an add-on to track it down for you is nice, or being able to open a previous file is nice, but really sensible file structure just makes it nicer, especially when you're coming back to a project that you started a month ago. Use linked assets, we already talked about that. Don't version what you can generate. This is a fun one. So assume we're using version control, right? And we're using sensible version control that we've talked about already. If you're rendering frames out, you can always re-render frames. Sometimes frames take a long time to render. I'm not saying that's a thing, but even if a frame takes a couple hours to render, it probably took you longer to set the scene up, do the materials, do the animation, do those sort of things. You can regenerate a frame. Regenerating the blend file that generated that frame, time consuming. So versioning really should be the thing that's the original art. The stuff that gets kicked out afterwards, you can always regenerate. So I recommend not versioning what you can generate. Also, that saves your hard drive. I said earlier, hard drive space is cheap, but it's not that cheap. Name everything. You might have noticed when I was drilling through there that something was named cube. Shame on me. Name it what it is, name it what it's supposed to be. That way, thumbnails are great. Thumbnails are a great way to reference things, but names are explicit. You're not going to have any confusion about that. And then obviously take notes. Document anything that's a non-obvious convention. So if you have, for instance, on your rigs, you prefix everything with control for control bones and def for deform bones. Just using that as an example. You put that at the beginning of every one of those and be consistent about it. And you might want to put in a note somewhere, maybe a piece of paper, maybe a file, maybe something that says, I'm naming all of my control bones control. I'm naming all of my def bones, my deform bones def. That gives you a lot of, again, it's kind to future you. Rule 2, see rule 1, be consistent, be annoyingly consistent. All right. Here's another fun thing that has been in Blender for a long time. The poor man's render farm. Stop me if you've heard this one. You can use Blender by itself without any additional add-ons to give yourself a render farm-like experience, especially if you have multiple machines, but you can even do it on a single machine depending on how your renders are happening. So the way it works, it's underappreciated and it's so very useful. Short version, you disable overwrite and you enable placeholders. What do I mean by that? So go back down here. If you jump over into your render properties here, Actually, it's on your output properties. I was wrong. Down here. Let's see if I can pull this, make it even bigger so you can see it. Yeah. Oh, that's the one I wanted. That's not the one. That's the one. So this one here, overwrite and placeholders. So you want to disable overwrite and you want to turn on placeholders. Save that file. Now, when you render this version of Blender, it'll be just fine. But you could run a second, because Blender allows you to run multiple instances on the same machine. You run a second instance of Blender. If you have a high-powered machine with a lot of threads, a lot of cores, and you're not tanking them out on every single render, you're not going 100% all of them, firing up another instance of Blender and let it cook on it as well. What's going to happen is the way overwrite, disabling that obviously means it's not going to overwrite a file that's already there. Placeholders means put a placeholder there that's empty until it's done rendering, and then copy the data into that. So what that means is if you have two different versions of Blender running at the same time, one's going to make a placeholder. I'm working on this one and start rendering on it. The other one says, oh, there's a placeholder there. I'm not allowed to overwrite. Let me jump to the next frame. You've just made up a small local render farm for yourself. Now imagine setting that up with a few computers that write to a file server that you have. You just made yourself your poor man's render farm. It is so, so nice. Yeah. So those are my four main tips if you want to try to employ kind of general studio workflow ideas and attitudes for an individual artist, and basically be kind to future you so that future you won't yell at past you, or in this case, current you, back to the time travel. But in the spirit of studio workflows, I have a little announcement. As I said earlier, you guys saw that the big old CG Cookie logo because I've been working with them recently. We are announcing Orange Turbine. Orange Turbine is a small consultancy firm for talking about integrating Blender into studio workflows for small all the way up to large size studios that will employ Blender in their workflow, either as an individual component for modeling or other asset creation, or if it's going to be the backbone, even better. This is one of those things where the Blender Foundation for a long time has never wanted to get into the realm of offering that kind of support, right? We want the Blender Foundation to focus on developing Blender and making it the best application that they can. So our plan, our idea is to step in and show people how to integrate that into their systems and really get Blender to shine for them on their setup. So the idea is that we will help with fun things like Blender deployment, pipeline integration, automation, add-on development. So if you have something specific for your pipeline that needs an add-on, or the way your asset structure is particularly structured, you can actually allow for that kind of thing. And of course, because this is under the umbrella of CG Cookie, there's training, right? Being able to train and show people, because we can't assume that everybody at every studio already understands Blender. Wouldn't that be nice? So being able to provide some level of training and understanding for people who have not yet experienced the awesomeness that we consider Blender to be. Those are the services that we're offering, and that's the sort of thing that we're really excited to get ourselves involved with, because I think it's been a long time coming. We've really been interested in supporting studios that really, I mean, we want Blender everywhere, right? So this is a way to help make that happen. And that's the essence of what my talk is. I'm going to stop sharing if that works, and you can see my slightly sepia toned face here. And yeah.
Awesome. Thank you, Jason. So we had some comments in the chat, like that edit linked add-on was quite nice. Never seen that before. Dimitar, who was our last presenter on architectural Blender, says you should see architectural folders, especially near the end of the deadline. Probably every creative's folders. But I've dropped a link to Orange Turbines in the YouTube chat, so people can find more information.
Thank you. Yeah, it's orangeturbine.com. It's a simple little landing page at the moment, but yeah, that's us.
That's exciting news. Well, yeah, I want to thank you for joining and finishing on time as well. So thanks for that, for keeping the schedule on time. Yeah, we love our friends at CG Cookie. So for people that, I'll just give them a shameless plug. For people that aren't familiar with CG Cookie, they're probably one of the best Blender training websites on the internet. I'm a citizen, I have been for decades, and I highly recommend you join as well. But yeah, we're excited to see where Orange Turbines goes. And yeah. Thanks.
I'm stoked to see how that plays out. And yeah, if anybody has any questions, I'll be hanging out in the YouTube chat for a little bit, and we'll talk more about that.
All right, awesome. Thanks, Jason.
Thanks
feel free to hang out in the YouTube chat and answer questions. So so I see that Dustin Bowser is on the line. So Dustin is from Visual Creatures. He's coming in from Los Angeles. Dustin's a regular presenter at our Los Angeles Blender users group and also our LA SIGGRAPH meetups. And yeah, I'll drop some links where you can find more information on Dustin. But Dustin, why don't you go ahead and introduce yourself and let us know what you're going to be talking about today.
Awesome. Everybody hear me okay?
Yep, we can hear you great.
Awesome, cool. What's up, everybody? Yeah, as Sterling said, I'm Dustin Bowser. I'm a VFX supervisor and director in Los Angeles. Work for a studio called Visual Creatures. And yeah, we've been using Blender a bunch on movies last couple of years. So I'm honored to be part of such a prestigious lineup as today. I see a lot of big Blender heavy hitters here. So what I want to talk about is actually some cool sort of workflow stuff that we've been using at the studio. Kind of how we incorporate Blender into our VFX and animation pipelines at the studio, and some of the sort of tricks and tools and things like that that we've kind of worked out to be able to do that. So I'm gonna go ahead and share my screen here and show you guys some stuff. And I'm going to start off by not optimizing for video. And Sterling, just jump in if it's too choppy or whatever. Let me know.
Will do.
But I just want to be able to like everybody to see the buttons and all that sort of stuff. So first thing I want to show you guys is a cool little solution for retargeting that we've been using a bunch. In kind of our workflows between Blender and Blender to Unreal Engine and things like that. So I got a lot to show, so I'm just gonna kind of jump in and we'll see kind of where we land. So I've got this little astronaut dude who's set up with just a standard Rigify rig, nothing too fancy. And let me actually go ahead and turn on Simplify because he's a pretty dense mesh there. But so yeah, got my little guy. He's all rigged up, nothing fancy. Rigify, you should check it out. Really cool, built-in kind of auto rigging solution. So the tool that I want to show you guys is actually called Renim, and I'll pull up the. Check this out, download it later on. But what's cool about Renim is it's a node-based retargeting solution. And if you don't know what retargeting is, you will in a few minutes. So once you have the add-on installed, if you come to your little tools bar here, and there's now retarget animation node. And it's just like any other node graph that you've seen in Blender. Quick tip though, make sure you click the little shield here to protect it, because I've actually had cases where I did a bunch of work, closed the file and opened it back up and it was gone, and that's why. So if I create a target and source object node, what this is it is a way for me to retarget another armature onto my rig here. And the reason you would want to do this is because, say I want to make this guy move and I want to go download some Mixamo animations or something like that. So let me pull up some stuff here that we can use. Let's grab like the robot dance. Just move my guy over here. And you can see now I've got some cool animation just from Mixamo of somebody doing some crazy dance. And you'll notice the bone orientation and everything is kind of wacky. It's just because I brought it in default. You can bring in armatures and have it sort of try to auto figure out the bone orientation, but I recommend to just kind of leave it by default. And it'll look like that. So what we do now with renim is we say that this is the target. Let me go ahead and name this action just so I can know what it is later. Robot dance. And sorry, I got that backwards. This is the target. We are targeting this animation to here. So this is the source. And now what we do is if I just take this action off real quick, jump into pose mode, clear the rotation and the location just to bring it back to its base pose. And let me move my guy back in place as well. Let's go ahead and put this in front so we can look at it. And I just want to really quick make sure that they are the same size. So I'm just going to scale up this to match about where the shoulder height is. Move this guy over so we can look at it. And I'm also going to make his pose. I'm going to turn on symmetry and I'm going to match this kind of T-pose situation. And you'll see why in a few, why you want to do that. So anyways, now what you do, it's pretty simple. It's a little bit tedious, but if I select both armatures here, just go into this to simplify it a little bit, go into pose mode. That way I can select bones from both. So if I grab, say, and then I'm just going to start using the retargeting here bone by bone. So if I say this is, you can see here, this is my arm. And if I grab this bone, create bone node from selected bones, what this is doing is creating a mapping relationship. And let's see if it'll already work. Oh, let me press bind. You can see here, it's creating a mapping relationship between these skeletons. So let me unbind it and let's just go very quickly do all the main bones here. So bear with me. This would be something I'd usually time lapse through, but you can see that it's going to be pretty quick to do. And all I'm doing is just matching bone for bone. So if it's a shoulder, match the shoulder to the rig, a forearm to the forearm, all that stuff. And if you know anything about the Rigify rig, you'll notice that at the moment, I'm just retargeting to the FK bones. You can also do the IK, but just for the sake of this demo, I'm going to leave it as just the FK bones. And the reason I'm walking through step by step right now is to just show that it's pretty easy to set up, but it may not necessarily be completely intuitive. So if anybody does want to check this tool out, this will be a very rushed and potentially sloppy demo of how to set it up, and hopefully successfully. But you can see it's nothing too fancy that I'm doing here. It's kind of just repeating the same steps over and over. And the only thing you do want to be careful about is if you map a bone over here to the wrong bone over here, then obviously you're going to have issues. So now I'm just grabbing my spine bone over here and mapping it to this, which one is this? They call it a torso in the Rigify rig. And then I'm going to jump to the top spine bone here. And actually, let me turn on, it looks like we've got some bones. There you go. I got to turn on a couple of bones here, my torso tweak bones. And this is all, this interface here, this is all just part of Rigify, which is as I said, built into Blender, and it's a cool rigging solution. So now I've got a couple more FK spine bones in here that I can map to. So again, I'm going to grab this top spine. I'm going to grab this, and again, don't worry about how I'm sort of choosing these bones. Like if you investigate the add-on, you can. It's explained a little bit more in detail. I'm just kind of rushing through it so that we can have something to look at. So don't think that you should automatically know how to set this up like this. And then I'm going to grab the head. And I'm just looking sometimes just to double check. I grab a bone and you can just see the name of it up here. So there's a Mixamo rig. Sometimes there's eye bones and things like that. So I'm just double checking that it's the head. Grab my head here. And I think I mapped everything. So let me go ahead and hit bind. And I already know there's a mistake here, but I do it on purpose because I want to show something. So let's see if I can, yeah. So you can see here, when I move parts of the body, they move here, but you'll notice it's kind of moving at a slightly different orientation. I move the arm down and his arm is moving sort of inwardly. And the reason that is because Mixamo rigs, armatures by default, come in rotated. So you can see right here, rotation is at 90 degrees. So let me go ahead and unbind real quick. And if I just apply rotation, so now this is all zeroed out, cross my fingers here, and yeah, there we go. So, all right, why do we do that? If everything went according to plan, and we'll find out right now, I can take this armature, put my robot dance back on it, and now you can see my dude's dancing. He's got pretty sweet moves. Now, there's several retargeting solutions for Blender. There's the Rococo tool, which I may have over here. Let's see. Yeah. And that's a good one to use. There's a few others, but the reason I want to highlight this particular solution is this. As opposed to a normal retargeting tool, what it would do is it would take this animation and bake it to this armature, to this rig. But this solution is not doing that. This is a live retarget. And why is that interesting? It's interesting because, for one thing, I can dynamically repose this skeleton without breaking the animation. So you can see I can do whatever I want on top of the animation and it all works dynamically. I don't have to do anything fancy with NLA layers or animation layers or any of these other things that you might normally have to do. Because you'll notice sometimes, depending on if you're retargeting a character to a character of a different size, you may see that limbs interpenetrate, things like that. This is a really easy way to fix that. And then obviously you can also animate on top of this too. So rather than just posing it, you can animate these things and create whole new layers of animation on top of this mocap data. And the other cool thing is now that we have this armature retargeted to this, we can very easily bring in new mocap and it's all just going to work. So I can say, let's grab this twist stance, whatever that is. Now we have another armature in here. I'm just going to move that to the side, rename this twist stance so we know what it is. And because these are both Mixamo skeletons, I don't even need to keep this armature. I can just tell this one to now be twist stance. And you can see how easy it is to set up a relationship between these armatures and then just have the animation work. So in a nutshell, that's Renim. It's pretty handy. The developer has been There's actually been a couple sort of bugs in the add-on, but I've been back and forth with the developer, and we've gotten it working. So he's a cool guy. He's out there doing his thing and improving it as it goes. And so that's that. So so that's retargeting. That's renim. Check it out. It's cool stuff. And then so I got a couple other workflow stuff that let me jump into showing, and let's just see how far I get. So we've been doing a lot of work in Unreal Engine at the studio and using Blender as a sort of a pipe over that way. And one thing that you'll know if you've ever attempted this yourself about bringing assets from Blender into Unreal is that it's not necessarily always just kind of a one-click solution. And the reason why is because Blender lets you do all kinds of fancy stuff with shaders and UV mapping and procedural modeling and Booleans and modifiers and all this sort of stuff, which is great. And it lets you do really cool models and materials. But most times you have to simplify this stuff down and bake it down so that you can get it into Unreal. So there's a lot of ways to do it. Again, there's so many tools to sort of do the same kind of task, but I have found one that sort of does make it as about as one click as you could. So I've got this cool little like generator kind of model here thing, and the reason I want to show you this as an example is if you check this out, look at all these shaders this has. And if I click through, you'll notice some of them are relatively simple. Some of them are using procedural materials and even add-ons, things that aren't even necessarily Blender native. They're just, you know, every kind of little tool in the book. This is actually Mask Tools, what this is, if you've ever heard of that. I think I pulled that up here. This is another very cool texturing tool for Blender. It's got a lot of built-in procedural things for edgeware and rust and dust maps and things like that. So check that out. That's very cool. It makes Blender texturing much more sort of robust. And so anyways, obviously this is very cool. And if I was going to stay in Blender, this would be perfectly fine. And we could render this and it'd be great. But let's say I wanted to get this into Unreal Engine. How would I do that? This looks like this is going to take all day to bake this stuff down and kind of figure out all the sort of stuff. So let me introduce you to Simple Bake, which let me pull up the page here on Blender Market. Again, very cool like developer. I've been back and forth. You can use this little ask a question to talk to them directly. In my experience, he's gotten back. There was a bug in the add-on, and I emailed him, and I woke up the next day, and he had already sent me a new version with the bug fixed. So pretty responsive, and obviously he wants his tool to work. So what Simple Bake is going to do is it's going to use the built-in baking functionality of Blender, but he's just tooled it together to be basically a one-click solution. So I'm just going to kind of breeze through what this setup is really quick, just because I want to show you really more so the results. So I'm doing a PBR bake. So here you can choose between your different PBR maps. You get diffuse, metal, all this stuff. I know that this just happens to be diffuse, metal, roughness, normal, and emission. I'm going to go ahead and change this to DirectX because I know that's what Unreal uses. You can choose your resolution. And you can even do a custom resolution, obviously right here. I'm just going to do 4K. You can tell it to export. So it will, if you know about texture generation in Blender, you know that off the bat, it's not going to save it unless you save it manually. But luckily, he's got this little checkbox that it will save all these maps automatically. You can choose the format. I'm going to do PNG. The other thing that I want to point out about this model is to achieve this texturing, we're doing all kinds of different UV maps here. You can see there's a few of these. And I think I simplified it down. I think there were even more, which again is not ideal if you're trying to bring something over to a game engine like Unreal or Unity or whatever. So this also has a cool option to be able to create a new UV map, and it's going to automatically do a smart UV project. So we'll go ahead and toggle that on and copy object. So it's going to replace this object and hide the source object. And basically that's it. Once everything's kind of set up right, and fingers crossed it doesn't give me a Python error, but if I hit bake maps here, it's going to bake. And you can see as well, you can choose the GPU to bake with, and not just the CPU, which actually is significantly faster. So, however, baking still does take some time. So while this does this in the background and hopefully it isn't crashing, I'm going to jump over here really quick and let's just check out our studio reel really quick while that plays. And Sterling, jump in if this is if this isn't playing back or if the sound is not working, and I'll change the screen sharing settings. So just let me know.
It's coming through.
Okay, cool.
My hands on myself. Dust them off, put them back up on the shelf. Just a little baby girl isn't me. Am I coming out of left field? Ooh, I'm a rebel just for kicks. I've been feeling it since 1966. I'll be over now, but I feel it still. Ooh, I'm a rebel just for kicks. Let me kick it like it's 1986. I'll be over now, but I feel it still. Got another mouth to feed. Even with the babies and the mama gonna grave digger. Gone with the fallen leaves. Am I coming out of left field? Ooh, I'm a rebel just for kicks. I've been feeling it since 1966. Might have had your fill, I feel it still. Ooh, I'm a rebel just for kicks. Let me kick it like it's 1986. Might be over now, I feel it still. We can find a war for peace. Giving to that easy living, goodbye to my hopes and dreams. Stop flipping for my enemies. We could wait until the walls fall. It's time to give a little to the kids in the middle. Oh, until it falls. Don't bother me.
Cool.
The system works. Just ask these hunks.
Ask the hunks.
The hunks know. So yeah, that's the studio. And you know, by the way, give us a shout if you're out there and you're an artist. We're always looking for new awesome folks to work with, animators, modelers, you know, whatever kind of stuff. Give us a shout if you're out there and say hey. I also want to point out we've got our film that we worked on, Cherry, is out now. So go ahead and give that a look. It's on Apple TV Plus, starring Tom Holland, Sierra Bravo, directed by the Russo brothers. It's a really cool, kind of a darker movie. It's about sort of the opioid crisis, and Tom Holland goes off to war in Iraq. It's an adaptation of a best-selling novel. So check that out. We were working on that all through quarantine this last year, and that's out now. So anyways, so back to this bake. I don't know what this goes out. So this did not take as long as it took to watch that reel. It probably took about 60 seconds. So don't think that it takes necessarily forever. But so check this out. Here's what's interesting. What you're looking at right now looks to be just about the exact same thing as what we were looking at before, but actually it's not. It's a copy. And hopefully we don't crash or anything while I'm rendering. But check this out. So we got a clone. Let's look at the materials. One material. Let's look at the shader graph. All of that complexity, materials, shaders, everything is now just those 5 maps. Also, one UV map. So in one click, this thing is ready to go. This thing is ready to send out and use anywhere else you want to use it, which is pretty cool. So in these last couple minutes, I want to show you one last little cool workflow thing that is about how you might get this over into Unreal. So there's a really cool data exchange format called Datasmith. Here is the add-on is on GitHub. So it's just a Blender Datasmith exporter. And what it does is under the hood, it does all kinds of complicated translations to allow you to send entire Blender scenes over to Unreal with a pretty surprising amount of things coming through. So I just did this just before I jumped on this call, just to sort of test it and make sure it was all going to work. Okay, but check this out. So I took this scene, which is just one of the demo scenes that you can get on the Blender download page. I think it's called Mr. Elephant. Pretty cool scene. And without doing anything, all I did was export via Datasmith. Here I've got this in Unreal with materials, lighting. You know, it kind of merged into another scene that I had. So we're kind of mixing 2 scenes here, but you can see that it's pretty surprising. Everything that came through, we got the textures, we've got everything is its own discrete mesh. You'll notice that the pivot points are correctly where they should be. So that's pretty cool. So let me just see if really quickly we can do that with this and just show how easy it is. So once you have the add-on installed, just snag it off GitHub. It becomes just one of these export options. You see here, Datasmith. So I'm just going to go ahead and select my object that we baked down, Datasmith. And in this case, I'm going to go ahead and do selected object so I don't send all this other stuff. And let's just create a little folder for it because it does create some files. Just name it and let it go there for a second. And it should just take just a second. All right, and we're done. So now, if I come over here, move the zoom window out of the way. And in Unreal, I know this is not Unreal Meetup Day, but they, you know, Unreal and Blender are they're 2 very powerful friends to use together. So I recommend checking it out if you haven't yet. So there's also a Datasmith plugin in Unreal. So I'm going to click that to import, go to my generator. And when it exports via Datasmith, what it does is it creates a .udatasmith file and then a folder with all of the assets in it. So that would be the textures and all that stuff. So just be aware that that's what it's creating. I'm gonna go ahead and hit open. It's gonna want me to put it somewhere. So I'll just put it right there, that's fine. Geometry, materials, all this stuff. And let's see, fingers crossed. Don't make me a liar, Unreal. With any luck, here we go. Check this out. So what's cool about this is this was a procedurally modeled object using all kinds of different tricks up Blender's sleeve, procedurally textured. It wasn't necessarily done in any sort of what could be considered a clean way. And with one click, we were able to bake it down. And with one more click, we were able to get it into Unreal. And, it looks pretty dang close to what we had in here. Obviously, you can see some things are slightly different. It looks like the emission texture is not coming through. And all of this is just stuff that you have to kind of go in and see maybe a map is missing, or maybe the way that the material works is slightly different. It's never just an exact one-click solution, but you can see it's pretty close. It's pretty close to being a one-click kind of a situation. But anyway, that is about it in a nutshell. It looks like I'm coming up to Sterling. I was going till 11, right?
Yeah, you're perfectly on time, and
Cool.
we're just about to pivot to the next speaker. So it's been a awesome session, Dustin. We've been getting like lots of positive comments in the YouTube chat, like super cool
great.
animation, sick stuff, awesome.
Great.
People were, saying impressive reel, so much different, so cool. The ending made my spine wince. I think somebody asked, about the visual creatures trailer. Was it all made in Blender? I mean, obviously, probably not, right? I mean,
No, we've been incorporating it more lately in the last. So on Cherry, we used it a bunch. So check that out, and there's plenty of Blender stuff in there. We do a lot of like animation and MoGraph too, and Blender with geometry nodes and all this other stuff is really coming into its own as far as its capabilities with motion graphics. But Cinema 4D is also definitely in the industry like a go-to tool for that. So there's a lot of Cinema 4D you see in that reel, but honestly, a lot of us at the studio haven't touched it in like 2 years, and we've been full Blender for like the last 2 years, and we're loving it. So
awesome. All right. Well, hey, I want to thank you for joining. Excellent session. Feel free to hang out in the YouTube chat and answer any questions. But yeah, it's been great. Thanks for joining.
Thanks, guys. All right, excited to see what everyone else has got coming up. Cheers.
All right, cool. All right, so with that, I see that we've got Matt Myers on the line. Matt, I love your background. It's so cool. So for everybody, our next presenter is Matt Myers, joining from San Diego. He's presenting on using Blender for computer vision. Matt's been presenting some great Blender and artificial intelligence sessions at our LA Blender user group.
Thanks.
Which I'm personally a fan of. He also owns the coolest T-shirt I've seen, which says, "I can do it in 5 minutes in Blender," which is just cracks me up every time I see it. So I'm going to pass things over to you. Introduce yourself, Matt, and take it away.
Okay, well, like Sterling said, I'm from San Diego, and I'm part of the LA Blender users group. And I'm going to talk today about how I trained an algorithm to cook bacon. Let me share my presentation here real quick. Share screen.
Okay. And I could see your screen share just fine.
Okay, great. Okay. So this is like I said, it's a case study in cooking bacon and using computer vision. So I'm going to walk you through the steps of starting with where this fits in machine learning and artificial intelligence. And I'm going to talk about what is cooking bacon to a computer. And the real heart of it is creating the data sets. So I've created 2 data sets, one by scraping the internet and one using Blender. And then I'm going to talk about the next steps and really interesting things that I've learned along the way. So first, a little bit about me. Like I said, my name is Matt. I have a background in mechanical engineering. I got my master's of science in engineering from Purdue quite a while ago. I have 113 patents, and I've worked for more than 20 years as a principal product designer in consumer products. This is a couple of pictures of a few things that I've worked on in my career. Okay, so machine learning, I really like this chart because it breaks it down into just really simple branches to help you understand how this fits in. So reinforcement learning is it's a branch where you would use it to teach a robot to navigate a system. It's kind of an award type of algorithm, or like to teach it to play video games and beat like every Atari game there ever was. Supervised learning and unsupervised learning are pretty closely related, but the difference in supervised is that you know the answer to what you're trying to solve first, so then you try to work backwards and figure out the equations that will give you those answers. So when you're given something new, you can solve for that, like guessing a house price or sales price. Unsupervised learning is where you don't know the answer in the end, and you're, in this case, like let's say you're trying to cluster a customer segment together. This bacon cooking algorithm falls into the image classification supervised learning session. So this is a pretty well-developed field, and you've undoubtedly come across this before if you've ever driven past or seen a Tesla drive past you with their driver dazing off in the corner. These algorithms look for obstacles. They're trained to look for people, other cars, lanes, those kind of things. You've also probably seen it with your iPhone with the face feature unlock, and also surveillance and governments doing that kind of thing. It's also used in agriculture. You can use it, there's apps on your phone that will show like a plant. If you showed a plant leaf, it'll try to tell you what the plant was. Or it's also used to diagnose disease in plants. It's also used in diagnostics, like a manufacturing setting where it might look at a bunch of parts flying through an assembly line really fast and tell you if there's a defect in one of the parts. It's also used in medical diagnostics to diagnose cancer. So this slide right here, this slide could go at least an hour or two, because this is really the guts of how this works, but it's way out of the scope of this. So I just wanted to show you that this is the algorithm. This is what a convolutional neural network is and what I use. And if you're more interested in that, I can send you links later. You can just get in touch with me. So in this case, the way that it works is on a high level. You give it an image and it breaks it down into smaller pieces. They're called filters, but imagine it's like a puzzle piece. So you start with bigger puzzle pieces, working your way towards smaller. And what the computer does is try to figure out how those pieces come together in the end. And you tell it that when it after solve for those pieces, that this is what a robot, these are the pieces that make up this robot. And so what you try to do is give it enough different images of this class, and then you can use that to guess what future images are that it hasn't seen before. So I use that, and TensorFlow Hub with this, it's a 50-layer deep network that contains 1.3 million different images already pre-trained. And so what you do is you use that and work your way back, or I'm sorry, you use that, but you take the last couple layers off and you put your images on and your labels. So in this case, it's bacon images and then the labels of cooking bacon. So I'm going to show you what the output of that looks like. So this is TensorFlow, and this is what it's going to do. It's going to look at an image, and then it's going to try to statistically determine if it sees one of those classes in the image. In this case, it's banana and an apple. And so it finds it and it puts a box around, a label around that, tells you what it is, and then it gives you a probability that it's pretty sure that that's correct. So obviously, if you're creating these things and it says it's a 10%, whatever, that it's correct, if you're doing this for self-driving cars and you're 10% certain that it's a person, then you maybe want to reevaluate your algorithm. In this case, 80% for banana. I don't think that's hurting anybody. All right. So that being said, obviously, if you're like me, you're the kind of person that you need to give yourself a project to learn these things, and then see what kind of pitfalls you come across. So what I decided to do in this great COVID shutdown, so I'm stuck at home all the time, is to try to see if I could classify bacon. So as a product designer, these are some of the steps that I would go through to set up a new project. So I want to show you that it isn't so scary. So if you're interested, you could do this similar type of thing. So I'm going to create an algorithm that is basically to be used for an overhead stove camera that's going to look at you as you're cooking the bacon and tell you if you're set to, whatever level that you want to cook it to. So I need to scope the project that way, and then look at the different, identify what those labels are, so then I can go out and find images that match the specific stages. And then what I'm going to do with handling errors. In this case, like I said, it's cooking bacon. So the worst, on either end is it's raw or you burn it. This, like I said, isn't a self-driving car. I'm not diagnosing cancer, so it doesn't have to get as serious as those. So then we're going to create the data set and train it, and then repeat as necessary. So I've identified these are what I'm calling the 1 through 5 for the bacon data sets. So these are kind of the stereotypes of each one. So raw is 1 here, uncooked is just starting to get a little bit some waves in it. Golden is 3, crispy 4, and then burnt 5. So before I got into the Blender stuff, I thought that I could just go out on Google and just make a web scraper and pull up this data. So let's do a search for bacon. And I can see there's lots of images out here. So this is gonna be easy, right? No problem. So I created a quick Python script to go out and do a search for a golden bacon and give me 120 pictures. To get a good data set, you need at least, starting in this case, at least 100 or a couple hundred images of each type or each class and go from there. So this is what I set out to do. And running this gives me these images. And I could already tell this is going to be a problem. And I'm setting this up to show you why I turned toward Blender. So that's definitely not golden bacon in the way that I want it for this. That looks pretty good. That is literally golden bacon. And you can see it starts to get just, I'm going to have issues. So I had to get pretty clever with this. So you end up, Google changed some things in their web scraping about a year ago. I think maybe people are using it too much or something, but I had to go out and create this search system, basically looking for all kinds of different keywords: raw bacon, uncooked, fried, burnt, bacon strips, shredded bacon. And so I finally was able to get a data set that looked decent. And then I had to create another script to remove all duplicates and do all this. So it's not as easy as you would think. The next step, once you get all of these, is to label where it is in the image. Like I showed you before, the final product is the border and the percentage around the class in the image. So you have to manually do that ahead of time. So this label image software is pretty nice for this. So you point it to the directory where all your data is, and then you create a rectangle around the area where your class exists. In this case, this bacon, and then you got to give it a label. So I would say that's probably that doesn't look so great. Maybe that's a 2 bacon level. Okay, and then you save this out, and it creates an XML file that tells it where this is pixel-wise in the image. And you do this for all of your images. So in this case, I had about 750 images that I had to go through. It's a pretty tedious step. And I'm going to show you later where I think Blender might save in this kind of thing, which would be awesome. Okay, so once I got all this set up, once I got all this set up, then I went and trained it. So using Google Colab, it trains and it runs for 8 hours. And then at the end, I'm ready for the validation step. So I wrote this script, which basically will take images in a certain folder and compare it, and it will put the labels on the box. So we're going to run that, and I'm going to show you what I found. Okay, it takes about 20 seconds. So unfortunately, we have to wait for that. So it's going to load the saved data up, or the saved model that I trained. It's going to open the images, and it's going to print out some so there's the images, and it's going to print out some diagnostic information. So what it does is it finds about 100 inferences of classes in there, and it will, the way I have it set up is it will find a box and put a box around only the highest one. So it's doing that right now. And then we're going to use this to see if the model was good enough, and see if I was able to actually web scrape a decent selection of bacon that I can use for its model. So here's the first one. That's saying it's 79% level 5. And I guess you could go with that. It looks like maybe it's some kind of a maple bacon, but it's got, you know, the characteristics, the black char on that. This is a 4 over here. That's definitely raw. That's definitely raw. This one's pretty good. That's burnt. This one I'm going to set aside for a second. And then the rest of these look pretty good. Okay, this one was interesting. Now, I know it's cut off because this picture is pretty big relative to where the label is. But if you look back over here, these diagnostics, this one ends up being bacon level 1, which is telling me that it's raw bacon. Now, definitely there's strips on either side of this. And this, like that same similar picture before, should be classified as either 4 or 5. So you got to ask yourself, why did it do that? Well, if you look at this, I think it's classifying the hand as part of, it thinks that that's the bacon because it, you know, has similar characteristics, maybe in the knuckle, the crease in the skin here. So I needed to go out and do a search to add more images to this. So I do another Google search to add images of bacon, of hands holding bacon. And I want to add these in so that I can train that out of it. Okay, and now I noticed, okay, I found a bunch of hands holding bacon. So this is great. So I can add these pictures in and put the box around it. So then it knows to exclude that out of the data. That's kind of what the labeling does. Well, here's the problem. Notice how every hand is a Caucasian hand. Now, this is interesting. If you follow these kind of things in AI, it's been a major topic about bias in AI and machine learning. And I wouldn't expect to see it in something that silly as me trying to train bacon, but here it is. So again, this is another instance where I'm going to get back to at the end of this about why I think Blender is really good for these algorithms. So this being said, I picked the pictures that I could and retrained this algorithm. So I'm going to show you what the results are. Okay, so it's going to run again. Again, this takes about 20 seconds. It's opening the model up. Bear with me.
Matt, while that's running, quick question. Yeah. Is the labeling MG software also open source?
Yes. Yeah. I'm going to show it at the very end of this. There's a couple of links. There's a Medium article that has links to some collab pages written by some pretty great people. And all of this is open source. There's a walk through demonstration step by step to install all of the dependent Python libraries and TensorFlow libraries. So yeah.
Thanks.
Yep. Okay, so here's the results. And I chose a couple of different pictures this time, but this is saying 99% level 4. So that looks great. This is level 3. Here's that hand picture. This is great. Now notice I know it's cut off, but trust me, it's saying now it's level 5. So it did figure out how to exclude the hand from this and actually recognize the bacon. At least that's how I feel it's doing this at this point. This one, now I got something new. These look good. This is another interesting one. Notice how now in this image, good old Justin Bieber here has bacon on this plate, but it's identifying, and it thinks that there's bacon on this countertop. If you look at it, and it's level 1. So if you look at it, I think it's actually looking at the marble, the patterning as though it's bacon. So this is an important example of why I think it's good to scope the project properly. Like I said in the beginning, this is going to be used for a camera that looks at how you cook bacon on a stove, not necessarily how you sit and eat bacon. So this would be something where, again, Blender and being able to control the environment that I train and get these images from is going to be a really nice way to get a better set of images. You know, just this bacon in these pictures, bacon in the wild, I'm stuck with, you know, Instagram pictures of weird Justin Bieber and other stuff. And that's why I'm going to finally get over to the bacon, the Blender side of this. So let's see first if we can make fake bacon using Blender. So over here, I've got just a mesh with a quick image texture on it. And I've unwrapped it real simply into one of these strips over here. And I'm just going to give it some shape. So let's push some poles around. Let's see. I'm doing on time, so I'm trying to just kind of go a little fast here. All right. I'm going to add a couple modifiers to this. Let's add a subdivision. I got to move everyone out of the way here. And I've noticed that bacon, as it cooks, it kind of gets a wave effect to it. So I'm going to add a couple wave modifiers to this. And I pre-wrote these down so I can be fast here. Let's add, definitely not like that. Looks pretty good, right? And let's move that, something like that. All right, maybe that's a little crazy. We'll add another one. And let's see here. All right, so now I've got a little bit of shape to this guy. Just kind of curl it up like that. Now there's one more thing I want to do to this. I'm going to use a shrink wrap and just give it a little more of a bend. So I'm going to shrink wrap it over torus. Let's add a couple of subdivisions to this. And shrink wrap to, oh, sorry, I gotta move you guys. Okay. This up. And did I get it? Let's see, where are we at? Object, Z. There we go. All right. So let's just give this a little bit of shape, right? So we'll add a couple more. Rotate this around. All right. So now I've got my, well, you know, I could add, I guess, a solidify modifier to these guys too, make it, give it a thickness. But that being said, so what I want to do is try to create some diversity, is some, you know, textured bacon that now I can run that against the previous trained data set to see if it actually picks it up. So I did that, and over here, I've got some predefined, you know, raw bacon, and you know, from each, basically bacon from each step. There we go. So I'm going to run that. So let's see what happens. We're doing pretty good on time here, so that's good. All right, and we're gonna find out.
Mike, again, while we're waiting, do you use accuracy metrics like map on your bounding boxes and so on to understand how good the classifier and recognizer is?
I'd probably end up using something like a confusion matrix. Yeah, I haven't gotten so much into the labeling itself and where that fits in the image just yet. What I was going to talk about at the end here is how I think when you create a synthetic data set, a fake data set in Blender, that you can use the bounding box of that item to become your labeling box. So
cool, that's a good idea, actually.
Yeah, thanks. So let's see. Okay, this brought it up. This was level 3 golden bacon, but it's showing it at level 4. So clearly there's a little bit of issue here that it needs to sort out. But it did find a pretty high level of confidence in finding some kind of bacon. This is a level 5, and that's what it's showing. So that's pretty good. This is 4. It found it. And then this one's another golden one, and it actually did classify that one as golden, which is great. This was level 2, and it's kind of a terrible texture. I'm not super happy with this one, and it classified it as 1, so there's a little work that needs to be done there. And then this one definitely is the raw, and it found it all. It did great. So cool. We found that we can make a fake data set that I can train against the bacon in the wild one. So now what I want to do is put it in its element. So I created a kitchen scene, which we've got here. And give it a second. Come on. I got a lot running. Okay, there we go. So I got a script here, which basically was the same script that was running to classify everything else before. I just created a Blender add-on or a Blender panel inside of here to run. And so I've got that preset up. And so you can see I've added the fake bacon strips from before. And I've got a camera positioned above the range. So this is what I'm going to be seeing. This is the environment that it would live in. So that's what it sees. And now, if I run the classifier on this, it should be able to tell me where it is in that image. So let's go and do that again. And you see this is real similar inside of Blender. Pull the window up and identify. And let it do its thing again.
So Mike, while we're waiting, Blender comes with its own Python packaged from memory. And so did you have to install all the libraries for TensorFlow and so on into the Blender build?
Yes. Yeah, I did. There are a couple different ways of doing it. I kind of did it the backdoor cheating way for this. In other words, I took all of the site libraries, the site modules, folder that I have for my virtual environment that I use outside of Blender, and just pasted it over the top of the one in Blender. So here we go. It found the bacon inside of here, and so I've got it where it's set up. It actually puts a box around it. It finds it in space, and then it tells you, oh, it's calling it uncooked. Well, again, I'm using the bacon in the wild data set to classify this right now. But if I created a fake bacon data set and run it, it's actually going to work because I trained it inside of here. Ooh, come on. Trained it inside of here. So what I did was, and this is where I think Blender can really come into effect. I created an animation where, like I said, we need to get a whole bunch of images that are diverse and in different positions and scales and rotations of your data in that space. So if this image, you can see the field of where the camera is going to be capturing, and I animate this across the scene and capture each one of those and then label them in my data set, and then that's what I train it on. It's going to be that's the system. It's gonna be very accurate. So that's what I did here. So if I move this across the screen and now I do a classifier and identify, it should find that. And then so we can do the same with all the other bacon, and you're gonna see that's exactly what happens. So I'm gonna wrap this up real quick right here. In the future, what I want to do with this, since this seems to work pretty well, I'll go back to where my slideshow is. So I used textures and a couple of modifiers to create the bacon in there. I would love to make a completely procedural material node style bacon, but I'm not that good at that. So if anyone in this meetup is really good at that, a node member person, I'd love to get in touch with you about that. I also want to model more environments. You saw that was just a black cooktop, like gas ranges, those kind of things. Anything that's going to be environment that you train in is going to make this more accurate. And then also, I'd love to be able to animate the cooking process and actually put a chef in there. I talked before about a hand holding bacon and being stuck with whatever you could scrape off the web. Well, I could either go and hire a whole bunch of hand models and all these things to do this, or I could model this inside of Blender. If you remember when COVID went down and everyone was having trouble with their face recognition in their phone, not picking up because they were wearing a mask, and then over time, Apple redid their algorithm and retrained it. I could do the same kind of thing with this. So let's say that the fad for cookware suddenly becomes bright yellow pots and pans. Well, I could go in Blender and then just pop that in there and retrain my algorithm and be all set. So you can really get some versatility there. So I want to thank you, and my email I go by Conjure on GitHub. So my email is github@gmail and Conjure that way. So I'll put up other pieces of code here and there as I go. And I want to give a special thanks this is for the slideshow template. A lot of the assets that I used in the kitchen scene were from artists on BlendSwap and as well as Polygon. The TensorFlow training tutorials are a couple of students or computer science engineers, Ludmil Vladimirov and Nisar's Kapkar. And that's it. Thank you.
Awesome. Thank you so much, Matt. That was a great session. I think you made us all hungry. I've been back channeling with the World Blender Meetup crew, and David's wife made bacon scones and my wife's cooking bacon literally right this very second. So I think World Blender Meetup Day 2021 sponsored by bacon.
Yeah, I've definitely cooked a lot of bacon in the making of this. It was a good excuse to go to the store a lot.
You made me very hungry.
So we've got some chat in the YouTube interesting tech, such a simple example of technology with a massive potential to change our world in ways we've yet to imagine. So yeah, really interesting session. So thanks for joining. Thanks for presenting.
Yeah, thank you.
Yeah, cool. And at this point, I'm going to take a minute and transition to Joseph Conover. So Joseph is he's a regular presenter at our LA Blender users groups, where he's shown his logo and credit work on films like Avengers, Endgame, Wonder Woman, Guardians of the Galaxy. I'm also a big personal fan of his Calvin and Hobbes fan short. Joe, over to you. Why don't you introduce yourself and what your topic is and take it away.
I mean, you kind of covered it there, but yeah. So I've been doing design work professionally since 2016 when I moved here to LA at a lot of different studios. I'm kind of a freelancer. I worked on Avengers Endgame, Guardians of the Galaxy, Pacific Rim Uprising, Wonder Woman, and a few more big and small movies and ads, designs, just whatever's going on. I mean, because of COVID, a lot of movie stuff is dead. So a lot of my recent stuff has been commercial, but hopefully that'll get started back up soon. I've been using Blender since 2006. And it was one of the first 3D software packages I've learned. Blender has become a sort of sketchbook to me where I build out all of my ideas first, and with all the generalist stuff it can do, it's become probably the best tool in my little utility belt. So let's take a look at my demo reel, and then I can probably do maybe a shallow dive into some of my recent projects and some new stuff and works in progress that aren't in my demo reel. With the exception of the Avengers and Miramax logo, everything on this reel went through Blender at some point. So I do a lot of my modeling layout, or sometimes the entire render will be in Blender with cycles or something. Here, let me see, share my screen. Screen one, share, there we go. Can you guys see my video?
We can. I'm just waiting to see if we get sound. Did you share with sound?
I'm not playing it yet.
Oh, okay.
Okay,
Great.
yeah, so
yes, but we can see
I'll
it.
just play it. Cool.
You may want to reshare it with optimized video because it is coming in a little choppy. There's a little checkbox when you click on share
gotcha.
screen. Yeah.
And click that share with sound if there's sound in the trailer.
Screen. Oh yeah, okay, cool. Share sound, optimize screen share video. Okay, cool. Just do that real quick. There we go. Yeah, I'll just skip that. Yep, so that's my reel. That's my life's work basically. Let me see. So yeah, so that's my reel. It's a lot of like Blender stuff, and I think it's really cool. Let me do a quick dive. You saw my Spaceman Spiff project on the reel, which I think is probably my best work. Let me do a quick dive into that project real quick. Let me pull that up, and it was really cool. So basically, growing up, I read Calvin and Hobbes, as I'm sure it was a very popular comic, so a comic strip. So a lot of people read it, and it really resonated with me and a lot of you guys. So I always wanted to create something that kind of honors that work, since it was kind of like what sparked my interest in sci-fi as a genre. Like, I read Calvin and Hobbes before I watched Star Wars, and it's just like kind of just sparked my interest. So I decided to create a fan-made interpretation of Spaceman Spiff, which is Calvin's alter ego. So I'll show that video here.
Great. And we're currently looking. There we go. We had a black screen for a second. But
yeah, that's my desktop. My desktop is a black screen.
okay, wonderful.
Yeah.
Take it away.
Sometimes I think the surest sign that intelligent life exists elsewhere in the universe is that none of it has tried to contact us. Our hero sets his death ray blaster.
Yes. So this was just like a project I did in my spare time, and I really thought a lot about the design, and it ended up being like one of my best works so far. Let me go into the design process a little bit. Also, yeah, I have a black screen just because, you know, I like to keep everything simple so I can think straight, I guess. I don't like being messy. So the first thing is the mothership. So I did this gun here, which is this gun is just ripped straight from the comic. But here's the mothership. The large looming mothership design was a design I thought about for a long time. A lot of inspiration comes from NASA's Internal Space Station, as well as like sci-fi art I've found online. It's sort of like my idea was that it's made as if like the tubular structure base was built first, and then over the years has been retrofitted and iterated on. So I like to kind of like build these like little worlds inside my head and think about like, I guess, the lore behind the structure that I'm doing. The wires and structures were inspired by International Space Station photos combined with classic sci-fi book covers and modern sci-fi art. It contains like a spinning artificial gravity core, because the movie 2001: A Space Odyssey, if any of you guys have seen it, did that also. So I got to try to do it better. 2001: A Space Odyssey had an issue where the space station was spinning, but it was partially under construction, so it's scientifically inaccurate. So I got around that problem by sort of containing my structure within a large enclosure. So, you know, I try to look at like what's been done in the past and how I can improve on it, maybe. It was modeled in Blender and ZBrush and then textured in Substance Designer. The tractor beam was sort of an afterthought because space doesn't have any. When you're in space, there's no up and down, you know, you don't really think about that because you think about up and down because of gravity here on Earth, but there's no really sense of direction. So one of my friends suggested I was like, make a tractor beam to give like a sense of direction to the audience. And I was able to quickly make and render it in cycles with a new hybrid CPU GPU rendering and composited over my scene, which was pretty cool. So yeah, that's my mothership. And then I built these. Let me go over here to this folder. So the Red Rock Mountain scene right here this was the first one I built. It was largely inspired by this awesomely drawn panel from the comic. I exaggerated the ship's destruction quite a bit so it reads better. Also, are you guys able to like see this in decent quality, or is it low quality? Just wondering.
Yeah, it's coming through well for me.
Okay, good. Just making sure. Yeah, because sometimes the Zoom can be a little compressed or whatever.
Yeah, it can be finicky, but it looks good from here.
Okay, cool. Yeah. So I built the Red Mountain scene based off this panel from the comic. I exaggerated the ship's destruction quite a bit so it reads better, but I tried to keep the integrity of like the ship design intact. I also took a lot of creative liberties in making the alien landscape, which is like in my head, it's like a human world where hot water churns below and bursts through vast red rock mountains. And the idea, these water plumes here came from NASA's Hubble discovery of possible water plumes on Jupiter's moon Europa. So I saw some like visualizations for that, and I was like, oh, water plumes. So I can do some water plumes myself. And that was almost like an afterthought too. A lot of the volumetrics were done in Houdini, but then these water plumes, I was like, oh, I'm gonna do water plumes. I quickly built that using Maya's using Blender's particle system in cloud volume, whatever it was called. Blender has a new volume system. I wasn't able to use that one, unfortunately, because I was having issues with it. So I had to kind of switch to the old one, which is a little bit faster, but it looked decent. So
looks great.
Yeah,
It looks
thank
really
you.
great.
Yeah.
Hey, Joseph. Hey, do a quick share stop and take off that optimize for video if you're done playing the videos.
Okay. Yeah.
And we will get a slightly crisper version of what you were showing. But
Yeah,
it still looked pretty good.
I could probably I'll probably be showing like, yeah.
There we go. Yeah.
There we go. There's a crisper
Looks a
version.
little crisper, but
Okay,
awesome.
yeah. If I play another video, I'll turn it back on.
Sounds good.
Yeah, so this was my whole crazy compositing. I basically went frame by frame, trying to make sure every single frame looks good, and this is one of the good looking frames. It was built in Blender, kind of sketched out in Blender quickly. The terrain, I did the terrain in World Machine. So I sketched out the terrain in Blender, made sure to get the camera position right and stuff. Yeah, you can see the terrain here. And then I took it into World Machine, then back into Blender for the displacement maps and stuff. And then I exported it to Maya for rendering. And then here, the next scene. So the logo design, that last scene with the mountains took me like 3 months, but the logo design took me only a week, which is kind of silly. It was a lot faster and a lot less complicated design due to I'm kind of going for like the minimalism and kind of simple beauty of my reference. So I have NASA has these simple moonrise photos that they've taken. I'm not sure if these were taken with like a satellite or whatever, but these are NASA reference is always great, and NASA, it's all public domain, so it's like a moonrise. So I wanted to be like, see if I can do like my text is rising over the planet, and it was also based off of this panel from the comic. Let me see. Yeah, so it's based off this panel for the comic, and I wanted to kind of do that red mountain planet from earlier with like the logo slowly turning overhead. So that was really cool. The final scene, let's see. The final scene was ripped straight from the comic. Here's my just like layout build that I did in Blender real quick. It's like Spaceman Spiff is Calvin, and he's on top of like a mountainous blanket, ready to cause some mischief in the middle of the night. I was able to model his pet stuffed tiger Hobbs from the comic also in there too, just to throw that in for fun and give it like a 90s home video aesthetic. So yeah, that's my project. Does anyone have any questions so far in the YouTube chat?
I got one here, from David from World Blender Day. This looks awesome. As a big fan of Calvin and Hobbes, I love it. Have you had have you posted it? Have you heard anything from people, and maybe Bill Watterson or anything?
Well, Bill Watterson's kind of like a recluse, so I doubt that nobody hears from Bill Watterson. That would be like, if there was a way to contact him, I would have by now. But I mean, I haven't heard anything like official, but like when I posted it online, I got like when I posted on Reddit, I got like a couple 100,000 views, and then I posted on YouTube and I got like 40,000 views or something. So I got like a good number of like people that were like, a lot of Calvin and Hobbes fans out there were really excited because this is like, this is me going crazy and making the best Calvin and Hobbes thing that I've ever like seen in my life. You know?
I feel like you should just do a 90-minute movie at this point. This is so awesome to look at it and keep that 90s VHS aesthetic too the whole way. It's awesome.
Yeah, I know. I mean, I honestly, I have like a whole idea for like I had like an idea for like a 6-minute like short and stuff like, right. I mean, I got to pay my rent. So I was like, this was kind of like, I was doing this like in between jobs almost for fun and just kind of like pouring all my money into this while working. I do want to continue it possibly, but I want to keep kind of in the spirit of the comic. I'm not making any money off of this or anything like that. So it's like, there's only so much I can do, I guess, you know, but I mean, there's always those ideas that I have in my head for doing more, you know, but yeah, thank you for the comment.
Yeah, well, we got some we have some really positive comments in the YouTube chat, like pretty awesome reel, whoa, well done, impressive. I guess you were showing off some of the Marvel stuff, and it said talk about industry standard, cool Avengers Endgame logo made with Blender. So people are pretty excited about what you're showing.
Oh yeah, thank you. Yeah, I set a very high standard. It's got to look. I try to make my stuff look better than most movie stuff. It's kind of like ruined movies for me because now I watch movies very critically and I'm like, oh, they messed that shut up. Oh, they messed this up. But yeah, so I set a very high standard. I could move on to a if we don't have any more questions. Stop me if there are any more questions, but I can move on to this.
Will do.
Yeah, I could move on to this thing I did. I did this thing for Tom and Jerry a couple of years ago. Because of COVID, movie work has been slow and I miss going to theaters. But here's a super small thing I did for Warner Brothers. Here, you know what? Let me see. Let me optimize this for video real quick. Optimize for video. I'll play this twice because it's really quick. I did this for a Warner Brothers internal reel using early concept art from Tom and Jerry. So this wasn't in the actual movie, but it was used for like a sizzle reel that Warner Brothers was like doing internally or something. But it ended up looking really cool. And this was done like 100%. I used concept art and I did like 3D projections. So this was done 100% in Blender with the cycles renderer. Let me play it real quick.
I'm afraid we might be getting the choppy version again. Did you reshare for video or?
Oh, you know what? Let me share it on my 1080p monitor. I'm sharing it on my 1440p monitor. That's probably why it's doing that. Let me.
Did you optimize for video or?
Yeah, I did optimize for video, but here.
Okay,
well
then just disregard what I said. Actually, now that I see it on the YouTube channel, it's actually looking fine. So.
Okay,
sorry to interrupt.
Here, I'll just play it again real quick. Yeah, so that was a cool little thing I did for Tom and Jerry. I love Tom and Jerry, so it's like like the fact that I got to do that little thing for them, you know, was pretty cool to me. Yeah, the movie industry has been pretty slow. I do have more movie work, but you guys are gonna have to wait like maybe like 6 months or so until that stuff comes out. Everything's been going pretty slow lately. Let me see. So I'm gonna go over for my last project. Let's see, I got 8 minutes left. I could probably go over this real quick. I'll show you guys a new idea that I've been working on recently. I formulated a concept in my head for Sky World. Let me stop sharing and reshare without optimized screen share. There we go. So I formulated a concept for kind of a sky world where a bunch of brutalist towers are attached to and sucking the lifeblood out of like a large eldritch tree structure. I'll show you soon. Let's see. I start with a mood board and I try to find the best reference possible. So I'll show you kind of like my workflow style. I feel like a lot of my work gets overcomplicated. So for this project, I'm trying to focus on having more negative space, rest area, and simple shapes. So check it out. Let's see. So here's my mood board. I build these mood boards out, and they're important to kind of have an idea for what I'm making. Like I could go on and on about like the technical side of Blender and stuff, but recently I've been trying to focus more on kind of like the art side. Now that I've like learned the technical, I try to focus more on the art side and try to get across like the feeling of the artwork. So I'll usually be working and I'll have like this mood board on the side. You can get kind of an idea. I want like simple shapes and like simple geometry, like really epic type scenes. And I have this mood board on the side so that I kind of stay on track and I don't just trail off randomly. So the first thing I did was I built this tower in Blender. I modeled this brutalist style tower. I love brutalist architecture, so I wanted to build something with simple shapes, curvature, and negative space. This was almost like a sketch where I just sat down and I was thinking like, okay, what can I come up with? And I just kind of like randomly just like came up with this, you know. You can see my UVs over here. For the UVs you can see a lot of overlap and me breaking kind of the typical UV rules, but there's a reason. If I need to do proper UVs, I use multiple UV maps a lot. So if I need to do proper UVs or UDIMs or whatever, I'll do that in like a separate UV map. But for this one, Blender has a very cool UV squares add-on, which is super cool. It basically makes I'm able to make these really curved shapes and kind of like map them onto squares. So I keep in mind like the UVs when I'm like modeling this stuff. So I'm able to map it onto squares. And so when I build my master material, which I'll show you in a second, it'll follow the shape and curvature of the mesh and it'll look really cool. So next I built my Eldritch tree, which is like I found a cool procedural way to sculpt and art direct it to be use the awesome new cloth brush to make a sort of like wrinkly tree base. So you can see I was just pulling stuff around with the cloth brush and doing stuff. And then after that, I created an SVG file of tree roots, and you can import SVGs. You can import SVGs in Blender, so you can see the SVG of like some tree roots to make I made like a bunch of Boolean subtractions to give it like these holes and these root type shapes that like, you know, trees are known for, like these root shapes and stuff. And the mesh obviously was like crazy. So I took this wacky Franken mesh is what I'll call it into ZBrush and sculpted out like the secondary and tertiary like branch shapes. I did the UVs in there, and then I'll show you the scene that I sort of built here, right here. This is the scene that I've built. So now you can see my like Eldritch Horror tree is like the huge looming tree in the background. Then you have my brutalist towers extending out into the distance. I use the array modifier. I love the array modifier. It just helps me just like get it done quick. Blender's been super great for building out these sort of like pre-visualization scenes and compositions, so I can get an idea and visualization for how the scene should feel. I used the array and curves to make the towers and wires, and quickly made this mesh with the mesh at the bottom with cloud displacement to sort of feels like a cloud layer, so I can get sort of like an idea of what I want it to look like. I can edit the cloud later. Next, I went into, I'll show you my crazy, like, I feel like I'm going crazy when I make this stuff. I went into Substance Designer real quick to build my master material here. I have this mountain material that I built in World Machine a couple months ago, and I never really used it. And I was like, now's a good time to use it. And I found an asset for trees, like tree bark online that looks really cool. I forget what kind of tree it is. If I looked at my reference, I would remember, but it's like a special tree that's like, has a lot of like root type shapes. Let me see. So this was my master material for my tree. You can see all my crazy node setup right there, and then here's my material for my towers. My thing is like I built this first material a while ago for the Spaceman Spiff project, but my issue was it was kind of like, I would say it was kind of like noisy, and there was no really like rest space. So I built these. So I was able to find this material online where I could build this kind of like these huge like rest areas, I would say, where it's like there's like very little detail, but it's like very like micro detailed. But then you can see like the super insane detail down here, and this is my crazy node setup, which is I was kind of going insane, just like art directing this kind of in my head. And my whole scene just has these two materials. What's great about Substance Designer is you can kind of iterate on them. So I make multiple materials out of these nodes and stuff. And let me show you here. So after I do that, I built these wires in Houdini. I built wires in Smoke. I took the curves that I had done out of Blender, and I did this thing where I select random points, and then I like kind of like connect them. It's animated too, so I've animated it to be like right now I haven't done like a final animation, but I plan on doing an animation. So these will be like swaying in the wind with a proper like sense of scale and everything. Let's see, and then I import everything into Maya real quick. Maya is kind of where everything comes together. The scenes are super heavy and slow. It takes like 5 minutes to load the scene up. It takes forever. I think it's because of my Substance plugin and all those nodes. But it works somehow, so I use it. I'm doing my render with Redshift. I experimented a little bit with the Redshift renderer in Blender, but it was crashing so much. I just couldn't get it to work. It was right now the Redshift renderers for Blenders, it's really cool, but it's like in the beta stage right now. So I think I'll wait a few months for that, and I'll probably do like a project in Blender with Redshift at some point, I'm pretty excited for that coming up soon. So let me show you when I rendered it out, this is the final image. Oh, have I run out of time?
Well, we are getting towards the end, but I did have just one question I wanted from the audience about the Spaceman Spiff. Did you handle all the sound design, and I guess like what about the rendering? Do you have a render farm, or did you use an online one?
I thought about using one, but I bought a 2080. I have a Titan XP in my thing. That's why I use Redshift, because Redshift's really quick. It's a GPU renderer, and able to render quickly. I had to do some denoising, obviously, just because I just got to get it done quickly. I'm too cheap to pay for a render farm, so it was mostly. But I bought a 2080 Ti, so I've been using that. I have 2 GPUs now, so I've been using that for rendering. I like begged my friends if I could render on their computers too, but, but I don't know. So far it's worked out. It's kind of like a crazy process.
Sound to me, I've got like 4 GPUs. I'll help you out.
Oh yeah, if you could, I'll definitely probably have to hit you up next time I do some crazy render. That would help a lot. I need to buy more GPUs, but prices are insane right now. Yeah, I did. So the sound design was actually sounds very important to me too. So I did like half the sound design, and I hired a professional to do the sound design, like to do the score and stuff. But of course, I was art directing it. I was giving him notes, and then I took his they're called stems. So I take his like different sounds that he's done. He sends it to me like in a bunch of layers, and I kind of add my own little flourish. So his sound design was good, but in order to like, you know, get it like really good, you know, I had this idea for like, I like clickiness and I like epic stuff, I guess, and I like keeping it simple. So I added my own little like flourishes here and there for the sound design. It turned out good.
Awesome. Do you use a denoiser? Another question.
I experimented a little bit with, I have experimented with all of them, and so far there's this plugin for After Effects called Neat Video Denoiser. It's only like $100. It is the best denoiser. It's better than any of the machine learning denoisers. I don't know. It's like, it's basically magic. I don't know what it does, but it's like the, I feel like that's like the industry standard denoiser. Basically, it's Neat Video Denoiser. It's super cool.
Right on.
Yeah.
Well, you got a bunch of positive comments in the chat, like amazing scene, brutalism architecture reference, really epic 3D
Oh,
techniques.
awesome.
We really
Good to
appreciate the
know.
art side of things. Plus, somebody
Yeah.
says like, you know, would rock as an animated short, obviously the Calvin and Hobbes thing. But unfortunately, I think we're at time. So if you
Okay.
could just finish up and we'll transition to the next speaker.
Okay, yeah. I mean, I can just finish up here real quick. This is very much a work in progress, but I'm doing kind of like what the matte, I see the matte painters doing this, where they kind of like take the render and then they paint over it. So I'm painting over it with layers in After Effects, and I plan on taking these different cloud layers, pulling them apart, and whenever I do I'm gonna keep my final animation pretty simple. It'll just be like a simple camera move, and it'll like have that depth, you know. Yeah, so that's all the stuff that I've really worked on, and
Awesome.
give me a few more months and you'll see something more cool stuff, you know.
Yeah, we can't wait.
Yeah.
We can't wait. The Blender scene in the chat says more alien sci-fi post-war architecture.
Yes, that's what I'm into. Yeah.
Cool. All right. Well, Joseph, it's been an awesome session. Thanks for joining. And yeah, I think really well received by the group here. So we really appreciate you joining World Blender Meetup Day. And we'll look forward to what you have to show next year.
Awesome. No problem. Yeah.
All right. I put the links for where people can find your stuff, including your demo reel, the Calvin and Hobbes, all of that in chat. But feel free to hang out in the YouTube chat and answer any questions people
I'll
have.
hang out in the YouTube chat for sure. Thank you.
All right. All right. Yeah, sounds good. All right, Damien, are you on the line?
Yes, hi.
Perfect. All right. Thanks,
Hello.
everybody. Our next presenter is Damien Rohrbach. He's coming to us from Mexico City, and he's going to be speaking to Blender for jewelry design. Damien, why don't you introduce yourself and take it away?
Hi, everybody. My name is Damien Rohrbach. I'm a jewelry designer, a jeweler. I was a jewelry teacher for 17 years here in Mexico City. I had my own jewelry school. So I'm going to start, well, I'm first obviously very happy to be here. So thanks for the invitation.
Welcome.
It's also wonderful to see so many differences between the presenters. So, well, I'm mostly famous for all the jewelry designs and renders that I make. So first I'm going to go through designs I've been making these, well, I've been doing this for 20 years. So obviously I've done thousands and thousands of creations, designs. And well, my main job is jewelry making. That's how I pay the rent, like they say. Okay, so just you can see how varied is what I do, because I do create this is a very classical ring, a solitaire ring. This is for like a proposal ring when you want to get married. This is mostly what I do as custom jewelry. So, well, first I'm just going to drawings, also technical drawings. This was done entirely with Blender, then with Freestyle, then it's...
Hey, Damien,
Yeah.
I don't think your desktop share is working correctly. Can we just check it real quick?
Weird. We don't see, where is this Zoom?
So yeah, we're just seeing the thumbnail for your Zoom account.
Yeah. Return to meeting, share screen. Are we good?
It's coming through. All right, we can see. All right, we can see your screen. Go for it.
All right. So I was saying, let's go first through things I've been doing. So here we go. So I do so I was talking about this ring. This one was done totally with Blender. And then I do the freestyle technical drawing, and it's digitally painted with a Wacom tablet. So this is generally what my clients ask for: wedding rings, proposal rings. So that's very classical jewelry. This is done with LuxScore for the render. It's my favorite renderer lately. I started using it last year, and it's really wonderful. It wins over any other render engine available nowadays, especially for acoustics and the diffractions in the gemstones. So it's quite amazing. So this is also LuxScore. Everything is working fine now because I'm getting messages. I don't know if...
Yeah, we're able to see your desktop share just fine. We're seeing all these beautiful pieces of jewelry.
And I also do a lot of 3D sculpting. So I had to really train a lot. A couple of 5 years ago, I started making really heavy 3D sculpting, and because my clients, and this one was 3D printed and made in silver. And I printed it on a Solus 3D printer at 25 microns to really create a very, very small sculpture in silver. So we can see this one is like 3.7 centimeters high. It's really, really small. It allowed me to really check my sculpting level and also my 3D printer accuracy and the manufacturing process. This is the render with cycle. I also do a lot of jewelry drawing. This is traditional drawing. It's an exhibition I made 2 years ago after a trip I made to London. It's all based on the mythological beings. This is the griffin. It was mainly in gold over many pubs that you can find in London. Okay, this is something I made last month. Because I'm going to talk a bit more about my life story, because I've been doing this for so long that I run across many life problems. So it's always changing. So now I'm tending more to really 3D art. I'm still including jewelry in the scene, like the ring. Many people ask, what's the ring doing here? Mainly it's just a pretext to be starting from the jewel. The jewel was modeled entirely with Blender. And then I really inspire myself with anything really to create a real setting for the jewel. So in this scene, I really wanted to have the paper lamps and the clouds. In the end, I was very happy with the clouds. The clouds are also entirely done with Blender. I wanted really like cotton-like clouds and colored clouds around the Japanese ceramic. And so in the end, the jewel doesn't matter anymore really, because of the pandemic, I had to close my jewelry school after 17 years of teaching. But in fact, it's also because I got, well, I'll talk about that later. Let's keep on looking. So drawings, 3D model on the left, drawing on the right, obviously. And this is the jewel. So this is the prototype in silver. Also because obviously gold jewels are very, very expensive. So generally, before making the final version in gold, I create prototypes in silver. Mexico is really the silver country. It's the most, we have the most productive silver mines in the world with Peru. So obviously also the jewelry production in Mexico is huge. Mexico produces tons and tons of manufactured jewelry per year, gold and silver. So the exportation is huge. But then also I create really crazy and more artistic jewelry. This is a cathedral ring. It's really huge. It's obviously made to impress. And these are for clients that really want to show off in events, red carpets, and all of that. This was done. This is a friend of mine. He's a professional photographer who took. We made a photo session a couple of years back. This is a phase 1 ultra high resolution photography. It goes up to 15,000 pixels, I think, or even more, 20,000. This is the monkey I just did yesterday, obviously for marketing and PR of the event. Okay, more drawings. So really, and sometimes, like I said, I create scenes. This is Jules Go to the Pool. So there's part of a concept I started a couple of years ago that I really want to take the jewels all over the world and also into space. In a couple of, well, it depends, because each month I create a special scene, because I also create assets, 3D assets, and sell the assets. And also because of my YouTube channel, my members get some steps of the scenes I create at early stages, but they do get quite a lot of the 3D scene. This was done for a client, custom cross. And also, well, like I said, I'm sometimes working on way more complicated jewelry, so I have to sculpt. This is a project I started last year. I'm still making an animation. This is just a preview render. Okay, and like I said, then I go back to very classical commercial jewelry. And this also was done for a client. This one was done totally with Blender because the grooming in Blender is just amazing. The hair system, and then it was printed. Many of my clients, well, I design for them and then I don't manufacture the jewel. They print them, they then cast it in gold or silver, white gold, platinum, mostly here in Mexico, but obviously I have clients, well, almost all around the world. Sometimes I try to make more realistic renders or more geometric jewelry. So I really range over all the spectrum of the jewelry field. And some people just don't know that. That's why I was very happy to be able to take part today in the World Blender Meetup Day, because many people, because I have a lot of websites or social media, and most of the people just see tiny parts of what I do. And also because most of my models I can't really publish because the client doesn't want it to be published. It's a custom made piece and he doesn't want any promotion about his jewel. This is a jewel I made for an American jeweler. He wanted a lion. They already had the gemstones. So most of my clients send me drawings or very specific technical precisions about the jewels. And that's why we're working really in a niche market. The jewelry design field or industry is very closed, and that's a big problem also for teaching. I'll talk about that a bit more later. And let's move on. So sometimes just have fun.
Hey, Damien, quick question somebody had in the chat for you. So
yeah, of course. Go
it
ahead.
said, did Damien have lenses to observe the micro details in the Ganesh skull? I'm not sure what they mean by lenses, but
is that a question? I didn't get the question.
Yeah, so the question from Blender Scene is, did Damien have lenses to observe the micro details in the Ganesh sculpt? Oh, maybe, I see. Maybe they were just talking about how the micro details were so
okay,
detailed.
yeah,
You
that's
might have needed
no, actually,
lenses to see
one
them.
of the only tools that I don't have yet. I have a microscope for gemstones because I was teaching gemology for also, well, those many years. I still don't have a binocular. In the jewelry field, we do use the microscope for gemstone setting. That's very common now, and a request, a professional obligation to use a binocular lens to do the gemstone setting, because obviously what we're doing is very, very, very small and can be very tiring for the eyes. And that's something I don't have. I'm not that old. I'm 42 years old. I consider I'm just halfway into my life. I hope so. I mean, I hope to be living like 40 more years at least. So my eyes are not tired, but yeah, that's true. No, I still don't use lenses, micro lenses for what I do. But I should be, I think this year or next year, I will be buying those famous binoculars, because yes, I do manufacture. So sometimes I create, there's a kind of humor sometimes that a lot of people I know still don't get in my creations, because many times I don't have the time to comment or explain well why this is more like a humor, because obviously the scale of the ring is totally wrong. It would be like a huge ring sculpture, and it's a very simple ring. But this is also, the concept is to talk about the fact, because I sometimes create very intricate jewelry, there I put the most simple ring on a pedestal in a museum, and that's to express the fact that mostly simplicity is best, is better. This is also like the Japanese Zen concept. That's why, well, I've never been to Japan, which is very funny, because I do have a lot of Asian influence, Greek influence, Egyptian influence, because of, this is an Egyptian sacred scarab. This is an animation I'm working on with the butterflies. All the wheels are, so I've started working on animations, and also because our field is not so big. So I'm really always working on new creative things in my jewelry field, to do things that other people are not doing. So this is an animation I've been working on since last year. More drawings. This is the unicorn. The idea came from a tapestry from the V&A Museum in London. Renders. This was the first test with the optics, denoising and rendering with cycles 2 years ago or 1 year ago. So sepia and color version, more engravings and rings. And well, this is, I think, the end of the images. I'm starting over a bit because, like I said, I've been teaching during 17 years. But let's go now at the, well, I'm going to make a presentation about me, not especially because I'm so important or things like that. That's not, in fact, my character. But I was born in Switzerland, but my mother is Mexican. So half of my life has been in Switzerland, where I got all my education. And obviously, it's a bit of a weird life, because I never fitted anywhere. In Switzerland, people just find me weird because, well, I was raised between Switzerland and Mexico. So I never really had the Swiss culture. And in Mexico, obviously, I'm way too white. I'm a European. So I'm not a Mexican for Mexican people. But the problem is that both countries are my homes. And half of my life now has been in Mexico, where I had the jewelry school, and that's where I'm working now. I have a lot of clients, obviously, in Mexico. So first, I was a painter 20 years ago, and I used my Mexican name, which is Viaras, and I managed to, I really had a very successful career as a painter. In the year 2000, I started a jewelry apprenticeship in Lausanne, where I was born. I was very, very lucky to find an apprenticeship space, because there's basically none. And that changed my life. I started working in the jewelry field. I really learned working the metal, melting the metal, soldering, stone setting, jewelry drawing, all the old school traditional jewelry process. And actually, that's a huge problem all around the world, because we do lack jewelers. There's very few good jewelers anywhere you go. New York, Paris, Mexico, Dubai, Shanghai, anywhere, they're lacking of really skilled jewelers that can make the jewels. So obviously, something that people don't really like to hear, but it's true. You shouldn't study jewelry design if you don't know how to make your jewels. That's something people don't want to know, because first you need to get your hands dirty, and jewelry making, working the metal, melting it, bending it, soldering it, is obviously really hard. It's not the easiest craftsmanship around. It's really hard, and it's really slow. At first, just to make a silver wire, a gold wire, from the silver comes in small pellets. So you need to mix it with copper, melt it. It melts at 1,000 Celsius degree. That's pretty high temperature. You could go higher. Platinum melts at 2,000 degrees. That's more extreme, but obviously platinum is also way more expensive and a lot harder to work even than gold. So that's the problem that we're gonna go through. So then I moved to Mexico, and I was simply supposed to keep painting, because I already had clients in many countries. I've already have made a lot of exhibitions, and I was really a painter, even if I've been studying jewelry. My plan coming to Mexico was to have my workshop here and just keep painting. But people were just not interested in my paintings in Mexico. But all my jewelry creations, they got the eye very quick of many people, and I started teaching in 2004. So that's way back now. For me, it's like the past. But I was already teaching 3D jewelry design in Mexico City, and I was the first to do that. Nowadays, 3D jewelry design is very common. 3D jewelry visualization, sorry for my sometimes complicated speech. So nowadays it's really common, like architecture visualization and many other fields. But in 2004, it was, people don't even knew that you could do that. So I was working with 3D Studio Max, and that's when I started teaching. So I was an employee. I started teaching in a school here in Mexico, but a couple of years later, I created my own school in 2006. That's the old website. I'm going to keep it alive because there's a huge collection of photos of drawings, jewels we've made over 17 years. Actually, sounds like a joke, but I might try to get a Guinness record for that collection because I have thousands of jewels, photos. So that makes it very special collection. So obviously, if you're interested in jewelry making, jewelry design, I'm keeping it as a museum so people can have a look at how I come to be what I am today. So 3D Studio Max in 2005, I've made an exhibition. These are 5 posters I've made for an exhibition in 2005. So these were real scale posters. They were like 60 per 90 centimeters big. And each render took like at least 24 hours on a Pentium PC. I was using Mental Ray back in the day. So we already had caustics. We can see, especially on the render on the right, these are cufflinks. And all these jewels I've made in real life. I don't have the pictures anymore. And well, basically everything just went way over my imagination. So over the years, I really, well, I had TV shows, fashion shows. I work with big companies from Spain and the US and here in Mexico. And I obviously created my own brand. But the funny thing is I was Viadas the painter 20 years ago, and I became Rohrbach the jeweler in Mexico. So my life flipped already once or twice, and I had to adapt every time. So then 3D printing became a reality. In 2008, I had access, we had access to Solidescape's machines. And then I bought my own, I bought a Solus 3D printer in 2017. So that was pretty late. At first, I would send to other businesses for a 3D printing process. And that was a huge change because I've been modeling 3D things since I was a child. I started on an Amiga 500, like many of you, I know, because I've published about that and I got a lot of comments. Well, that's our generation. When we were childs, computer like the Atari, Amiga, obviously PC, ZX Spectrum and all of that. Well, some already had some kind of 3D softwares or games even. So I started 3D when I was 10 on Sculpt 4D on an Amiga 500. But nowadays we can design and see that materialized in real life. This is mind-blowing. This is, well, it's obviously a huge revolution. So for me, that was back in 2008. We're in 2021. And the crazy thing for me is that, in fact, 3D printing for me is almost over because I'm getting bored of it. I've made so many things. Okay, so something important that happened in my school is that I work a lot with 3D CAD software. It's a French software, and I became the Mexican official school and instructor here in Mexico. So that's one of the top softwares for the jewelry industry. When that happened, I thought, that's the top of my field. That's amazing. What's next? Well, the things that happened is that I started losing students. And I was, what's going on? I'm working with the best software, which is 3D Design CAD, and I'm losing students? Why? Well, then I started looking more in depth of the difference between like Europe using a French software. When you're in France and you go to a jewelry school, your main goal is to finish your career and get a job in the jewelry industry field in France, which is amazing. The French brands, Italian brands, American brands, they have design areas. They have a lot of different areas you can work. So when you come out of your jewelry career in France, it's the dream come true. You are going to get a job the next day because, like I already said, there's so few skilled jewelers available that when you study jewelry making, beware jewelry making. If you're good at making jewels with your magical hands, you are going to get a job because the jewelry business is, well, just look at the new brands.
each day you can find new brands. These guys, they need jewelers. Designers, well, we'll talk about that later. But it's way harder to be a designer. So in France, you take your career and you want to be a well, you're going to end up in the jewelry industry right away. In Mexico, that's not the way it goes. All the students that studied with me, they created their own studios, brands, workshops, making jewelry and designs. They became a one-person enterprise. Okay, that's the huge difference. So they start with almost nothing. They don't have money. And the thing is that with 3Design's CAD is really expensive. It's really, really powerful, but it costs several thousands of dollars. So obviously it's more oriented to the jewelry industry. It's a fantastic software, really, really amazing. When you need to change the size of the ring, it's going to be done in seconds, and everything is parametric. So all the stones are going to move into place in seconds. It's amazing. So how did I get to Blender? Because that's we want to get to Blender. I want to obviously show you a couple of things in Blender. That's what we're here for. Okay, so I had to find a solution, and the solution was obviously Blender. So here was with Blender. The other problem that we have in Mexico, it's like almost everybody is using Rhinoceros. Almost everybody knows that software too, but piracy, everybody almost uses Rhino, but they don't buy the software at all. So here, the ethical part of the work field, the professional field, is almost inexistent in Mexico. That's very weird. It's true. I was there too, that's why, but I was sick of that. I didn't want something involving piracy because for me, being moral and ethical in my job, in my entire life, basically, was always very important. I know sometimes you don't have the money, especially when you're a student, to buy now a subscription to Rhino, to Photoshop, to any kind of software. You need to learn. So, well, obviously many people copy the software, but Blender was the absolute blessing. So I knew Blender in 2010 when I made a first scene test, but then in 2015, so 6 years ago, I started using Blender, teaching Blender. And I was teaching these all cufflinks. It's one of my favorite examples because we have all the steps from obviously the drawing on the left, then the 3D sculpted jewel in Blender, the render made with cycles, and then on the right, the cufflink already made into real life in silver. So that's what I was saying already in parts. The problem is that the world lacks jewelers. If you really want to...
Quick question for you, Damien. So we had a question in the chat. Are you planning to publish a course on designing 3D jewelry in Blender on the side of your YouTube channel?
Yes, I was starting to think about that. This year it's a goal, obviously, because I need to pay the rent, like they say. Obviously, my channel teaches almost everything already, but it's true that I'm planning on making a full comprehensive jewelry design with Blender and also for 3D printing, because there are things that I can't really just say out loud in public. So yes, of course, very nice question. Okay, so that's on YouTube. So I've been making a lot of more advanced scenes. And okay, now the problem just about me. I have a couple of 2 years back, I had to go to the doctor because my leg my left leg is twice as big as my right leg. So that was very weird because I do a lot of sport. I train a lot. I generally have been really healthy all these years, maybe working too much. When you have your own business, you tend to work too much. Like I already talked about that to other people. Toon Roosendaal, the founder of Blender, actually, well, he got leukemia, which is way more severe than what I have, but he also expressed the fact that he needed to change his life, and I really understand that because I'm in the same process. It's pretty slow, but here we go. It means that I can't really sit. Well, I was always on the move and hyperactive. In fact, I have a very weird vein configuration in the left leg. It's malformation since birth. But the doctor told me I was very lucky because, well, but that I should really change my life. Why? Because the thing is, I really could really make a heart attack in 5 years or really sooner than I should. So, well, basically, I stopped teaching the way I used to. It's really recent. I stopped teaching a couple 4 months ago in December. That's when I really stopped. And I'm going back. That's why I'm also rebranding my work. I'm joining my names and I'm going back to a fully artistic world. So then came the pandemic, which, like many presenters today said, everything is going really slow. Obviously, the entire world is on lockup almost. Here and there. Here in Mexico, we can go out if we want. We can work, all of that with all the security protocols, obviously. But for me, the transforming my life process came 1 year before the pandemic, or I was already in that process. And here I am again. Lucky for me, I have my studio, jewelry studio here at home. I changed place. In all my professional life is changing. All right, but now let's go to Blender. So this is just a quick view of the scene I made last month, the Japanese Zen garden. But that's not what I want to really show. What I want to do, okay, let's make a new file. We're going to create quickly. So let's make some jewelry design here. So like many said, the SVG format is way underrated. You can always, here I have the Blender logo to SVG, so we bring it here. The wonderful part of that is that it comes as curves or meshes. Yeah, this is curve. We can see the icon here. So the SVG imports really well in Blender. And then, well, then we can start. Wait, who is who? We're gonna hide. Okay, that's the reason. Well, actually, I can just take that. So if you don't know how to make an SVG from anything, you can find that on many channels, but you just go like GPG to SVG. And there are many websites on the web that will take your image and make the SVG of that file. So that's how you end up. If you don't have the SVG version, I think there's available on the blender.org, but I don't remember. If it's not, I just made it from the PNG image to SVG format. So then you can import it. That's when you don't really want to model something or sculpt something. This is the cheapest, easiest way to make 3D of anything. Now I'm going to make a mesh. Did I know, sorry. Here, mesh. Okay, now it's a mesh. So A, extrude on Z here. And this is already a solid that actually I can 3D print. So it was done in seconds. So sometimes when we need to design something and manufacture it, it can be done in seconds. It's that lousy sometimes. But obviously, if you want to set stones, okay, so what I was saying about being first a jeweler and then becoming a jewelry designer is that the size, the dimension here, I have 0.111 meters. Obviously, if it's on a relative scale, I can say these are millimeters, but this is way too small. The problem of the sizes, the scales in jewelry making is a huge problem. If you're not a jeweler, you will have no idea about the thickness you need to use, the size of the pendant, the weight of the pendant that is adequate. And the only real way, the really good way to know that is to manufacture jewels. Obviously, you can study maybe with me on YouTube or later on buying my course about jewelry, and I'm going to explain all that. But you won't have a real relation to the jewel or such a good connection to the jewel if you first don't study jewelry making. And that's a bit sad. But in the jewelry business, we have a huge problem that I don't know if it happens to architects, but I don't think so. Meaning, nobody says, oh, I'm going to design a house, a 3D house, and pretend I'm an architect. It's really, I can draw a house. I can draw a house, but I will never say I'm an architect because I just drew a house. Because to make the house in real life, you're going to need a lot of technical solutions, the electrical system of the house, the water system, and like making the house. Obviously, the architect is not the one bringing the mortar and making the wall in real life, but he participates in that process somehow. So obviously, if you don't know how a real house is made, you'll never be an architect. Well, or shouldn't. In the jewelry business, you can't imagine how many people just make any drawing or any render, and they're just calling themselves jewelers, just magically. And their famous names, obviously, well, I can call names even if they're friends of friends. Paris Hilton once was a jewelry designer. Obviously, it's just marketing, but that shows something that happens way too often in the jewelry business. Luckily, they don't last much because they tend to fail because they technically know absolutely nothing about. If I want stones, obviously I'm going to go for a gemstone. Let's go to any, okay, here, and let's bring a diamond. Diamond here. Okay, so now where's the little diamond? It's down there. Little diamond. So what size should my diamond be? Like I was saying, if you're no jeweler, you'll never know what's the correct size for a stone. Well, 2 millimeters. So obviously I'm going to work in meters. So I'm going to copy the scale right here. So now I must put this to scale to set the stones in the pendant. Okay, so now also a subject that happens a lot with me is that I know I don't use, there's a very good and very famous jewelry add-on, which is Jewel Craft for Blender. I don't use it, but I already explained that I don't use it because in my workflow, I never have to do twice the same thing, never. That's why I started showing things that I have done. Nothing looks alike. Some days I need to create a very simple ring with just one stone. The next day I need to create an entire bird with stones and flowers with stones, and the jewel has 1,000 stones the next day. So the problem is that for me, the add-on just blocks my workflow. So, okay, so here we are. I put the pendant or my logo in scale with the stone. So the stone is giving the scale to the rest of the jewel. Now I just need to look at the thickness. So that would be 4 millimeters. It's too thick. It should be 2. That's more for weight issues. And now let's go the stone must come out just a bit. So obviously I want to complete this one. So then when I start setting the stones, I start in strategic positions. And what I first just need to know is a proper distance between the objects. When I, let's take 2.15. So once you know that, you just can copy and use a numerical placement. So I love doing it numerically most of the time. If you don't want that much precision, you can do it visually. At this scale, depending on the precision you need for your manufacturer, you'll be fine. So there's a row here. And then we start just distributing the stones. So that's for the stones. Okay, then the little prongs, they're basically just spheres. They're also, with 3D printing, they should be at least 0.5. Smooth. Okay, so here in edit mode, I'm just going to make the prong bigger like this. Okay, now, so depending on who's going to set the stones, the prong, they generally ask the prong to come out that much. Obviously, it needs to touch the stone. Let's go like here. And we need 2 prongs on the opposite side. And we need prongs. We need at least 3 prongs. Well, you can have 2 prongs. Well, all the gemstone setting field is not even the work of the jeweler. There are specialized stone setters which do the work of only setting the stones in the metal. It's an entire different job just for setting the stones. These are the guys that need the binoculars to really work every day. Just to explain that even for polishing the jewel, that's a job, the polisher. He polished the jewel. That's all he does all day long, polishing with buffs and special compounds for polishing and polishing the jewels, because polishing the metal is a science. There's the designer, that's what we're doing, a 3D designer. There's the jeweler. The jeweler basically just works the metal. He sands it, he cuts it, he solds it, but the jeweler doesn't set the stones. So that's not true in every country. In Mexico, and that's what I do the entire process. That's why I always have something to do, a jewel to manufacture. But that's not the commonplace.
Hey, Damien, just wanted to relay a question from the chat. Not sure if you covered this, but why not use the array modifier here?
I know, of course. But generally, it's faster. I don't have to explain that now. It's funny. I don't really use very much of the tools in Blender. Obviously, I use the array, but that's, let me just do, let me just complete this line. Let's say I just got there. The array is going to work only for this line up to here. Then what's going to happen is obviously the array won't give you the curve for the pendant here. So it looks crazy, but even the array modifier will be counterproductive in too many occasions. Obviously, this is so basic with you. Wait, that guy is making such a jewel, it's not even using the array modifier. That's crazy. But it's the way it looks like that, man, this guy doesn't know even how to use Blender. But in the end, it's just for workflow, a studied workflow. Here, I need to duplicate this guy and start putting 2 prongs on the external side of the diamonds. Yeah. So it's because I've done that a million times that I know I'm not going to the array modifier, but I'm not even thinking about it. I'm just going to make the jewel. And
fair enough. I think there was a similar comment.
So it's funny. That's a huge problem I have on YouTube or a thing like that, because obviously I'm not using the array modifier, but man, I did this scene last month. So obviously it's not about, it's weird. It's a really weird place to be for me. And also for the followers, because like, man, that guy, why he's using Blender? He doesn't know the tools. Okay, but okay, so this is actually this is enough for this. What I want to show, and also I won't say in this. We're going to make the monkey, and the pave is that it's covered with gemstones. So let's go with the subdivisions, 2 levels, and the smooth shading. So I'm going to append also the same diamond, should be here, okay, here. So again, I'm going to put the gemstone at, oh no, sorry, this is the monkey. Hey, monkey, don't shrink. Where's the diamond? Here. Okay. So that's a diamond. And Blender has, and that's why I work with Blender, well, actually every day. There's a very specific snap to face. We can use the center median or center, okay? And we're going to move and rotate. So for placing the gemstones, and let's turn it on. Okay, here, are we? I need to rotate here. Okay, so now are we, okay. So to make the pave, this really, well, again, it's a really basic function, but that solves the entire issue of putting gemstones on any mesh you want. And like I said before, I'm using very simple basic functions, but it's the way I use them that started making different results and attracting followers to what I do and growing what I'm doing. Obviously, I'm going to turn on the mirror modifier. It's going to be quicker and it's easier to start setting that. Then, yes, it's done all by hand. All the placement is done by hand. So now, obviously, in CAD softwares and in many add-ons, you could do the placement with tools. I do have access, and also, don't forget that I do have access to 3D Design CAD software, which is one of the most complete jewelry softwares. Nonetheless, many times I love, and I do it in Blender. So people tell me, but man, this is slow, this is not efficient. The time it takes are more based, because I've been doing this for 20 years. I choose my tools not always because of the speed. The speed in the jewelry making, or just in the making, there's a life issue. When you're trying to win speed or make things faster, just know the Murphy's Law. Something else going to fail. It will happen all the time. So maybe I'm going to win an hour or 2, or maybe even 10 hours if I use another tool than Blender. If I use a really specialized jewelry software, I'm going to maybe do the pave in, let's say, 20 minutes in another software. To do the Suzanne pave here, to make the monkey fully set, it took me 2 hours. For me, it's a good time. So obviously it's so slower in Blender, but that time blocks the rest. The rest won't fail. So I just take my time so the rest doesn't fail afterward. When printing, when making the jewel and all of that. Every time you try to rush things to win time, you forget the time is infinite. There's no less or more time. You're born into this world, you're gonna die someday. The day you're born, the day you die are already fixed. There's nothing for you to change there. And that's your relation with time. When you study jewelry, you very quickly start to know that there's a huge problem with the relation to time, between humanity and time. So then that's what I say, and I always say that when I choose my tools, I choose the one I like more, the one that makes me more happy. And making this process in Blender is just a lot of fun, because I don't have any pressure. If something goes wrong, I'm just going to correct it. That's why I do it one by one. And then I bring the prongs the same way. Let me just turn the snap off. Okay, so let's make the prong. And also the materials. I do have assets and libraries and all you want. Almost every time I make a render, I create a new material for the gemstone and for the gold every time. Because I want new scratches, I want a different color, and this is made more for creative reasons because, like I already say, life won't ask me to repeat what I do. So it's new every time. And well, obviously that's very proper to my job, to the way I work and to the way I live. Okay, now let's go to the mirror here and let's bring it here. All right. Oh, sorry. We need to turn the snap on again. Okay, here we are. So now, okay, this is pretty good. All right. So with the snap tool, it's really easy to set the stones and start making the prong for the stones. And that's why in 215, because before I really started teaching here, I'm going to remove the mirror. I made all the tests. The other thing you want when you're a jeweler is the Boolean modifier or the Boolean system to work very well. And in Blender, the Boolean system is really strong. It fails, obviously, like in any software, the Booleans are going to fail. But in Blender, it allows us to make very advanced Booleans, and it's really steady. And these are very, very specific issues when we're jewelry designers and jewelry makers. So in 2015, when I was planning to really start teaching and basing all my course and school more on Blender, obviously I teach 3D design, but more for jewelry owners or brand owners or designers already trained that need to get really fast and use a jewelry specialized software. But believe me, Blender is really work efficient and really fast. And well, the fact about add-ons or things like that, that's more really related to my artistic approach and my needs, specific needs with Blender. Now, things that are going to change a lot is that the new geometry nodes that are already in Blender 293 and all, I will be working with them because obviously we can start using the nodes. We can use the nodes, the geometry nodes, to start spreading gemstones over a mesh. This is amazing. So obviously the Blender developers didn't have that in mind. They have more like artistic or animation requests from the public, not really like a jeweler said, oh, listen to me, Blender developers, I need geometry nodes to make a monkey pave with stones and prongs. Obviously not at all. But what we do with the new geometry nodes, and I will be making, I hope not this month, but because I need to make a lot of tests with the geometry nodes, but they will be useful even for us jewelers inside Blender. And this is amazing. And that's why also I'm very happy and even proud and all that of that, because Blender is on the move, is moving forward, developing new things all the time. And what I love about Blender, and that's also why I don't use that much add-ons. I do use LuxCore, which is finally an add-on. I even use, is that I love simplicity and speed, speed of freedom, the freedom that simple tools gives you a lot of freedom. And there's even a very famous phrase that the tool is the death of creativity. And this is true. When you're a painter, you always end up using just one same brush, the brush that works. And that's what I loved when I was discovering Blender. Well, Tom Rosendahl was saying very simply, Blender works. And I'm very happy to see that Blender is still working. And it's becoming every day, attracting many more people. So in our field, Blender offers all the specific solutions. Blender has that covered. And then I started using Blender for renders. I could never imagine doing scenes like that or renders like that. We have the particles, we have the volumetric effects, we have so many effects, and these are just still images. I don't know if I still, okay, just maybe quickly if I find an animation. Where do I have an animation? Well, let's go to the channel then. Going to be easier. Okay, here. So that's the one I made last month. And actually, I did this one with cycles. Some people don't believe me that I did this in cycles, but it was done entirely with Blender and cycles. So that's why also for me, using Blender is so important.
Looks beautiful.
Thank you.
You're getting a lot of good feedback in the channel too. Lovely jewelry, Damon. Somebody loved your Pegasus and silver. Of course, you got fans of your studded Suzanne. You're really inspirational. So yeah, you're getting a good reaction there.
Great. Great.
I'm personally a fan of your jewel
Okay.
Blender logo.
Thanks. Well, it felt really good to be invited, and it's really great what you're doing with the meetup day. So really happy to be taking part in this, and yeah, inspirational. That's also what that's why the channel keeps growing, because we're going to travel a lot through the jewelry around the world, and like I say, even in space, I want to make some jewelry on the moon, on Mars, yeah, we need the jewelry industry is really stiff generally. They don't want something I didn't put here, but a couple of weeks ago, let's go to Instagram maybe. I did a render that had hair. It had hair on the jewel. So obviously, where is the hair? These are stone. Okay, this one. Well, here we can't. I know it's pretty good. This render has hair. Here we can see one. So obviously that goes on the totally other way than the jewelry industry. The jewelry industry wants really clean, sparkly jewelry, like the animation that I just showed, because they don't want the real life jewelry. Real life jewelry has scratches, has fingerprints, is covered with dog or cat hair, because that's what happens to a jewel. It gets dirty pretty quick. And that's what I want. I want more lively jewelry. And that's also why I started making a lot of more work around the jewels, but also because that's my story. That's why I did a wider life story section in my presentation, because obviously my journey into life already goes pretty much back, and I've already made and produced a lot of paintings and jewels. I've produced maybe, I don't know, 10,000 or more manufactured jewels in gold and silver and platinum. So obviously, yes, you get tired a bit physically and emotionally, and you need to reinvent yourself. And that's obviously why my body, my leg, starting to really express that. I'm tired of doing the same thing all the time. And yes, it was a bit sad to it was a bit sad to stop teaching, but beginners don't really realize that when you're already said a million times that you need to mix silver with copper to make the silver harder when you manufacture a jewel. Well, I had to say that a million times or even more. After a while, you get tired. But I also, that's not their fault, because I did everything the wrong way, the opposite way. Normally, I had to first make my artistic career, and then when I'm older, start becoming a teacher. Because generally you become a teacher when your life is already done, I guess, and you already know life, and you start retiring maybe when you're 40 some, 50, and so you become a university teacher because you know everything in a field, and you're very happy to transmit that to new generations. I started teaching when I was 25, and I was making my life as a jeweler, a 3D designer, as an artist. So obviously, that was a bit weird sometimes, or a conflict sometimes, because these opposites would sometimes just come head to head. I want to be an artist, but I have to teach, so I need to shrink and simplify my life to transmit it to a beginner. And in fact, I couldn't do that because I can't just simplify my work. I just need actually to expand my work. And that's why the word inspirational is central in everything that's happening with Blender. And I keep doing a lot of jewelry, but I want to extend that to the rest of the scenes.
Well, we're looking forward to what you're going to produce going forward, and everybody has your YouTube channel, so I'm sure everybody like me is going to be anxiously awaiting your geometry nodes versions, because we're all dying to learn geometry nodes. But we want to thank you for your time on the event today, Damien. Yeah, it's been really great. Like your artwork and your jewelry is amazing, and we would love it if you hung out in the YouTube chat, maybe answered some questions from people.
On Discord?
While we transition to the
YouTube.
next speaker.
Yeah, on YouTube, there's no problem.
Awesome.
I have
All
time
right. Well,
for you guys.
Well, thank you, Damon.
Guys. Thanks again.
Have a great rest of your day. Adios. Muchas gracias. And
thanks. Gracias. Merci.
All right. Thanks.
Have a nice day.
So,
everybody.
wow, that was awesome. So, okay. So our next presentation is from Mij Senav. I think I'm pronouncing his last name correct. AKA known as the Mantissa. So Mij will be presenting on designing experimental footwear in Blender. Let me go ahead and get that queued up. So that's very odd. Okay, let's go ahead and get that queued up, and yeah, we'll go ahead and take it away.
Hello, and welcome to my talk on designing experimental 3D printed footwear in Blender. Now, before we jump in, I just want to do a very quick background.
And I just want to do a quick sound check.
So you have
Andrew,
an idea
are you
of
on the
where I'm
line?
coming
Can you hear
from
this?
on this project. And you'll see that some of the stuff that I usually do actually ended up being quite interesting to apply to the project at hand. So yeah, I'm mostly obviously a digital artist. I use a lot of Blender, and I make all kinds of weird and wacky, interesting animations and renders. I really have a bit more of an experimental style. I enjoy trying out new things in Blender as well. And it was pretty cool to be approached by these guys for this research project. So I was approached, let's say, early 2020, I believe, by the Future Footwear Foundation. And they're actually looking for a 3D artist, basically, that could help them with, yeah, trying to find a way to design footwear in 3D that can be 3D printed. Now, really, there's a really big sort of research background to this project, which I'll very briefly touch on, so you've got an idea of where they're coming from. Basically, Catherine, the leader of our research project and the founder of the Future Footwear Foundation, is somebody that has been studying indigenous communities all over the world that use minimal footwear. So basically, what does that mean? Basically, there's a lot of people all over the world, a lot of indigenous communities that use different types of footwear. And really what minimal footwear is all about is the idea that you're using very little materials and you're sort of adhering to, let's say, the natural state of the foot as much as possible. So one of the things that I've also learned during this research project is that a lot of the shoes that we wear here in the West, at least, really aren't all that good for your feet to begin with, and do a lot of really crazy things with them for the sake of fashion and looking cool. Now, the idea behind this research project is to take sort of the tradition of this minimal footwear and kind of combine it with technology and innovation to see if we can create footwear that isn't only good for the wearer's foot health, but maybe kind of even betters the foot health over time. And that's the goal of the underlying research project. So the idea is that basically we want our feet to start doing the work again, rather than our shoes doing all the work and having our feet sort of encased in them. What we want to do is make sure that we, design something that strengthens the wearer's feet once more. And one of the hallmarks of people that wear minimal footwear or do a lot of barefoot walking is that their toes are completely spread out. And what we're trying to figure out with this research project is basically, can we get back to a state where our feet, whether you have worn minimal footwear before or none at all, can actually sort of open up again and see if the foot will actually try and restore itself to a more natural state. So with that in mind, we're trying to find a way to design these shoes so not only that they, serve this purpose, but also that they look a little bit cool. There's nothing wrong with designing something to look cool. We have about 50 people that are going to wear this experimental footwear for a number of months after it's been 3D printed. And really what we're trying to do is just create something appealing and make sure that we also, adhere to everything that the research stands for and that we need it for. So here you can see some early ideas that we were playing with. Basically, we want this idea of scales that sort of move independently, because the material that we're working with for 3D printing isn't super flexible. It's a little bit like flexible, but not really in the sense that you would think of as something like rubber or something else. So we need to design these structures in a way that they are actually flexible and they can move around without having material that's like super flexible and therefore breaks really easy, because we need something that can withstand being worn, up to every day for a number of months. And we were able to work with HP on this one for a special material that they're bringing out in 3D printing world. And for us, the hardest part was basically figuring out if we can do this in the first place, and how we're going to tackle this with the design that we created. So when they explained to me how everything was going to be done, I said, sure, that sounds really doable. Let's go for it. I'm interested. I definitely want to try and dive in and see what we can do. So then we started. And step one, basically, I'm not a footwear designer. So I learned a lot from Aisha, one of the other people in the project, who is a footwear designer. And we sat down together and tried to figure out how we could use this material to its fullest potential and how we could design, again, something that maybe looks appealing. So basically, the overall workflow for the project or per person is, first of all, we're going to take a scan of their feet. So we take a scan of the left foot, of the right foot, and that then is manipulated. So that means basically there's another part of our research project, Manuel. He's a student at the university, and he basically takes those foot scans and then turns them into sort of a convex hull, but with added sort of dimensions, a few millimeters here, a few millimeters there, based on other previous research that they're working off, to kind of give us a model, or at least as 3D artists, give us a model that we can start from, that we can start wrapping our designs around. That way we don't have to worry about the research part of it, and that can be really accurate. And we get something that we can just work on immediately and really focus more on the design and make sure that the shoe is flexible enough and that it, that it just works basically. So the cool thing is, before we started any of that, basically what we needed to do is figure out the material properties. That's like the hardest part of this entire process, is figuring out like, okay, this material, while it's very sturdy and it can withstand a lot of abuse, it also needs to feel nice when you're walking on it. So we started playing around with a whole bunch of patterns, which you can see here. And basically, the things we were testing was flexibility, but also strength, depending on the thickness. So we had patterns that maybe start really thin and end up really thick, so we can kind of pull at them and see when they start breaking. So we can define like a minimum thickness that we use for different parts of the shoe, that kind of thing. And we ended up going with sort of a bit more vertical pattern. And that allows us to have quite a bit of rigidity, but it can sort of flex open and open up as you need it to, which is really nice. So with that in mind, basically, we started pushing that further. So now we have these patterns, these really basic patterns that we know work. And what we can do now is try and overlay some designs on top of these. So what we're trying to figure out here is, do we lose much of that functionality once we start trying to make it look pretty? And this idea of these scales was from the start actually quite pervasive, and we ended up going pretty deep into that route, at least for the design that I'm creating, because there's another 3D artist who is working in a completely different way. And because obviously I know how to work with Blender, I ended up going the Blender way. So once we had those basic patterns, we started experimenting with even more of these patterns and 3D printing them. And every time we got these samples in, basically we're like pushing at them, pulling at them, sometimes even destroying them if they're not strong enough, just to make sure that, we have something we know we can build from, and that it's flexible and that it works, but it can also withstand being walked on or walked in. So the next part of that is design versus structure. So again, we noticed immediately once we did those patterns that, okay, if we want to add design in, it is going to affect the underlying structure of things, but we need to find a really good way to kind of maybe design a shoe first that's functional, that's going to work, and then put a design over top that won't interfere with it too much, so that we can get consistent results. Because that's the thing with research. Obviously, you want to have something that's quite consistent. I have to make 25 pairs of shoes, which I'm actually currently doing. We're in the production phase of the project. And we need to make sure that, all of those pairs, at least, or at least many of them, as many as possible, feel really good from first fit onwards. There might be one or two people or one or two instances where something doesn't align quite right, and then we can always go back if we have to. But preferably, we'd like to have all of them fit nicely from the start, be flexible enough to walk in, and again, look kind of cool. So we did that by doing small things like you see here, like this little sock that we created. And this was just to test the structure, for example. Like, okay, if we add a sole to this and we add this sort of overlaying structure, what happens when we bend our feet? Does it feel nice? Does it feel bad? Does it kind of work in the way that we expect it to? And from there on, once we had our initial results, we could actually start building sort of a base model for the mesh. So as much as I want to do everything as procedurally as possible, obviously you have to have something to start from. And what you see here is actually a very first version of that base mesh, which was divided up into 4 parts. We had the sole, we had the top part with 2 flexible parts around the heel, and then with the heel part itself, which is solid, which is meant for just rigidity and to make sure that that part of your foot is nice and solid and you can walk around and the shoe sort of hugs around it. Now, again, this is a very first iteration of it. As we tried more stuff, this changed, and sort of the end iteration maybe seems really simple on the surface, but you'll see later on in the presentation how that sort of translates to becoming a full shoe. So my idea is to have a few basic parts. So in this case, the sole and the heel actually ended up fusing, becoming one big part. We still have those flexible parts on the sides, which we're going to use some kind of mesh in that we used for the research, so we know it can flex a little bit when you're going in and out of your shoe. And then the top part, which is has a whole bunch of design and stuff on it, and also has an underlying mesh for structure and rigidity. And the mesh that you see here seems like really basic, but to me, the idea is that I want to have a mesh with as little points as possible that I can easily map over one of those foot scans, and then have an entire procedural system that basically does the rest of the work for me. Again, 25 pairs of shoes is 50 shoes, and I want to make sure that I can get everything done in the time that's allotted to me. So I want to make sure that whatever I need to tweak at the start is as simple as possible, so I can just keep it very quick. So once we had a system going, we ended up having a whole bunch of prototypes, and this is sort of where the fun started. And not necessarily every shoe that you see here was printed, but it gave me a chance to build a procedural system that works and try different feet, because even though we didn't always have all of the participants scanned yet, we had our own feet and actually have multiple pairs of prototypes that I've worn, that I've gotten printed, which is really cool because suddenly, you're so used to seeing all of your work up on a screen or in a video or something like that. And all of a sudden, here's this like 3D printed live version of something you created. And, what's even more wild is that you can actually wear it. So for the first time in my life, I was, wearing a shoe that I made. I can tell you from, the first prototypes weren't necessarily all that, how should I say this, all that comfortable, but we were able to iterate quite quickly because, these are fairly simple models and I can very quickly change ratios and that kind of thing. And depending on the research that was still being done in the background, maybe the manipulations to the feet models changed. So we were quickly able to adapt to that. And you can see I kind of went wild with some of these designs. And after a while, trying some of this stuff out, we hit sort of our first milestone. And this is pretty far still from the final result, but there's something in here that's quite interesting, is basically both the sole and the design on the top part are being controlled by the same procedural texture within Blender. And it gives a very organic, more flowing kind of look. The only thing with this first sort of milestone prototype is that, well, it wasn't a very good shoe. You can see one of our team members actually took it out hiking on a holiday, and she wore them for quite a while, and they weren't uncomfortable, but there were definitely quite a number of issues that we needed to solve. And again, it's kind of interesting to be a part of a project like this where, as a designer, I get to kind of go wild first and then figure out a way to easily bring it back a little and make sure that things actually work out and fit together nicely. And for me, that was kind of the other way around of working. Usually I work very rough first, and then I go into finishing everything and kind of go wild towards the end of a project. And here, I could have did it the other way around, which is cool. And again, you kept getting 3D prints and you kept being able to inspect the shoes. And sometimes we would pull on the soles, or on the, not the soles, but the heels of the soles. And we would notice the mesh in the back around the ankles would break because it was too fragile, it was too thin. So then we would thicken it up, and maybe the week afterwards, a few weeks afterwards rather, we would get a version with thicker mesh, but then maybe we'd made it too thick, so it wasn't quite as flexible and it was harder to get back into the shoe. So it really was a process of going backwards and forwards between the designs and thicknesses and kind of getting to know your material at the same time, which was very, very interesting. Now, once we had this done, the funny thing is I did this one sort of as an extra because I'd been working quite methodically before. And this one was like, okay, what if I just break all the rules and I try and create something from scratch and see what happens? And as luck goes, obviously that's the one everybody liked. So I had to then figure out like, okay, I did this in a really sort of quick and dirty way. Can I reform this to something that makes a bit more sense? Which in the end, is what we want. So many iterations later, we start seeing these procedural systems at work. So again, like I said in the beginning, I want to make sure that whatever I'm doing is as procedural as possible, because if I need to do like 3 hours of edits for each single shoe, it's going to take me, months to create 25 pairs of shoes. So I need to make sure that I can do roughly, let's say, maybe 20 minutes, half an hour of edits to a shoe, and then be able to bring out a completely finished one. So here you can see, actually, while these videos run in the background, how all of these different parts are built up. So you can see I always start from a very simple base shape, and I just start adding things like vertex weights. So I can add in vertex weights with textures and things like that. And then we can use those to displace different parts of the mesh, take away other parts of the mesh, and kind of work together. And I'm sure, as geometry nodes sort of starts making its way into Blender, in the future, this might be able, we might be able to push this even further with sort of a geometry node setup. But for now, everything was done with modifiers, and it turned out quite nice. The cool thing about 3D printing is that in the end, when I first started doing stuff, I was trying to make everything one mesh so that it was watertight, so it was easy to 3D print. And that really caused a lot of issues because you have quite a number of constraints to work with within that kind of system. And the cool thing is, after a while, the remesh modifier and the remesh tools, like the voxel remesh, hit in Blender, and we were able to use those to kind of give us more flexibility. So when we saw those base shapes earlier that was split up into different parts, basically the only reason that now works is because I can take all those different parts, join them all together. I don't even have to boolean them or anything, and then just remesh the entire thing as one mesh, and I get one nice watertight mesh out in Blender that is almost ready to print, that only needs 1 or 2 checks to make sure everything's in order. So for me, that gives me a lot more flexibility in being able to create the shoe and make it look cool. Because at the end of the day, again, I've said this before, that's kind of what you want, right? You want to make sure that everything looks cool and that it works out nicely. So here we see a screen capture of me creating one of those shoes, and I can show you the entire process from scratch, which is really cool. So we're just going to do the left foot for this one, but first thing I do, we have a file with a number of landmarks on the foot that I've written a little script for. That can basically import them and sets up a whole bunch of empties, which might not be super visible. But basically what it does is it shows me things like the ankles, the front of the furthest part of the toes, things like that. And they're just points for me to work around in Blender, so I know I can kind of form the shoe around those key points in our design. So then we bring in the foot. I just remesh it very quickly so we have something to work with. And then the work basically really starts. So I have a left and a right collection. I'm going to focus on the left one here. I grab all the different parts, and then I just scale them up a little bit so I can fit them around the foot. And let's see. And we're probably going to speed this up a little bit so you don't have to look at the full 20 minutes here. So then once they're scaled up, now I'm going to start working on piece per piece. So I basically turn off everything that I don't need, and I always start with the sole so we can basically start fitting that to the shoe. And you can see, because of the modifier setup, it already fits. But you can see I have to kind of go in manually and define all these boundaries to make sure that it follows, the shape that we've set out, and it follows the research that we've done. And that way I can define a base shape on the foot, make sure all the different parts are in the right place. And again, you can see, if this was like a super complicated model with lots of points and lots of, basically lots of vertices that I'd have to tweak, this was going to take a very long time. Now, in this case, thankfully, because it's not that much, I can do this quite quickly. And because we're going to super subdivide this and do all kinds of crazy modifier stuff to it, I don't have to worry about the topology being perfect. I tried to keep it quads as much as I can, but every now and then, if it doesn't work out perfectly, it's not the biggest issue because, like I said, we're going to subdivide this and sort of brute force our way around it. So as I finish around the foot here, you can see I go back out of edit mode, all those modifiers get applied, and it just fits around the foot really nicely, adds the design and everything that we need to do. It's really cool. And then one of the things you can see here for the top pattern is I want to have, as we discussed before with these patterns, sort of a more vertical looking opening. So it's a little stretched out in the vertical direction. So again, to avoid having too many polygons, those blue lines that you'll see in the screen capture are actually sort of bevel weights. So that way I can set them up nicely and then get more geometry without having to do extra work and fitting it to the foot. So again, doing the same thing for the pattern on top. So we've got a duplicate sort of shape that's being pushed out by maybe 0.5 millimeter or millimeter, so that it's sort of on top of that mesh that's above the foot, and then kind of nicely gels together. So that's another, I would say another, what's the best way to describe this, advantage of remeshing is it sort of glues everything together a little bit at the end. I don't remesh at a super, super high resolution, and that way a lot of the sort of sharp edges and weird intersections kind of glue together nicely. Here we see the same thing happening as well. I have a very basic shape that I then fit together. And you can see I'm just going in and out of edit mode to kind of preview the modifier setup and the modifier stack setup. And again, it's just a case of tweaking, going in, setting everything to the right sort of position, going around to the other side, making sure it all looks okay. And at the very end, I think the only thing that's left to do for me here is to add a number. I think we're going to do that in just a second. So checking everything here, making sure we set our number to 13 in this case. And that's about it. So now I have just one empty controlling the entire pattern for the sole and everything. And that way, here you can see me going in and tweaking a little bit again, pushing over some vertices because I noticed some overlap. But again, I can do all of this. I make a copy of everything. And then at the very end, basically, I remesh everything. You'll see it takes a second. Boom, everything's remeshed. And then I make sure that there's no non-manifold edges, that there's no extra parts. And at the very end of it, I just add a smooth modifier with a few iterations just to get sort of the harsh edges off. And that's it, basically. So a lot of time went into figuring out how all of this stuff would work together. And it's been kind of an interesting journey for me as well, because, again, I come from a bit more of an art background. So yeah, for me, it's been kind of fun seeing how all of this stuff works and trying to apply the skills that I have to something a bit different than what I'm used to. So with that said, I'd like to thank my other team members, Raf, Aisha, Catherine, and Manuel, who are doing an awesome job. And yeah, that's pretty much it. Unfortunately, we only have like half an hour, so I have to go pretty quick. But I hope you enjoyed the presentation. And yeah, if you want to see some of the other stuff I'm doing, like art and everything else, I'll have all my things on the screen here. Definitely check it out. And yeah, thanks for your time. And sort of as a last thing before I go completely, I want to plug one thing we're actually doing. So on the 27th of March, me and a few friends are organizing a free online conference for digital artists. So yeah, if you have a chance, go check it out. We've got 6 speakers and a full day of talks planned. And we have a giveaway that's going to open up pretty soon as well with some cool prizes. So it's worth checking out if you're into that kind of thing. But yeah, other than that, again, thank you for your time. And I hope you had fun with the presentation. All right, bye.
All right, so how was that? That was a fantastic session by Midge, also known as the Mantissa. He was in our chat, our YouTube chat, answering questions, and how fantastic is that? That's tremendous. Thanks, Midge. We really appreciate you joining, and we're super excited about your upcoming conference. First time I'm hearing about it, and I can't wait. So I noticed we have Juan Rivera on the line. So Juan, thanks for joining. Why don't you go ahead and unmute? And yeah, I think I believe you're next in the session presentation. So why don't we go ahead and just introduce yourself, maybe talk about what your experience or relationship is to Blender, and what you're going to present today, and it's all you. Take it away. You've got let's see, just about 54 minutes.
All right, awesome. Well, thank you very much. Can you hear me okay? I just haven't checked it today.
I can hear you great. Yeah.
Okay, awesome. So I want to thank you for inviting me to do this today. I'm overwhelmed by the amount of like experience that is part of this World Meetup, Blender World Meetup, and I'm really excited to be here. I'm from Orlando, Florida, and we have a place there called the Dorothy Lumley Melrose Center, which is where I work. It's part of the downtown library in Orlando, Florida. And what we do there is we give people access to equipment and software so they can work on their own creative projects and let their creativity fly. And I am a interactive design software instructor. So my job is to teach people how to, at the beginning level, how to get into, Blender, Unity, Unreal, all sorts of software. So this is my relationship with Blender. And I just wanted to share one of those classes with you guys. I will let you know ahead of time, compared to everything else that has been available here throughout this meetup today, it's very beginning level.
So Juan, we're really appreciative of beginner Blender content on this event, because quite frankly, there's I'm sure a large portion of our audience are beginners, so we're happy to have it.
Awesome. Okay. Well, let me go ahead and share my screen with you guys, and then we'll get started here. This is a Blender Fundamental virtual event, and what we're going to talk about today, we're going to try to go over some of the basics, like I mentioned before. My goals, their objectives for this event is to introduce you to the interface, show you where the tools are, show you where the different things you can do with Blender. I'm going to focus, there's a lot, there's so much. So I'm mainly going to focus on like modeling and rigging and animation, and show you some of the most commonly used tools for doing that. And I'll share some techniques and everything you can do to expedite that process. Okay. First of all, Blender, what it is a free open source software that can help you through the entire 3D pipeline, 3D creation pipeline. So what that means is you can 3D model, you can rig, animate, you can create textures, you can, and much more. I mean, you have, the ability to draw, the ability to create video games. So it's a very fantastic tool, and the fact that it's free and open source is amazing. So we have it available to all of our students in our library system. So thank you very much for those who are responsible for making that available. So some of the things that I have to go over with some of our students is I have to introduce them to, working in a 3D environment and how the 3D axes work and in Blender, to help them recognize in which direction they're moving their objects or editing their 3D model. And I always, share with them about the X, Y, and Z axis, and to remember the colors that represent each one of them, because in each one of the tools that we're going to go over today, the colors will help you understand, in which direction you're rotating the object or moving the object around the development environment in Blender. And one of the unique things about Blender, as far as I know, compared to other software, is the up and down axis, or is the Z axis rather than the Y axis. So then I always make a point of letting everybody know that's a little bit different. So then within the topic of talking about modeling, I introduced to them the probably one of the most common ways of modeling, the 3D modeling, is using polygons, and how you have the power to manipulate all the different components of a polygon in Blender. So your 3D model then is composed of a mesh of polygons. So, which is why a lot of times the geometry that you create is also known as the mesh. So I introduce them to concepts like vertices and faces and edges, and how you can manipulate each one of them independent from one another or together if you need to. So we're going to talk about that today and show you how you can use the tools to create a 3D model. Then that 3D model it's going to be a very simple 3D model because I only have an hour. So we will focus on creating maybe a humanoid style with a head and arms and everything, and how you can go about rigging that geometry so that you can later on then animate it. So we're going to go through those steps and what rigging is, and also how to create the animation within Blender. So let's go ahead and start practicing with that right now. So here's Blender, and one of the first things is that we need to get familiar with is, the interface and what the different panels and editors are. So just like many other programs, Blender has a menu bar on the top, but within the menu bar, you're going to find, this is Blender 2.92, by the way, 2.92. You're going to find these other tabs that are going to change the layout for you, so that you can focus on different aspects of the 3D creation pipeline. And each one of the tabs on the top, they will have the title corresponding to why the layout is the way it is. So like modeling layout will give you access to the panels or editors that you need to model within Blender. Same thing with sculpting and access to the tools on the left side. And then if you need to UV edit. And some of these concepts, if you are new to Blender or 3D modeling, some of these concepts may be foreign to you. But trust me, if you stick with it, you will learn what they mean, like UV editing and texturing and shading and everything like that. For the purposes of this exercise, we're just going to stick with the default layout because it gives me access to the most common editors and panels here in Blender. All right, so the default scene, it's called, it's the environment, the development environment in Blender. The default scene that Blender starts you out with is already has some objects that you can start with manipulating within the scene. Okay, you have a cube. You also have this thing over here on the left that you might not know what it is right away, but what it is a render camera. And then you have a light source for your scene. When you are done creating something in Blender, and most of the time you are going to produce either an image of that object to share with people. Of course, you will probably keep the Blender project itself, but what you will share with the public will probably be an image or a video of what it is that you have created, like an animation or something like that. And that product that you are producing from the Blender application, it's going to be what is called render from the point of view of your camera in your scene. So not necessarily from the point of view where you are developing it from. That is why the default scene will include a camera initially to give you a starting point from where to render your project from to create that image or that animation. And this is if that's what you're using Blender for. Some other purposes of using Blender is maybe creating a 3D model that you are going to use for a video game or something like that, that then you will just have the Blender file itself and share it with other softwares. Now, in the scene here, we have these three objects, the main cam or the camera, the cube, and the light source. But if you follow my mouse over here to the top right corner, you're going to see an editor. This editor right here is called the outline editor. And the outline editor is, it's kind of like, so it's an editor that you can use to also select and see the objects that are in your scene. For example, so it's a a list view of all of the objects in your scene. They can help you manage your objects. I mean, we're looking at a very small scene right now, that if you are working on a large environment and you have a tree up in the distance that you want to search for or whatever, and you can't see it in your scene, then maybe you can select it in the outliner panel. You can do other things there too, like turn things turn on and off. And group them into what they're called collections, so that you can easily group objects within your scene within certain, I guess you can think of them as folders, the collections, virtual folders, not in real life. So that is the first section of the screen that I want to introduce you to. Is on the top right corner. This is the outliner. Right underneath the outliner, again, this is on the layout panel. Right underneath the outliner is the properties editor. And the properties editor has, by default, certain icons here on the left side. And these icons are going to allow you to edit different properties of this project, like properties that have to do with the scene itself, the objects in your scene, the light properties, the camera properties. You can find those all in the properties panel. So you can think of the properties panel or editor as a context sensitive. It depends on what you have selected. You may have more properties or less properties available to you there on that editor. At the bottom of the screen here, we have our timeline editor, and the timeline editor allows you to create an animation by giving you access to frames that you can record over time, objects moving. And I'm going to demonstrate that in just a little bit. So that's at the bottom here. And in the very middle here, where we're going to be working on most of the time, this is going to be the 3D view editor. Each editor has their own menu bar in most cases, where it will have properties that have to do, or attributes that have to do with that editor itself. So for example, on the bottom here, the timeline editor, you'll see that you'll have some playback buttons there and some menu options there, as well as the 3D editor itself. The 3D editor has a ribbon on the top right here that gives you access to certain tools. Also menus within the editor, like these right here, which says object mode, view, select, add. And then you have the tools over on the left side. And depending on which moment within the pipeline or the 3D creation you may have different tools available to you here on the left side, okay? So I want to start demonstrating some of those here in just a little bit. But before I do, I want to show you how to manipulate your point of view here on the 3D editor, okay? And if you have a 3-button mouse, there's a way where you can just use a 3D button, the 3-button mouse. And I'm going to talk about that in just a little bit. But before I do, I want to show you the icons within the screen that you can see to manipulate your scene. So if you look at the icons over here on the right side, these icons all help you manipulate your point of view within the scene. So you'll have this gizmo on the top right corner that has the axis that I kind of mentioned to you guys a little while about, X, Y, and Z. By the way, these 3 axes will always match up with the stage. So wherever the stage is facing. So if you look at the colors on the stage here, you have the red line going right through the cube and the green line going right through the cube. That represents the original axis for the Y-axis and the origin of the X-axis, and they meet in the center, which is the center of the stage. It doesn't show you the blue one on the display right here, but you know it's up and down. Now, if you notice when I move my cursor over that icon on the top right corner, the circle highlights, if I click and hold my left mouse button and then move the mouse, then I can rotate the scene and also the axis corresponding to the colors and the letters on that gizmo. So you can see how I can orbit around my point of view right now, which is the center of the scene, which just happens to be where the cube is as well. So that is one way that you can rotate your scene. We're going to come back to that in just a little bit. But before I do, let me go ahead and move on to the other icons that are also part of the orbit icon here. So you have the magnifying glass there. So if you activate it, if you click and hold and then you move your mouse up and down, or left and right, up and down, you can zoom in and out on that, again, that same focal point that we had established that is the center of the stage for now, right? So you just click and hold, and that's how it allows you to zoom in and out. This is again with the left mouse button. The hand allows you to do a movement called the panning, which is if you click and hold and you move the mouse, it allows the whole point of view to kind of move parallel to the 3D view window that you see right here. And this is a way where you can change your focal point. So, you know, it used to be the cube, now it's way over here, somewhere in the center of my scene, but it's not on the cube. And then you can rotate according to that focal point. So that's another movement right there you can do. And then you have the camera icon. The camera icon is a toggle, so that you can toggle between your development camera that we're using right now to create the world and the render camera in the scene. So you can click it back and forth to toggle between the two of them, okay? And the last icon that you see there on the right, this is an icon that allows you to convert your scene from a perspective view to what is called an orthographic view, okay? So perspective and orthographic, if you ever get lost within those words or what you're looking at over here, on the top left corner, right here underneath the menu or the options here, Blender will try to help you remember where you are and what you're doing right here. So it says user perspective. If I click on that, and now it says user orthographic, okay? So, you know, if you're new to 3D content creation, you may be wondering what is orthographic and what is perspective. Let's just say the perspective is more of a realistic version of what you're looking at. So it has vanishing points and different perspective clues within the scene. Unlike orthographic, orthographic is a more flattened view of your scene. So, and you were probably wondering, why is that important? How is that useful? Well, in some cases, you can switch to an orthographic view to allow you to maybe align objects to one another. So, for example, let me go ahead and demonstrate that real quick. I'm gonna go ahead and move my object here to the center again. So let me use my hand and move over here. And let's say and I'm gonna show you how to do this in just a minute too. Let's say I wanna have two cubes here and I want them to be aligned to one another. Well, if I wanna create another cube, for example, I could come over here. There is this new tool right here, but I want to, you know, this tool right here, you can use it to create primitive shapes like cubes and spheres and everything like that. So I could use that tool, but let's use this one right here. It says in the menu, it says add. This is another way where you can create predetermined shapes and curves and everything like that. So one of the options is this one here called mesh. And in that mesh, you'll see that there is a variety of primitive shapes that you can use to create new objects. So I'm going to go ahead and create this new cube, which you're going to see it in the outliner, but you're probably not going to notice it here in the scene because it is overlapping the cube that was there already. I am going to use my move tool to offset those two cubes, maybe move it further one way or another. And from my point of view here, if I was to look at this, it's hard to tell if these two cubes are perfectly aligned or not. I know they are, but it is hard to tell if they're perfectly aligned or not because one of them is smaller, the other one's bigger. But if I was to change my point of view to an orthographic view, and then maybe make sure that I am looking at this from a specific location. So like this is where you can go back to this circle right here and choose a specific axis to look at this scene from. So for example, the x-axis, which is the side view right here, I can see that and I'm going to zoom in a little bit so I can see that my cubes are not aligned to one another. You can see there's one cube here and there's another cube right over here, maybe there. So I need to maybe move it over. And this is in the case that I wanted to line something up. This is where the orthographic option might be useful to do things like that, okay? So another way that you can orbit the camera without having to use these icons is if you have a 3-button mouse. So if you have a 3-button mouse, it's a shortcut. So you can use your middle mouse button to, if you hold the middle mouse wheel or button and then move the mouse, that can orbit your scene. If you need to zoom in and out, you can scroll the wheel up and down to zoom in and out on your focal point. Or if you need to pan, you can hold the shift key and then hold the middle mouse button and move the mouse to pan your view without having to always come back over here to the icons. I like to show you both because the shortcuts may take a little bit of time to get used to it, and just to show you that you have that option there also. And if you don't have a 3-button mouse, then you have that option there on the scene as well, okay? Now, I kind of talked about this a little bit, but I'm going to mention it again. I talked about the move tool. So you have these tools right over here to help you edit your objects. And one of those is the move tool. The move tool has the the icon has the 4 arrows pointing in all directions. And if you hover your mouse over it, the little window pops up and tells you the name of that tool. And also it shows you a shortcut. Now, be careful. The tool itself and the shortcut, even though they do the same thing, they behave a little bit different. So when you activate the tool here on the left side, you have this gizmo that allows you to use the different parts of the gizmo to move your object. So if you want to move your object along the y-axis, which is the green arrow here, then you can click the green arrow and then drag your object left and right. If you want to move it along the x-axis, then you grab the tip of the red arrow, move it left and right, or up and down with the blue arrow, okay? And especially if you're working on a perspective view like this, that's the way I would recommend to move your objects, just because it makes sure that the movements that you're doing are precise and not all over the place. Another way that you could move this is by just grabbing the center of the cube by left clicking and then moving the mouse. But you know, your mouse only moves in along two axes, not 3. So those axes only become up, down, left, and right. It doesn't matter where it is on 3D space. So you may end up with an unwanted location. So for example, if I have this cube right here, they're all both right next to each other. But let's say that from this point of view, I want to move my cube to the back of the stage over here. And I decide that I want to do it by grabbing the center of the cube. If I do this right here, from my point of view, it looks like the cube is where it needs to be. But as soon as you rotate your point of view, you can see that it's nowhere near where you were intending that cube to be. So if you're in a perspective view like this one, I wouldn't recommend to try to move your cube by clicking and holding the center. Instead, maybe using the arrows to place it where you want it to place it, like this, okay? Sorry about my dog. All right, another thing that I do want to mention to you guys about moving an object is that all of those movements are being tracked by the coordinates of the center point of that cube. And to display that, you can open this tiny little arrow within the 3D view editor. And it will show you here, there's 3 tabs. Make sure you're on the item tab. And you will see the location of that cube and coordinates. And it has a little M at the side because the standard unit of measurements for Blender is meters. So that's how far this cube is from the center of the world. Okay, so it's in reference to the intersection here where this other cube is. It also shows you the rotations in degrees, which leads me to the next tool right here, which is the move tool, the rotate tool. The rotate tool is a little bit different, but remember I was telling you about the different colors, the green, blue, and red. They still represent the same axis. So if you wanted to rotate your cube around the X axis, then you can just click and hold on the red circle and then rotate that cube around the red axis, okay? Same thing with the green circle and the blue circle. And then the white circle on the gizmo represents the screen plane. So to rotate the cube along the point of view, your point of view. So it just rotates it around that point of view, all right? Now that I have rotated this cube, I wanna show you another axes. So I talked to you guys already about the stage axes, the X, Y, and Z that lines up with the stage. Well, each objects, they have their own axes, known as the local axes. So this can be displayed by using the move tool gizmo. And I'm gonna try to focus on this cube over here real quick to show you that. Right now, the move tool gizmo, it is aligned with the stage itself. This is the global axis of the world. So no matter how much I rotate my cube, if I take this and I rotate it this way and that way, the move tool gizmo is aligned with the world, so it's not going to rotate with the cube unless I change that. So if you look at the menu bar over here on the top, there's an option there called global. And if you click on it, you can change it to many different orientations. But the two most important ones are here are global and local. So if I change it, notice how the gizmo quickly rotates to align itself with the axis of the cube, which may or may not match the axis of the world. It depends on how your cube is rotated within that world. So you could also see that with the other tools. It's just easier to see it with the move tool gizmo. So there you go. As you can see, this cube is actually upside down, or on its side. I'm sorry, not upside down. So you can fix it by returning it to its original location. So that's one way that you can see that. You can also fix it by manually inputting numbers on this transform panel on the right side. So I could actually return these values to 0, 0, and 0 to align it, the cube back with the global axes as well. All right. So you can use this as input panels to change it as well. Okay. Now, I also wanted to show you what happens if I have two objects selected, which, by the way, to select multiple objects, you click on one, then you hold shift, and while you're holding shift, you click on the other one. So as you can see, now that I have two objects selected in my scene, the gizmo will align itself in between them. Okay, this is due to the fact that I have it set up that way. This little icon next to where I changed the axis orientation. This one is the pivot point. So the pivot point icon can help you, or menu can allow you to change where the pivot point is aligned to. So right now it's aligned to the median point. So if you have multiple objects, it'll be the point in between the two objects. Okay. If you change it to something like individual origin, I'm sorry, let me see, active element, for example, if I was to rotate this right now, you'll see that the second object will rotate around the last object I selected, which is what's called the active object. The last object will be highlighted a different color. So you can see that the active object would be highlighted yellow, while any additional objects would be highlighted more like orangey red. Okay, so you can change the orientation of the pivot point to many different options. Let me see this one right here. So the option that says individual origin, even though the gizmo is still in between them, when you rotate it, it actually rotates the objects along their individual axes. Okay, so unlike median point, where it will rotate both around the center of that median point. So you have those options there on the top that I just wanted to make you aware of. So we can get rid of that cube now. And then we have also a scale tool. So move tool, rotate tool, and scale tool. And the scale tool allows you to make the cube bigger. If you click and hold anywhere within the circle here, the cube will be edited proportionally to itself, so it doesn't get distorted, okay? But if you decide that you want to distort the cube, you can actually click and drag any of these extensions of the gizmo in the desired, along the desired axes. This can happen along the Y or Z axis, along the local axis, or the global axis as well. So you can, so you have a lot of choices there depending on what you're trying to do. Okay, so and then you have the, I guess it's less like the all-in-one tool. It's called the transform tool. And you can see it has all of the gizmos all in one. So the rotate tool, the scale, and transform tool as well. Okay. You have these other tools right here are just temporary tools, the annotation tool, so you can draw and highlight things within your object. This is not a 3D object at all. And then you can actually measure things with the measuring tool. And like I mentioned before, this tool right here allows you to create objects. So right now it's set to a cube. So if I come over here and I can actually create a cube along the local axis of that object there. So let me change it back to global. And you can create multiple primitive shapes with this tool right here as well. So so that's what the tools are over here. The first two tools that I neglected to talk about, let me talk about them now. So I'm going to go ahead and undo a couple of steps here real quick. This first tool is the selection tool, and the selection tool has multiple options within that tool. So you can see that within that tool, there's a little triangle in the corner of the icon. That means that there are several different types of selection tools. So if you click and hold the mouse button there, it will expose the different types of selection tools. And you can use them depending on what you need at the moment. So you have a lasso selection tool, which allows you to draw a lasso option to select object within that. And then you have the cursor tool. The cursor tool is really neat because it allows you to, it's an insertion point for objects. So when you use the menu bar here, and if you select the cursor, you can actually left click and hold, or left click and hold and then move around and move that cursor to different locations. So when you add a new object, that new object will be created at that location. So that's one of the benefits of the 3D cursor. That's what that tool is right there. And I've only been using the left mouse. So left click and hold allows you to put it in different areas. The 3D cursor can also manually be put in a specific location if you know the coordinates by going to the menu on the option on the right side here, but instead of items, go to view, and then you have the 3D cursor coordinates right there where you can place it in a specific location if you need it to place it somewhere in your world. Okay. All right. So what I would like to do now is, let me go back to my selection tool. I would like to sort of use some of the things that I mentioned to you guys and go over some and use them to create a 3D model real quick. So let me go ahead and go back to the center here. And I'm gonna create a cube to start with. So here we go. So now I have a cube there in the center of my world. And I'm gonna transform, or I'm gonna create a very primitive looking humanoid character just to show you other things you can do with Blender. So right now I am using a mode in Blender called object mode, which allows you to select a full object and move it around altogether. But as I mentioned before, objects are actually made of different polygons, and the polygons themselves are made of different components. What if you wanted to go in there and actually edit the different parts of the polygon? Then you would have to go into what is called an edit mode, okay? That can be found on the top left corner here where it says object mode. You just click on it and you can find it right here, edit mode. To be able to toggle between edit mode and object mode, you just click the tab key on the keyboard, and the tab key will take you between edit mode and object mode. And again, edit mode is so that you can go in and actually edit the different components that make up this cube, okay? Or any primitive shape for that matter. Like I mentioned before, this cube is made out of polygons. Each polygon is made up of vertices, edges, and faces. And those three different components, you can select them independent from one another to edit them and to eventually create something new. If you need to edit the different components, you do have to tell Blender which component you are intending to edit by changing these three little icons here on the top left corner. This is the vertices, edges, and faces. And then that would allow you to select the individual components so that you can continue to edit that component. So I'm gonna select the faces right now, and I'm gonna select the top right here. By the way, if you are on edit mode, the shortcut to change the different components is 1, 2, and 3. So 1 is vertices, 2 is edges, and 3 is faces, okay? So now that I have the top face selected, I'm gonna go ahead and do what is called extrude so that it creates more geometry from this geometry right here. And notice that when I enter edit mode, Blender is giving me access to additional tools that I can use to now edit the different components of this cube. So the extrude tool is this one right here, so I can activate it. Once I activate it, I will get its gizmo just like I did with the other tools here. So you activate the tool and then you use the gizmo to actually extrude the different parts of that you have selected. So in this cube, I have the top selected. So I'm just gonna go ahead and click on that gizmo and pull up. And as you can see, I am actually extruding a little more geometry from that cube. Then what I'm gonna do is I'm gonna go ahead and scale it down. So I'm gonna scale it down from the evenly. So I'm gonna drag anywhere between this circle right here, drag and then drag in to scale in, drag out if I wanted to scale out. So you can see how I'm making that smaller, okay? And maybe I can make it a little bit, let's bring it back down a little bit. I think I extruded a little too much. Now notice that I'm trying to orbit my development camera around this cube, but I can't because it is not in my focal point. So I need to align that cube back to my focal point. So to do that, I'm going to select all of the faces real quick, which the shortcut to select all is just the A key on the keyboard. Press A and that selects everything. Most people would want to draw a selection box like this to select everything. But you have to be careful when you do that in Blender because it only selects what you see. So if you don't see the back, it won't select the back, okay? So, and there's ways around that, but I'm just gonna click A to select all, make sure everything's selected. And to refocus my development camera onto the objects that I have selected, you just press the period. If you have on a number pad on your keyboard, you press the period key and that would frame your development camera onto that object as well. So that's the period if you have a number pad to focus on that, okay? That way, now if I orbit my camera, then I can orbit around this cube right here. All right, so let's go back this way here. I'm gonna select that top. I'm gonna go ahead and continue extruding. So I'm gonna extrude another piece of the neck right here. And my extrude tool is still activated. So if I wanna continue extruding, if I wanna change the location of that extrusion, I can just use the arrowhead on the extrusion. Or if I wanna continue extruding here, or extrude more geometry, then I click the plus sign. So I'm gonna go ahead and do that. Then scale that a little bit bigger. And then extrude again. Reframe my view here, extrude a little more. And then scale, okay? Now, so that is one way where you can extrude. If you are, if you're more of a power user, then you can probably use the shortcuts. So I'm gonna go over some of the shortcuts at this time, so that way you can learn both. So you can always activate the tool and use the gizmo, or you can use the shortcuts. So the shortcuts are actually pretty powerful in Blender and pretty intuitive, okay? Because they did a really good job of making sure that they match the keys that belong to the shortcuts, as long as you know the name of the tool. So for example, the extrude tool, if I wanted to extrude more geometry here, instead of having to go over there and activate the tool, I can just press the letter E on the keyboard. And there you go. I have more geometry that I can extrude from here, okay? And notice that blue line that comes across the bottom here as I'm extruding it. And that is because whenever I extrude a new geometry, the extrusion actually happens along its normal axis, the direction that component is facing. So in this case, it's facing this way. That represents its normal axis, okay? So if I extrude it this way a little bit, and then I'm gonna use this, the selection tool, so that way you don't see the gizmos anymore. So now I want to scale this face down a little bit. So what do you think it could be my shortcut for that? If you said S for scale, then you are correct. The trick of using the scale tool is that your cursor has to be within the 3D view window. And then you can press the S key. And that will activate the scale tool. And that allows you to scale the face uniformly, okay? If you wanted to scale it, but also scale it and distort it, then after you activate the tool, you have to do something different. So let me show you that real quick. So let me undo that real quick. Let's say I wanted to scale it, but I wanted to scale it in a way where only the top and the bottom of this gets a little bit smaller, but the width stays the same distance. Then what I can do is activate the scale tool. So it's activated. While it is activated, then I have to tell Blender, hey, I only want to scale it down along the Z-axis, for example. Then I will activate the Z-axis, and that's how you can scale it only along the Z-axis, okay? If I wanted to do that, I'm going to demonstrate that here a little bit more in a little bit. All right, so I'm going to make this a little smaller, and this is where I'm going to extrude the arm of this character out of. So I'm going to go ahead and move this up a little bit so it aligns up with the shoulder. So to move it a little bit, we have to activate the move tool. Here's where it's a little bit different, because even though I keep calling it the move tool, and Blender calls that the move tool, the way you activate it is by holding the letter G. So, but you're probably wondering, I thought you just said they do a good job of matching the letters with the tool. All right, well, but you have to think of that tool a little bit different. So instead of calling it the move tool, we could call it the grab tool. So if you activate the grab tool for G, basically that's what happens. You're grabbing it with your mouse button, and now it is moving along wherever you move your mouse, right? But then, you know, I told you also that it wouldn't be a good idea to do this kind of movement in a perspective view. So then what you do is after you grab it, then you lock the axis that you want to move the object along by pressing the letter that corresponds to that axis. So if I want to move this face up and down, then I press the Z key, and that will lock it so it only moves up and down. And try not to click, because when you click, left click, it's like telling Blender, hey, I'm done with that movement. So make sure that you don't click until you're done. So you activate the tool, then you tell it which axis. So let's say I wanted to move it forward and back, or in and out, in this case, or up and down. Then you do stuff like that. Then you press the letter that corresponds with that one. And then when you're done, then you left click to finish or press enter. All right, so let's go ahead and continue extruding the rest of this arm. I'm not going to worry too much about how the size is or anything like that, because I'm going to move on to something else real quick. So I'm just going to extrude the rest of this hand here. There we go. All right, we'll call that down. Okay. Then I'm going to extrude the rest of this body here. All right. And this is another interesting thing that I wanted to show you here. So if I extrude this leg, it's going to continue going out in this angle, because that's the way the original face was facing, right? But I actually want to extrude this leg going straight down. So to extrude it going straight down, then I have to change the orientation of the axis. And the way you can do that is by toggling through all the different axes available by continuing to press the letter that corresponds to that axis. So I want to move it going straight up and down. That is the Z axis, as I mentioned before. So then if I keep pressing the letter Z, it will toggle between local, no axes, or global axes, like I mentioned before. That's the way I want to do it, going straight up and down like this. And then I have to extrude the different parts of the leg like I did with the arm here. The reason why you would want to do something like that is so that when you're animating it, it allows you to create the proper typography of the geometry for the areas of the body that need to bend and squish and everything, like shoulders and elbows. So you want to initially section them off like that, okay? So I need to do the same thing for the leg, but if I keep extruding the leg in this format right here, then I will have to continue to correct the axis as I go along. So instead of doing that, I'm just going to fix this first. I'm going to fix it by changing my component to edge, and then I'm going to move it. But as I move it, I want to make sure that I lock my axis on the so with other edges. So I'm going to snap it so that when I move it and I lock it on the axis, then I hover over other components so that the movement snaps to match other components. And then this is again an even face. So then I can continue extruding. So I'm going to go ahead and finish this real quick. And as I finish, because I want to show you, let me turn this off real quick, what you can do after you have model something like this. I mean, you can go in there and create more detailed, but again, we don't have a lot of time. So then after you create something like this, you can select all the components by pressing A, and you can use within the mesh menu, now that you have available on edit, there's an option there called symmetrize. The symmetrize option by default, as you can see in the little pop-up window, is set to symmetrize from the negative x-axis to the positive x-axis. So initially when you activate it, it will do that. and it looks like, oh, I lost my arms and my legs or whatever. But actually, if you open this menu up, then you can change that to from positive to negative, and it will create the rest of the geometry for you. And then you don't have to do the other side. So it's a technique so that you can quickly model on the other side. All right. I only have a few more minutes, so there's more that I want to go over with you guys, but because I only have a few more minutes, let me go ahead and just show you real quick the rest of the stuff that I wanted to go over in this presentation. And you can see it at work, and then we'll and you can at least see it rather than not being able to see it. So I'm going to go ahead, and now that I have my geometry, I am going to add a modifier here so that is adds more geometry to the basic shape. And that is if you go to the properties panel, you have the little wrench icon, click on it, and on the generate section here, you can find a modifier called subdivision surface, and that will subdivide the geometry and give you a little more detail. So let's go ahead and add a little more here. To actually apply it, you have to go back to object mode, and the shortcut to apply it is Control A, because once you have it in the modifier section here, it's not actually applied, which is why it's a preview, what you see here on the scene, which is why if I go back to edit mode, you see the actual shape is still looks boxy. So that way it gives you time to change the modifiers and merge them. If you want to add multiple modifiers to one object, you can, and see what they look like in the preview. And then once you like it, then you can apply it by moving your cursor over it and hitting Control A, or just clicking this little arrow and hit apply. So that way you can see that on my edit mode now it's actually applied and it created all the geometry there for me. Okay. So let's say this model is done. Now, if you wanted to animate it, it would be hard because you would have to select the different components on edit mode and, maybe rotate it or something like that. And that's weird to do. So whenever you want to animate something like this is highly detailed, you would create an internal structure called the rig or skeletal structure. A Blender calls it an armature. So you could create an armature, and you can't see it because there's initially it's just one bone that gets created. It's inside the character. I'm going to change that by going to the properties menu and going to the viewport display so I can actually draw it in front of the character. I'm going to move it down real quick and go to edit mode. And again, I'm kind of flying through this real quick so I can save some time, but I'm going to grab it and move it up a little bit so you can edit it. I'm going to extrude more. Move it here. And then I can move the insertion point so I can create more bones. I'm going to create an arm here. Grab that, put it at the elbow, extrude that at the wrist and at the tip of the hands. Then move the cursor again over here. Create another bone, grab that, put it at the knee, extrude another one, put it down by the foot. And I'm going to extrude one more for the toes here. And be careful because you'll notice that the bones are actually not inside the body. So it'll be good to maybe rotate to the different angles and make sure that the bones actually go inside the body, especially when you're creating the legs and arms. Let's move that in there. There we go. And a way that you can mirror this bones on the other side is we're going to utilize the 3D cursor, and we have to return it to the center of the stage here by pressing Shift C. Then selecting the arm and the leg, duplicating them by pressing Shift D, duplicating them, and then using the armature menu in the edit mode and mirroring them across the x-axis. Make sure that your pivot point is set to the 3D cursor because it's in the middle here. So you go armature and then you mirror it. Then on object mode, you can select the skin and the bones and use the shortcut Control P to parent it so that the skin will attach to the bones with automatic weights. There we go. Then you can go to a mode code post mode where you can actually rotate the arms. Oops, the pivot point is still set to the 3D cursor. So let's go back to here. There we go. And then you can use the animation, the timeline to create poses in time. So let's do that real quick to show you. Arm this way, arm this way. If I select all the bones and insert by pressing I and recording the location and rotation at frame 2. I meant to do that at frame 1 there. There we go. There we go. We'll repeat that at frame 60, IO. And at frame 30, we'll just flip everything the other way. Whoops. All right, and then you can see the character moving there in animation. Okay, so sorry, I kind of rushed through that, but thank you very much. I appreciate your time. And, if you ever come down to Orlando, come check us out at the Miller Center.
Thanks, Juan. That was great.
Thank you so much, Juan.
All right, I appreciate it.
Is
All
it
right.
my turn?
Yeah, thanks. That was wonderful. So we are about to pivot to a new speaker, and we have an option. Andrew, are you on the line?
Yes, I am.
Yeah, so I think we had Sam Brubaker scheduled. Hey, Sam, glad to see you're here.
Hi there.
But we also have Jacob Merle, I think, scheduled after you. And are we looking to do see if Sam can accommodate 1 hour later? Is that what
yes,
I can do
okay.
that.
Yeah, Sam, how's your schedule? Is it flexible? If we
My schedule is totally flexible. Wait, can you hear me?
Yes, we can hear you.
Oh, good. Yeah, my schedule's flexible. If Andrew needs to come in and do his thing, I can stick around for another hour.
Okay, fantastic. All right. So Jacob Merrill, are you on the line? Oh dear.
I think Jacob has dropped off. Let me see if I can get him back.
Okay. Look, if you can't, no big deal. We can queue up Sam and just keep going with that. And
you know what we could do? So we could play our World Blender Meetup Day logo video that we haven't really played too much. It'll buy us at least a minute.
Sure, go for it.
All right, hang tight. I got it right here.
And he'll be presenting on Snowflake, geometric pattern generation using nodes. And Sam, why don't you go ahead and introduce yourself? We're not seeing you on video.
I'm going to start sharing my screen now.
But you could share desktop if you like.
Am I coming through?
Yeah, it's coming through now, and I can see your desktop. So yeah,
Okay.
Why don't you introduce yourself? explain what your relationship is to Blender and explain what you're going to present today.
All right. Well, my name is Sam. Well, first of all, can you tell me how many people are watching? I need to know how nervous I should be.
Yeah, so our viewership kind of fluctuates between I would say like 80 and 120 people, but we get thousands that watch the recorded video. So
oh boy,
you're talking to the world.
Okay, hello world. All right, so you should be able to see if I'm sharing the correct desktop, you should see a kind of trippy pattern going on.
Yep.
In Blender. Is that what you see? All right, I'll take it from the top. Okay, my name is Sam Brubaker. And I've been using Blender for, let's see, about 16 years now, since I made my first animation in 2005. And yeah, I haven't looked back. I've been an acolyte of Blender for quite some time now. So what I'm going to show you today is called Snowflake. And I'm calling it that only because we've talked so much about geometry nodes, and I am, in a sense, I have created some geometry nodes, but they are very, very different from the system which has recently come out in Blender. I've been working on this sort of on and off for about I don't know, 4 years now, and these are essentially geometry nodes, but they are just just for shaders. So what you're looking at right now is, I know you're probably thinking like, oh wow, what complex geometry? Nope, it's just a plane, just a plane with 4 corners. Everything that you see here is a shader. And you might be thinking like, oh wow, it must be a video texture of some kind. No, it's not. It's just plain nodes, just like what you see here. This is the whole shader. And of course, there are a lot of node groups within other node groups, but it's just a regular shader, and you can make it with math nodes. So effectively what Snowflake is, or this thing that I'm calling Snowflake, is just a library of node groups for generating geometric patterns. And yeah, I really appreciate Juan's presentation, because it's indicated to me that I need to slow down. Like, I'm watching Juan, he's like he's taking his time explaining like what the grab tool is, and I'm realizing now that I need to just slow the hell down while I explain this stuff. So David and Sterling, like, at any point, if you don't know like what the hell I'm talking about, please interrupt me and just be like, Sam, what the fuck are you talking about?
No, it's not a problem.
Yeah,
we have a really wide array of both beginner to advanced Blender sessions in our event. So if you want to go fast, I don't know, I recommend you go fast. People could always watch the recorded video and slow it down later.
Yeah, I don't know how fast or slow I should go. I guess, just
go at your natural speed.
All right, let me know how fast or slow you like it, and I'll accommodate. So so this is again just a material, just a shader in Blender. It works in Eevee, it works in cycles. It's pretty lightweight. As you can see, I'm animating it in real time. You can adjust these parameters in real time too. Ooh, look at that. Maybe I don't know, let's see what parameters I can mess with here that might look cool. I'm just messing with random stuff here. Here's another shader that I made. I'm kind of proud of this one. And again, this is just an assemblage of math nodes. It looks like spaghetti, but I could have organized it a little better if I wanted to. Here's another one again. And what I've created is a library of node groups that make generating patterns like this fairly easy to do, or easier, I should say. So the add-on is basically just a menu of all these different node groups that you can select here. And I should mention that this is still heavily underdeveloped, or still in developed, yeah, and underdeveloped as well. So what you see here is subject to change. That's the caveat. Yeah, I should probably start from the beginning, because I think a lot of people look at this and they think, like, oh wow, how cool. When is it coming out? Well, where can I buy it? And the secret is to this is that the power of Snowflake actually resides within you, the person watching this. You can, if you can wrap your mind around the math that goes into something like this, anyone can create all of these node groups and all these patterns from scratch using Blender without any add-ons at all. So I'm going to start from the very basics, from the very top here. I'm going to delete my shader and create a new one. And let's get rid of that. Let's get rid of that regular principled shader and just do an emissions shader instead. By the way, I highly recommend installing or enabling the Node Wrangler add-on, because it allows you to randomly preview the output or arbitrarily preview the output of every node in your node tree, which is really, really useful. I'm going to show you what I mean. If I go here and hold down Control Shift left click, I can cycle through the output of each one of these nodes, which is really, really handy. In fact, it's almost indispensable when you're working with trying to generate geometric patterns. You're going to have to constantly, check the output of this node, check the output of this other node. And so Node Wrangler just makes it really, really easy. Just that one function, in fact, just makes it so much easier to preview what you're doing. So what I want to start out with is explaining that everything that you see in Blender or in the node window is a lie. You've all been lied to. Because I'm going to blow open this whole conspiracy here. RGB and XYZ are the same thing. They're identical, and that's really the secret. That's how you understand how any of this really works. Don't believe me? Look at this. Right now, using just the generated texture coordinates, I can plug this into the separate RGB or the separate XYZ. And look at this. They're the same. XYZ and RGB are identical. Look at that. They're the same. They're the same thing. These nodes do exactly the same thing. And in fact, RGB and XYZ are identical in the sense that they are both sets of 3 numbers. They're both fields of 3 numbers, but also these numbers can be arbitrarily modulated. You can do whatever you want with them. You can interact. You can have them intermodulate each other. You can do whatever you want, and the result is you can generate some geometric patterns that way. So let's take, for instance, the X channel that is generated when I separate XYZ. This is the easiest way of generating a horizontal gradient. Every time I see this node, this gradient texture node, I know that the user of this node doesn't really know what's going on, because this is probably the most useless node in Blender, in the shader system. You don't need it, because all you're doing is taking a linear gradient from what is already a linear gradient. Look at this. The X channel, or the X vector, is furnishing for me a perfectly good field of numbers starting from 0 over here to 1 over here. And in fact, that reminds me, I'm going to change my color, my view transform here to raw. And it's important to do this because this is going to make it a lot easier to visualize a linear gradient of numbers from 0 to 1. So for instance, a lot of people, you might think of this as a gradient of black to white, but really what you should be thinking of this as is a field of numbers from 0 to 1 with 0.5 in the middle. And in fact, if I render this image, I've just got a camera above this square here. If you click and drag your cursor across the rendered image here, you'll see that in the middle, I've got some scene referred display value or some scene referred color values here that are 0.5 in the middle, and they go all the way to 0 at the bottom, and they go all the way to 1 up here. And the same thing is true of the Y channel here. It's just a field of numbers from 0 down here to 1 at the top here, and an infinite number of numbers in between, depending on how far you zoom in. And that is all you need. Just that, X and Y. You can plug that into a bunch of math nodes, you do whatever you want, and you can generate all kinds of crazy patterns. So now I'm going to show you what I mean. I'm going to go down here, and I've added, when I've enabled the add-on, I've just got a little menu here that just helps me select from all these different node groups. If you look over in the outliner, you can see that I've actually got like 70 node groups here. And that's a pain. That's a pain to deal with. So what I've done with the add-on is kind of organize them nicely into a little menu here, and then hidden them in the group menu. So the group, so they don't actually, even though they are node groups, they don't show up in the group menu, which kind of helps things stay uncluttered. But yeah, let's go ahead and just add, I don't know, one node. Let's start with, I don't know, the scalar grid node here. I plug that in, and all of a sudden, I can divide this field of numbers. I can basically pass it through a modulo function and subdivide this field into 7 different bands. And in fact, if I do the same thing, I can do the same thing up here. And I can divide that into 7 different bands. And now look what happens if I recombine those. Let's go to combine XYZ. And again, I'm using XYZ, but you can use RGB if you want, because again, they're the same thing. That's the big secret. That's what they don't want you to know. And now what I've created here is basically a subdivided grid of what was here. So I had X and Y, just a field of numbers. I'm ignoring the Z for right now. I'll turn this up to 0.5 just arbitrarily. And now I've subdivided that into a grid of 7. And now let's, I don't know, plug that into something else. Let's see, we can incorporate it with anything. How about a magic texture? Now, if I take the initial magic texture or the initial generated region and plug that into the magic texture, I've got a field of repeating a periodic texture. Actually, maybe that's a bad example. Let's use a different texture. I don't know. How about a noise texture? That works. Oops. There we go. And if you see here, I'm basically plugging in the coordinates that were generated, in a Cartesian field of X and Y. They that's what gets plugged into the noise texture. Even when it's unplugged, implicitly, it's accepting an input from here. You should always imagine that when this vector field is unplugged on most texture nodes, imagine that there's an invisible, one of these connected to it. So yeah, this is unsurprising, probably. It's, a noise, a cloud, a field of random values. But then look what happens if I plug this in. I've now repeated that same figure over a 7x7 grid. And so this is the beginning of a pattern, a system of patterns that we can generate. So what I'm going to do now is open up the vector grid. I'm going to bring in a vector grid node here and do basically the same thing that I already did. Just turn that up to 7. Look at that. And what I'm doing here is basically just modulating a field of numbers and creating a new field of numbers. And now with that new field of numbers, I can do other stuff. The vector grid node here it subdivides the region into smaller regions. And then you've got we've got a couple different outputs. First, there's the ramp output, which you should imagine a ramp wave. If you do analog synthesizers, you know what a ramp wave is. This is the same idea. And then, of course, we have the step function here, which basically samples individual regions of the initial generated field and makes them uniform across this whole square. And then there's the integer function, which is just gives you whole numbers for each region going up and down on the XY axis. Is any of this making sense? I need someone to chime in here. What's going on?
Yeah, I think it's making sense. Absolutely.
Okay, so
super interesting.
So it's all right. It's about to get a little bit crazier. Okay, so let's say I don't know. Let's say I want to rotate these individual squares. Well, that's easy to do. I can just go to let's open up vector rotate. Easy. Change that to z-axis. And now look, I'm rotating this region about the center. You can kind of see, it rotate there. Actually, I should do a better job. It'll be easier to see if I plug these fields into an image texture. Here's one. Just your standard UV grid. Look at that. If I plug in the ramp output of the vector grid node, I've now subdivided that into a 7x7 grid of equal regions. And then I can now do things like rotate all of the regions uniformly. But what if I want to rotate, I don't know, the whole thing? Notice that the order in which I rotate these vectors produces a very different result. For instance, if I rotate the field of numbers here, the vector channel here, the entire thing spins. Whereas if I rotate it over here, just these individual grid, this individual grid thing spins. So that should give you an idea of where we're going. if I let's bring in another node. No, let's have some fun here. Let's bring in I don't know, let's do a spiral. Or actually let's do polar coordinates first. Let's see. If I do that and then that. Oh, now something interesting has happened. I've basically taken a Cartesian grid, just, X going in this direction and Y going up and down, and I've converted it into a polar coordinate system. And you can see the simple math nodes that are going on inside, as long with a gradient texture, the radial one, which is a little bit more useful than just doing a simple linear texture. And then once we subdivide that, we get a very different result. And here's where it gets really interesting. If I bring back that vector rotate node and rotate it like that. Wait, that's not what I meant to do. I meant to put it over here. There we go. So just with some simple, math nodes, vector nodes, you can begin to create some really interesting patterns. Let's see if I can get rid of this seam here. Where would I even begin? Maybe I can get it. There we go. If I just do 10. No, that didn't work. Come on. We'll eyeball it for now. Right there. And look at that. I've just created a nice kind of flower pattern using just nodes. Just nodes. And now we can begin to do other interesting things. For instance, we can take this step function here, and we can use that to modulate each individual cell that's been created here. Let's bring in, I don't know, how about the edge distance node? That one's fun. Again, pretty simple math going on here, but these nodes make it really, really easy to just kind of like run in and create these patterns instead of having to fiddle around with math nodes. Of course, you still have to fiddle around with math nodes no matter what, but at least we can cut your workload in half, so you can get to being creative. So let's take that edge distance and we'll see if we can map it a little bit. Of course, I've got the map range node here, as though I've invented it when I haven't. It's the same map range node that's over here. But what I've done is I placed it here anyway, because there's two map ranges now. There's the map range for just a scalar value, and then there's the map range for a whole linear or a whole vector value, which is just 3 map range nodes mixed together. Actually don't need that though. Let's bring in the map range node and I don't know, let's map some ranges here. Ooh, that looks cool. And I'll take another one. Let's introduce a nice, easy curve fall off. And you can see very subtly that we've introduced, instead of a linear bevel here, we've kind of like made it a nice rounded bevel instead. I frequently talk about these number fields in terms of up and down, in terms of brightness being intensity and light being being just a value between 0 and 1, because the more you start thinking in these terms, the more arbitrary they all seem. Everything is just numbers, and we can do whatever we want with numbers. So let's take, for instance, we've got this, nice little pattern here, but let's introduce some color. I don't know, maybe we can randomize the color a little bit. That might be fun. Let's take a noise texture and we'll plug the step function into it. Now look at the difference here. If I plug in the ramp node into the noise texture, what I'm going to end up with is all these identical fields of the same section of the noise cloud. But if I do the step function, I'm effectively doing the opposite. And so each region is a uniform sampling of the noise cloud. Now there's something going on here. You see that dreaded seam is back, but there's actually a way of getting rid of it. I think. We'll see. Could be totally wrong. Actually, forget I said anything. We'll come back to that. We'll live with this this seam here for now. But there's ways of dealing with that. So I've got some color here. I've got some color, or I've got some value here. Let's mix those together. All right, I'm getting into Bob Ross mode here. This is good. I'm getting into the swing of things. Ooh, that works, right? We've got like a nice little color pattern. And here's where things can get even more interesting. What if we took all of this and, I don't know, we just made it, we duplicated it and just made it a grid, or a group, I mean. Oops. Actually, forget I did that. Let's group this so we get those inputs and outputs of the group node. Let's take that, and what if we subdivided that? Do another vector grid. And now we've subdivided our subdivisions. We can keep going deeper and deeper. And yeah, we can let's work with this. What if in fact this subdivision was itself a part of a logarithmic spiral? Let's plug that in. That's bear with me here. We're getting somewhere, I promise. We just need to adjust the way this looks. Maybe something like that. And of course, I've added a little, some extra little things to make make the spirals more interesting, allow them to be customized. We can add arms. We can take arms away. Let's try 5, and then let's reduce the number of steps. Something like that. And then with that. And of course we can keep subdividing this all we want. And Blender's whole shader node system, whether we're using cycles or Eevee, I can switch to cycles here. And it's interesting, whether we're using cycles or Eevee, the node or the math that goes into this is surprisingly robust. It's very, it doesn't slow down. It performs really, really quickly. When Eevee first came out, I had been developing this for cycles, and I thought like, well, there's no way all of these nodes are going to work with Eevee. And then it did. They worked perfectly. So I was really impressed with that. And that's what made me get excited again. And then I started working on it some more. And then I realized, like now there's something called geometry nodes. and well, that's going to be a whole thing. I hope they're not stepping on my toes. Yeah, they're doing something really interesting as well, and it's with three-dimensional, geometry in this case meaning two things. There's geometry meaning a system of two-dimensional patterns and the science of three-dimensional forms, and there's geometry being the stuff that is in Blender. We call all this stuff geometry. And so we're basically talking about two different substances here. So at this point, I feel like I need a little bit of direction here. Are there questions? Do people have questions about this?
So yeah, there are questions. So is the node library available to download?
It will be. It will be. However, you don't. I mean, you might not need it. I think all of these patterns, everything that I've done here, it can be generated from scratch. Because again, there's nothing special going on here. But yeah, I should work on this. Expect a release this year.
Awesome.
I keep saying that, but yeah.
GitHub is just a few clicks away. All right, awesome. And let's see, gosh, you have some positive feedback here from people like, so good. Why did I know this existed until last week? Very MC Escher.
Oh yeah, yeah. Can I show you guys more nodes?
Yeah, go for
keep
it.
Keep going with these
Yeah,
nodes.
let's, let me just check how we're doing on time. I think we're good, right? Yeah, Sam, I think you were meant to go till, oh gosh, now that I look at the time, oh my gosh. All right, yeah, no, I think we've got slightly over, but that's okay. So we've got another speaker coming in, so
I see.
Okay, wrap it up.
I'll wrap it up.
Well, I tell you what, he's not on just yet. So if you want to show us just one more thing, I'll try and round him up.
Well, let's see. I've got spirals. I'll go really fast. I've got spirals. I've got hexagons. Check out my hexagons. Nobody's hexagons are as good as my hexagons.
Oh, I was wrong. You've got another 30 minutes.
Oh, I've got another 30. I've got like 20 minutes. Right? So I'm still going to like 6:30, right?
Yeah, well, everybody's got a different local time, but
I'm going to show
people. You're good till the half-hour mark. Let me put it.
Look at my hexagons. You're going to see like
I love hexagons actually.
They're the best, folks.
I got a hexagon fetish. Yeah,
we love them. We love hexagons, don't we? Yeah, yeah, the best kind. Yeah, no, it's the geometry of bees, and a lot of people, they're hawking their like $10 hexagon pattern generator on Blender Market, but can it do this? Can it go like, woo, can it do that? Didn't think so. We've got, let's see, we've got triangles. Got a triangle grid. Look at that. If you want to make triangles, we can make triangles. And again, the rules work exactly the same as with everything else. In the case of the triangle grid, it yields a whole bunch of different stuff, including this this means of sort of differentiating which triangles are pointing up and which triangles are pointing down. In the same way that the square vector grid, gives you both ramps and steps. You've got the same thing going on here. And so Snowflake is intended to be a kind of a broad solution for creating not every kind of, geometric pattern that's theoretically available or possible, but a lot of cool ones. So you're going to see the same kind of language in a lot of these different nodes in the system. Let's go to something like, I don't know, how about this? Let's do a nice like corner bevel. Let's see what happens when I plug in the try ramp here. Aha. we can actually bevel these corners. Let's see. And then we'll look at the edge distance there. So this is, again, this is just a system for you know, customizing these nodes. And because we have both ramp and step outputs available to us, we can modulate all of these regions individually if we want. I'll show you what I mean. What else? For instance, let's go back and let's just have our one grid here. We'll make it a little bit more interesting. Make it 8. We can, like I said, plug in the step function into a noise texture. Let's see, where does it go? Where's the noise? Ah, here it is. Just like that. And then take whatever's going on here and plug that into an edge distance function. And yeah, we can do all sorts of crazy stuff. There's let's see, there's a couple added things that kind of make it interesting that can, you know, spice up your life a little bit. There's the random color ramp function, which I enjoy. I like that because then you can kind of, oops, I should work on that. Let's see if we can scale this. There we go. I'm basically interpreting the field of numbers here as a space that can be scaled. So, you know, these nodes have so many different functions, and there's no wrong way of plugging them in together. It all works. Let's see. There's what else we got? Oh yeah, I've got rotational symmetry. That's fun. If we take this, plug that into there, and then I don't know, let's take a magic texture. How about that? Turn down the scale a little bit, and then turn up these divisions. You can see how easy it is with just a little bit of math and all of these repeating functions for all these, you know, just with simple modulos and step functions, we can create all kinds of interesting stuff. Let's see, separate. Well, I don't know, let's take the step function out of here. And again, you can see we've got this seam right here. This is what I wanted to show you earlier. If we plug in that function with this function, the parametric circle function, look at what we can do. We can convert this kind of hard edge. We can instead basically sample a Cartesian space. Instead, we're basically sampling by using this function. We're kind of sampling along a you know, we're going in a circle around a Cartesian grid, which allows us to actually travel in a circle. And so when we sample this, there's no longer that same kind of seam that we had earlier. You can see how it's disappeared. Whereas if we just did that, there's always going to be a seam there. And so that's just one example of how, you know, when we think about these things in Blender as just arbitrary fields of numbers, we can begin to create all kinds of crazy stuff. Are there any other questions?
Yeah, let's see. There's a question from Treasure. How often do you try to use the golden ratio, angle, or Fibonacci numbers in your patterns? Or do you just normally just randomly throw in anything?
I just throw in anything. The Fibonacci sequence hasn't come up yet. It's not something that emerges naturally in the work that I do, so to speak. So I think that's something that you have to kind of keep in mind consciously if you want to use something like that. A Fibonacci spiral, I think, is possible. I actually don't know. That would be interesting to find out if it's possible to generate such a spiral.
Yeah.
I don't think I've created that yet, so that should be my next project. Actually, that should be the
Okay.
next feature that I add. Should be a Fibonacci spiral.
Awesome. You got a lot of positive feedback in the channel. People are saying this is so much fun to watch. Have you considered doing some video tutorials? How can we get the add-on somewhere?
The add-on is if you email me, if you message me, I can give it to you, but it's broken right now. It needs to be, you know, you're not going to be happy with it because it's got bugs. It's not these nodes, they're not consistent yet. And you know, they haven't been properly organized either. I don't really know, you know, these categories that I'm sticking them into. You know, I'm calling this one vector math, scalar math. Well, it's all vector and scalar math, isn't it? So you know, what makes this vector math and this not vector math? You know, they're all vector math. So
Yeah.
it's a little tricky.
Fair enough. Yeah. People are saying so many floor tile patterns.
Yeah, that's the other thing. The reason I'm calling this, you can generate floor tile patterns. Not only can you generate floor tile patterns, but you can, for instance, generate infinite floor tile patterns. So if you wanted to, you could actually, why don't I show you? Let's pretend this is a floor tile pattern, and then we've got 2 floors, and then let's say I bring in my object info thing, and I don't know, I plug in the random value here. Now look at that. You know, we've got a unique system where each iteration, each version is slightly different. I can go back and I can, I don't know, plug the random function into here and make them even more different from each other. You know, now this one looks like this, and this one looks like this, and this one looks like this. And so I'm having difficulty describing what this whole process is, but it's kind of a way of taking the particular and making it generic, so to speak, and kind of taking everything that's, you know, set in stone and having it be modulated and then remodulated and then have the modulation be modulated, and you can just keep going you know, further and further backwards or deeper and deeper and deeper, and it's the result is, that's kind of cool. And yeah, a little trippy, kind of cool. And yeah, there's definitely, I mean, there's so much here that I haven't even begun to scratch the surface. You can do, I mean, if we wanted to, we could generate a system that, you know, just generated different kinds of gears if we wanted to. We could have the rotation of these gears be driven by something else. We could, you know, potentially figure out a way to make them all kind of interlock and move around if we wanted to. There's, yeah, the sky's the limit. with this kind of stuff. You can, of course, generate snowflakes with snowflakes. With Snowflake, you can generate snowflakes. I didn't even get around to explaining how to do that. But not only can you generate snowflakes, you can generate, with a particle system, you could plug in that little random input for the object. It works for particles too. And so in theory, you can have 1 million unique snowflakes using this system. So yeah, that's is there anything else people have asked? What are they?
I think that's
I just want to know when it's going to come out. When can I buy it?
Yeah.
When can I buy it on Gumroad?
Yeah, well, there's
take my money.
There's comments like I'm a newbie working in 3D. Thanks to discovering Blender during lockdown. This session is perfect for the dance related visuals I'd like to create. What's best for me to learn this magic?
What's best to learn this magic? Oh gosh.
Yeah, where do you get started? I guess.
I think here's the thing. I think the best way is just to pick something really that seems really easy. Pick something that seems like it ought to be easy to do. Then pick something that's even easier than that, and then just kind of jump in and try to do that. Try to make that happen. And just keep, open up Blender and just click around and you'll figure it out. I mean, I figured out there was no tutorial that I went to figure out how to make all these nodes. I just kind of sat down, I messed around with math nodes and ended up with this. And so, there's no master tutorial video that I've been watching to figure out how to do that. So, you don't necessarily need one either.
Yeah.
Just
go
jump in and mess around.
So there's a question in the chat. Can you show an example of where part of the pattern goes to color and part goes to displace? So to create a grout between the tile example.
Oh, that's a good one. Let's see. Let's create a new one here. So let's create a tile. Hold on, let me delete these other ones. Oops. And the question was what again?
So the question was, can you show an example where part of the pattern goes to color and part goes to displace so as to create grout between the tile example?
Oh yeah. So yeah, we can jump into that. So let's go to subdivide this really quickly. I'll make a 10 by 10 grid. And what I can do is then take the edge distance from here, plug that into, I don't know, let's say, actually, let's just do a regular color ramp. So we got something like that. And now watch this. Let's say we want to randomize, the displacement of these tiles. That's easy. All we got to do is take, again, the step function here, right? Plug that into the noise texture. Then use this as a factor, and then watch this. We can use that factor then to rotate. Where is it? We can use that to rotate these tiles. Now, of course, the result is going to rotate these like a hell of a lot. So, and it's going to be, the range of values here is skewed from 0 to 1 where we don't want it to be. So I've actually got to take a preset here that I've created where we map these ranges a little differently. And you can kind of see what's going on here. Some of these values are negative, so they will show up as black, but Blender can use negative values, no problem. And so now let me change the variety of of rotation that I'm doing here. Now you can see that I'm randomly rotating these tiles, so they're all kind of randomly displaced. And if I want to turn up the there's right now there's a uniformity to how much they're all displaced, so I can turn up the scale and make it really, really random if I wanted to, make them all kind of wiggle like that. And of course, you'll see that once the tile reaches the edge of its boundary, you can see some clipping there. So what we can do is maybe just turn that down a little bit. And I just brought in the math nodes here so you can use those. And just kind of let's make this a little bit more tame. And so now we've got some almost uniformly displaced tiles with grout in between them. You can kind of imagine from there what we can do. We can use this. We can use the output of this to be the mask of roughness. We can use the this gradient here to be a bump map. Yeah, there you go. That's a very good example of how a very good question I should add of how you can map these numbers arbitrarily. That's what nodes are all about. You can plug in the color of one thing into the displacement of another thing. You can plug in time itself into into all sorts of other inputs and do whatever you want. So the more you kind of broaden your mind into thinking of these things as just numbers that can be manipulated, in both spatially and temporally. You can do all kinds of cool stuff, and that's really what Snowflake helps enable. Is just a library of nodes to make a lot of this stuff, easier. So you can just get right into being creative and not having to, make the same sequence combination of math nodes, 10 times over every time you're working. That's what it's all about. Yeah, there it is. That's my system. Hope you liked it. Let me go back to the cool one. Yeah.
Wow, mesmerizing. Fantastic. Well, it's been super educational, certainly for a lot of people in the text chat. So thanks for joining us for our big event.
Thank you for having me.
Yeah, this has been great, Sam. I think with that, you're welcome to join us in the text chat on YouTube and answer any questions that people have. But yeah, I think overall that was fantastic. And
awesome.
Yeah, so I think let's see. If you want to hang out just a little while longer, we're just waiting for our next speaker.
I got one more.
Do you have any sites you want to show, like where to go for more information? Or
at the moment, there's nowhere for you to go. You just have to
go
to Blender.
Okay, Jacob, are you on the line? Oh, I didn't see you. Okay, I'm sorry, you were hidden under a Zoom
I'm totally here.
Okay, wonderful. Well, Sam, we'll say adieu. Thank you very much. And yeah, happy World Blender Meetup Day.
All right.
Excellent.
Thanks for having me.
Okay, cheers. All right, Jacob, thanks for your flexibility. Thanks for joining. For those that don't know Jacob, he's going to be presenting on a BGE, which is pretty exciting. I've been seeing some YouTube chat comments going on about it, so I know there's going to be a few people looking forward to this. But Jacob, why don't you go ahead and introduce yourself, like what your interest in Blender is and what you're going to talk about today.
So like a little bit around 10 years ago, I got into making like small games in Blender Game Engine, and it was pretty fun. And I tried to make bigger and bigger scale projects, and I noticed that the tools just didn't really scale well. So I started trying to make tools to make it scale better, and then I ended up becoming friends with the developers, and we just kind of have talked about the way the engine should go, and it's kind of went that way over time. Now you can call Blender game engine Python at the same time you can call Blender Python BPY. So like you can modify meshes in real time and that kind of stuff. So this scene that I'm in right now, you guys can see this, right?
Yep. Yeah, we can see your desktop fine.
So right now the engine started, right? And I've replicated most of the functionality of the viewport. So like you can zoom in, zoom out.
So
And then
do you want to start with like what a BGE is? You're gonna get to that.
UPBGE is Blender Game Engine restored to Blender 2.93. So it's using a BPY object and a KX object for every object. So right now, this is a map editor based on it. And it's calling BPY and BGE Python at the same time. And then when I quit, it's like a fancy modal operator. So you can use this to create tool sets, not just to make games. It's like a interactive mode. There's bullet collision shapes and all that good stuff that you can employ here. There's the viewport render. We can support grease pencil animations, XR actions branch. We have a branch of that called VR includes. That is right here. I don't want to go into my VR while screencasting and everything else. It makes it kind of tricky, but I can play a video of it. Let me bring up my YouTube. So let me move this little bar here. We can use the XR actions branch inside of UPBGE in the viewport. And here's an example of me doing that. All right, so these textures were generated by an AI. I still have to like put a roughness map on there. I have a edgeware mask I can use for the roughness map, but this texture was made by a robot. That's the thing. Deep style transfer. I used the edgeware mask as the basis. You guys can hear this? For the GAN to generate this texture. You probably can't hear my desktop audio, can you?
Yeah. Yes, we can.
Oh, okay, cool. Looks pretty good. Better than most of the stuff I could paint.
It's a little faint.
Here, I can. There we go. Skin.
Is there a voiceover with this, Jacob?
Is that really loud? The bullets. You can't hear that? I think that I think it's cut the voiceover because it's on my desktop audio.
Oh yeah, actually we can hear it now. That's great.
So I use thanks for watching. I use the VR controllers to assemble that robot in my game and then take control of him and then shoot all the stuff off the table. And the texturing on that, I used the edgeware mask from Cycles that I baked and then popped it into deep style and generated those textures from a Greeble sheet. So there's lots of fancy stuff you can do with Blender nowadays. So that's using VR. And then this is Yo-Ho Mate. So we have real-time modifiers in the viewport now. So this is using real-time displacement. And then I'm using nodes to animate the ripples. And it's using the texture chord node to get at where to put the ripples. And using the gradient node to make those. But basically anything you can dream of in Blender, you can do inside of this game engine. And they're trying to keep up with master. So it's in the prototyping branch. So every time something new comes out, they have to compensate for it. And it kind of breaks things a little bit. But this is so that when they migrate to Vulkan, that they won't be so far behind that they can't keep up. So we are like usually 2 or 3 days between merges or less with master branch. So like all the fancy new stuff you want to test will be here too. Let's see. So this is like a physics simulation. using the engine. So here's the script. Basically, I take all these things. I have a point in space that marches down. And then once they're below it, they get activated. And when they get activated, they get pulled onto a plane for an object, spun around in a circle, and then pulled in and out using physics. So it's all forces. I can take this kind of stuff and keep track of it and write F curves and save animations that you could render out in cycles as well. So you can use this as a production tool. So I'm using cosine of time and things like that to make it do this. And I have it so it ramps up over time. So the effect gets stronger and stronger. And I'm manipulating object color. And object color is like a uniform that you can use in a shader graph. So these cubes, the reason they glow.
Beautiful, by the way.
Thank you.
Sure.
So it's using object info and then multiplying it. It shouldn't say 0 there, though. Oh, it's really, 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 really low. That's what it is, 0.00001. Like, why does it say 0? So it pipes that into emission. And then we have bloom turned on in the scene. And this is the center of the effect. So like, say I move this over here. Now the stuff will move over there instead because it's relative to the object. Whoa. The faster they move, the brighter they glow. And since it's that far away, they get pulled faster, you know? So I am using some kind of advanced vector math there. What we do is we get a local from the empty to the thing saying, hey, where are you locally? And then it gets a spot on the plane by chopping the z off the local. And that's what this is. So we transform that coordinate back to world space and pull them to that. And then this is the force that makes them go in and out on a cosine on the plane. And then this is the one that accelerates it around in circles, I think. So a lot of this stuff, I kind of free form it. Like it starts off as an experiment, you know? And you can do literally anything you could think of. I've done robotics in here. There's a wrapper yet to be done that would be amazing. Is this BT multi-body is in Bullet, and they use that to simulate physics robots, a URDF, Universal Robot Descriptor File. And there's an add-on for Blender called Phobos that generates URDF from Blender armatures. So you could basically set up an armature actor and be like, now you're a robot. And then throw them in a scene, and it's like a ragdoll that can apply forces and be realistic, you know, like almost like Rockstar Game stuff. The forgot the name of it. Their library that simulates physics rigid body actors. So another one. Oh yeah, my main project. Let's see. I have a lot of stuff.
You can get feedback from the stream. People are saying super cool. That looked really cool. Looks great. Amazing. That is wild. So they like the demos.
Oh yeah, that's my VR game. I have way too many files is one of my issues. Oh yeah, duh, I put it on my Google Drive. That's right. I have a lot of these on the Google Drive so that you can play them later. So I have links to these and I can drop those into the thing.
So we have a question here. Can you go from Blender to ROS, whatever that is?
ROS is a robot simulator engine or whatever, but what you would have to do is take that and have data from Blender get passed to ROS, sim it, and then pass the stuff back into Blender. You wouldn't be able to, I guess you could take the ROS window and then render it into the texture buffer for the screen. We do that in BGE and stuff. You could take the buffers for a viewport and then just write right over it. As long as Blender's not writing in it, you could take another app and do what UPBGE does and render into the viewport, basically. Yeah, you could take any program and link it in like this. It's just not easy. Ewell did this. What happened was in 2.79, the devs decided to cut the engine because there was going to be just too much intellectual debt with porting the engine over to the new render, the new video system, GPU, and all that. They're like, well, we'll just leave it. And the community picked it up and they're like, we won't have that. And they put it back. And it was Yule and Lord Loki. And there's some other people that have helped. WKK, Mystic Fall. Mystic Fall just did a patch with pointers for components. So you can have a pointer to an object in the scene in your component as a dropdown. So you can be like, use this light or whatever. There's components for Python. I don't really use them so much, but you can create Python components, which are very oop or whatever. I tend to script like up here. Like I write a script right here and hit play, and then the logic bricks take over and they engage. Like this is my logic systems that I created for state machines for actors. I haven't tried that in this new version, but it should work okay. So I have a really big HDRI. So right now it has to compile all the shaders, and the bigger the HDRI you have for the background, the longer that takes, I've noticed. There's some recent optimizations in master for shadows and things like that. Oh yeah, it's not running right. My feet are underground and it's not doing it. Yeah. Healthy UI. Yeah, this isn't working quite right. So I haven't opened it in this new version, so that's probably what bit me here. So anytime you go between Blender versions, it's a good idea to see what happened and like find out what's wrong, because I report the bugs to keep the thing working. So the better the users are at that, the better the engine works. But they're always keeping up with the devs work too, from master. So yeah, I use compound collision shapes, and for some reason their foot shape wasn't updating, so they were sitting on their torso. I'll have to look into that later. Hi, McKinley. My daughter's bouncing the ball over here. So again, it's compiling all the shaders for the scene. And I have a black screen. Of course, everything always goes wrong when you're showing people stuff.
It's a universal rule of demos, right? Whatever can go wrong will go wrong.
Well, what I can do is I have canned footage of the exact same thing. Let me go to my video. What is it? Murphy's Law. That's the one.
Murphy's Law. Yeah. Yeah. We'll sacrifice a Maya license or something for you.
This is the newest branch that
make the demo gods happy.
You can spawn collection instances and have rigid body joints. So here we are. I have licensed rectified beta under the MIT 3.0 license attribution version, which means you basically just have to say that I made it. And please donate to my Patreon. I'll pop it in the description. But here's what you got. It's a real game in UPVG 3.0, which is in Blender 2.93, I think. And it's in the experimental branch, basically. So here we go. I'm alive. Switch people. Pick up weapons. Aim. Shoot stuff. Stuff can shoot me too. I can die. There's ragdolls. Now I'm the other guy. Now this thing can kill me as well, or I can kill it back. So we have like a little game here. All right, so I win. I live. It has dialogues. It has UI elements. It has all that good stuff. All right, thanks for watching, and please support my Patreon. Thanks. So basically, the more complex a project is, the more that can go wrong. So I should have probably tried that out before just now to see if it would work. There's other things that I've been using the engine for that other people might find very interesting, and that is PEX. which is a picture augmented communication system. So normally,
So there was a quick question in the chat. Is it using EV for the renderer?
yes, it's using EV or cycles. If you had a GPU that's fast enough, theoretically, you could click use viewport render and use cycles. But basically, it's updating the scene graph, and it takes the BPY objects, wraps them in a KX object, and drives them around in the scene. So it's like giving them a physics wrapper and a logic wrapper, each object. It's a little bit less efficient than having one really robust object, but then you run into like a God object problem, like with having to have everything in one thing or whatever, you know, you don't want to have all the game stuff slowing down Blender. So it's like a compromise. So you can do own.blenderObject.data, and that's the mesh. That's a BPY mesh, and you can do like 4 vertices in own.blenderObject.data.vertices, and you can like iterate over them and do all that stuff. So the API inside of the game engine now is the same as the one that you use to make add-ons. So it's very powerful if you make add-ons. So this is BPEX. So this is using told the text and stuff. So it's OpenXR. So flashy. These are still kind of bright. I'm gonna fix that. So this is to help kids talk, but my daughter has autism. Everything's working. If I rotate my head, click a menu, everything still isn't aligned. Before it was kind of skewed, like it used the alignment of the camera instead of the back plate. I still have a position where an issue with its position. I have to work out my equations a little bit different. Like right now, that's where it's supposed to be. But if I look up, it moves it down just a little bit. If I turn my head sideways, it moves it down a lot. But we'll figure it out. Right now, it's still usable as it is.
I want coffee. I want coffee, please.
So yeah, it's much faster typing with 2. I could spread these out a little bit and then curve the keyboard some, and curve the screen some, and then add the rest of the keys. And I think it's ready to go. And then I'll need an augmented reality headset to test it with, and then to see if it's actually easier to use than a tablet. But I think it'll be intuitive to be able to reach out and type with your regular hands, like using gesture recognition and positional tracking using the cameras. But we'll see where it goes. Thanks for watching. So that's BPEX. So that's they have lots of virtual reality glasses coming out soon for augmented reality. Facebook is working on them. Apple has some, and so does what is the other company? Qualcomm. So they all have competing projects for this space. Then they're all OpenXR compatible, which means that if everything aligns, that UPVGE should be able to run on all of those devices. So a kid could put on a pair of glasses and be able to talk with them instead of having to lug around a tablet and like, hold on, let me open my voice and wait for it to load. It's like they always have it right there. So that's BPEX. And then, so we'll go over my demo files here. I have links to a lot of this stuff on my Google Drive. So this is the map editor that I was showing. This is a libload example. It actually opens up a file next to the file using Blender's API, and then converts it using the scene converter into a KX object. So you can like have files next to your game to load in. And for productions, this makes a lot of sense so that you don't have a mess. You have like an asset folder and then a file in there. And that way, if you're distributing the work and someone overwrites a file or whatever, everything just works. You don't have to like append new stuff in and clean up old garbage. So libload is very handy. And that just uses BPY append API. And then you get the scene, and the scene has a new function called convert blender object. You just scene.convert blender object, and then bam, it's a KX object. So you can even import assets from other file types, like MD5, anything Blender can load basically will load into the game engine now. but you have to like kind of wrap it. The other file that I have to share. So this is the version that has VR wrapped, and it's a Windows 64 one. And let me grab a link to it. And then go to the Zoom chat. Is there a way to have this show up in the video, or does it? If I post in the Zoom chat, or no?
No, it's if you post it in the Zoom chat, I could relay it to the YouTube chat.
Okay.
Oh, well, actually, you know what? I'm sorry. Chat's I'm sorry, chat's disabled.
Oh.
Because it was impacting our streaming. So
Okay,
if you
here,
put it
let
in, if you put it in
Discord.
Discord, I can get it to. I can get it to
Oh.
folks. Awesome. People get to see behind the scenes here
So-
at World Blender Meetup Day. This is how we organize with our speakers.
So there's the UPBG itself that has XR actions. So what this does is up here, there's already a VR tab normally, but it adds a lot more stuff. So actions, you can bind an action here. Oh, this is why my thing didn't work. This is exactly it. When I was trying to open it before. Oh, never mind. This is a different file. Okay, cool. So you can bind an action to like one of the joystick buttons on your VR. So when you click it in, invoke Blender Sculpt or whatever, but you'd have to override context and pass data to be able to have it work. But basically, you can set up anything right now in the XR Actions branch of Blender. That is here. So in Blender chat, there's a section for this branch, which is in development, which is going to merge into Blender, which means it merges into UPBG as well. So.
All right, I put that into the YouTube chat so people have that code.
Yeah. All right, and then another one. So there's a VR basic setup. So this makes it so you can throw objects and catch them in the air and stuff like that. Let me grab that, and then I'll show a little video of it. Hush, puppers. So that is the same place.
Great. Thanks, Jacob.
Discord. Open. Here. So, and then the file. So you can actually see what it looks like. This is it. All right, so now thumbstick is dropped, and then left click triggers a property called tool if it's in the object. So it could be a weapon, a tool, a quest item, whatever. You can trigger it by clicking again once you picked it up. Works with either hand. This doesn't have any code in it. It just has a none function it's calling. So whatever is in it, it'll call right now. This calls bullet. So we can take it, I can pass it in. I implemented something where it just floats up to your hand later, but this is where I was at. Now we gotta go. Phew. Let me get rid of this thing. But yeah, we can have it trigger the code. It can do whatever. This is adding a bullet, but this is the tool code. I have to say this functionality is amazing to me. The function that it's inside of it. So let me select the tool real quick so you can see that. It's like you're in your own plane of existence.
It's very meta.
Call pretty much any kind of a function now. So what we have here, tool, this is what triggers it. Cycle, this is the duration, like when it triggered again. So like a fully automatic weapon, it could be something like 2 or something like that. So every 2 frames, they'll make a bullet. And then function is what to call. And then args is what arguments to pack into that function. And then it actually scrapes them. We got projectile and life right here, where it says if own args does not equal blank, and then it uses AST to snag the arguments, and then it looks the arguments up as properties from the object and packs them. So it's much less complicated. Like, I mean, it is complicated, but now you don't have a bunch of arguments to pack. It just does it automatically right here. And then it calls a function from up above. Apparently, I can't select the scroll up with the VR thing. I have birds, dogs, cats, you name it. So there's add bullet. So it gets the arguments out of the argument dictionary. And it makes it nice and short and sweet. We don't have to look up a bunch of stuff. So I can make some more functions and examples, but this is VR test scene 2, and I'll have the file up shortly. All right, thanks for watching. All right, so what that does, that little tool operator though, is you could put sculpt in there or make terrain blob or whatever you could think of, and then call it with that. So you could have like little tool tips and have it almost be like working with stuff in a real shop. Like you just pick up a tool and do something, set down a different tool, and then have like the various knobs and stuff that are on the VR sticks interact with the properties inside the object that it's packing. Makes it pretty slick. I think that this is the future of Blender, but I think this is where it needs to go, to where you just hop into VR. And then there's another thing that I wanted to cover. I don't know if I have time. How long am I supposed to go?
We have you scheduled to the end of the hour, but you know, we're super flexible.
Okay, so Ubisoft Mixer. So what this does is it will sync your scenes, and this will work outside of UPBGE. It works in Blender. So you can have multiple people editing the same file at the same time. So if you did this with VR and passed the pose between each other, you could have people hanging out together in VR, basically. And you could work together and then hit go and fire up the game engine and test your games you made in VR, or make movies, or even develop stuff like engineering stuff, like sit around and talk, or even just chat. But this basically is the thing to turn Blender multiplayer. And it's made by Ubisoft. Ubisoft Mixer. Multiplayer Blender. So there's that. And this is another thing I wanted to touch on. Frank Mocap. So Frank Mocap is by Facebook. And this does pose estimation from single frames of images. And it does hands. And this, my BPEX application could use this to do a physics sim to touch the buttons with your fingers. So this should be really handy to animators in Blender. And if anybody can make any add-ons that's watching, it's called Frank Mocap. So yeah, that was, other than that, there's tons of BGE games in the works by all kinds of people who are amazing. There's Uniday, there's a Brazilian community, there's tons of Brazilians who use BGE. There's AKM making a sailing game that's really beautiful. It looks like a day at the beach. A lot of people use the older version of the engine still because it works on dinosaur hardware. But there's users all the way back to 2.49. So everybody's welcome.
Can you show an example of your favorite BGE game? Like, what's the most impressive looking game you've ever seen?
There's stuff on Steam right now.
Yeah, let's see if you.
Battle Arena. This is using an older version of the engine. It's amazing. It doesn't matter what engine you use, it's how much talent you have. And this is in BGE. That's in Blender 2.79.6.
So
and that's online right now. The developer said he made enough off of his games to buy a Mercedes. He made this, Tomato Jones 1, 2, and 3. Here, we'll show you those. It's a strong engine. It wraps bullet, SDL2, out of space engine. Now we have the new line art modifier, works in real time, but it's not very fast. So you can generate line art based on this stuff, but it'll be heavy on the depths graph. Basically though, anything that works in the viewport works in the new version of the engine. So VDBs, all that stuff. The stuff that's been added, grease pencil just got fixed, so you can play grease pencil animations with the logic bricks. There's, let's see, convert object was a big one.
We did have another question. Can you show more of the AI shader to auto texture objects like the robot? Is it open source?
So what it was I take the object and unwrap it in a manner that the panels that like, what is it, auto unwrap, where the edges don't necessarily meet, and that's a problem with it. It makes textures that look okay, but I use deep style transfer, and there's a number of these. There's some that are online, like this is my account, and you can generate all kinds of weird stuff, but I can also generate styles of UVs from here. I'd have to go back in time pretty far here to look for those. Let's see. But I just experimented with this and found out, here it is. So that if you put in UV maps of edge wear masks, that you can generate those. That's how I generated the model that you saw there is one of these. Let's see. And each one of these is a different style of robot, but it has little artifacts because the thing is not aware of UV seams. But it took some testing to get it to dial in. Like you have to scale stuff so that it actually generates. Like see, that's the top of the robot. And that's all generated by neural network. So if this thing were to know though, about details across the UV islands so that it were to draw them, you know what I mean? Like, so the details that it synthesizes to figure out where edges are, if they passed across these islands, you could do perfect UV texture and just be like, I would like this object in the style of this lamp or whatever. But I do not know that part. I've actually reached out to a couple of groups about that. UV island aware deep transfer style. But that's how I did it.
Very cool.
And if you have any other questions at all, I am free to answer questions.
Okay,
and
great.
We have a Discord group too. So if people want to go on there, let me drop that in your links.
Yeah, sounds good.
So this is where the devs hang out and everybody else. We've got a couple hundred members or more. There's constant work on all kinds of fronts here, logic nodes, people's games, the developers and stuff. So create invite. I will edit this to never expire and for no limit on users.
Awesome. I will paste that into the YouTube chat. So yeah, why don't you jump in our YouTube chat room and then you can answer any trailing questions that come up. But yeah, we really want to thank you for your time, Jacob, and it's super interesting stuff.
No problem. It was really fun.
Yeah. Yeah. Happy World. Sorry, what?
Oh, I said check out the engine. It's fun. I mean, it's something like if you're bored or whatever, it's more fun than playing games now to me.
Yeah, because you get to create.
Yeah, you can literally anything you could think of. You could just whoosh, throw it together. There's some stuff I didn't share that I may have shared last time, like with world generation and streaming height fields and stuff. But literally anything you can think of is possible.
Cool. All right. Well, thanks for joining. And yeah, again, jump in the YouTube chat, hang out with us. We have I think 2 more sessions before we wrap the whole event. So thanks for coming. And for those that are still with us, we are transitioning to Grant Abbott is our next presentation session. Grant's from Ipswich, and he'll be presenting on Q&A on sculpting for Blender. So you can reach Grant at gabbott.co.uk. Let's see if we can get him up. So. All right, so here comes Grant.
Hello, everybody, in World Blender Meetup Day. I'm not
Actually,
sure
I'm
quite
not sure
how
if I
this is
shared that
working.
with sound, so let me do that just one more time. Let's see. I did.
To
Great.
sort of people in the local. Hello, everybody, in World Blender Meetup Day. I'm not sure quite how this is working. I'm Grant Abbott, by the way, but like I said, I'm not sure how this is working, whether it's a local thing. And so am I saying hello to sort of people in the local area, or am I saying hello to the world? Who knows? But hello to you, whoever you are. I'm Grant Abbott, so I am more commonly known as a YouTuber with sort of Blender artist YouTuber, and mainly about sort of beginner to intermediate tutorials, so getting people started in Blender. That's my passion anyway, trying to simplify the complicated world that is Blender. Well, that is 3D art in general, I would say. So I've got some questions here, and I'm going to try and go through them with the best of my ability and best of my knowledge. I've been pretty busy recently, so this is a bit sort of ad hoc, but I wanted to be able to get involved. It's good fun, and it's nice to be able to reach out to the community. I have quite a passion for learning, so it was important to me to be here. But I thought I'd mention the fact that I'm busy because I work primarily in Blender, and there's lots of work out there, so I'm having to turn lots of work down. So there are jobs out there for you if you are an aspiring artist and you want a career and you want to use Blender as your tool. That's often a question I get asked. What should I be learning? Blender's fine to learn, and it is used in industry, but not as commonly as other ones. Anyway, that's a different question, and that's not on my question list. So I'm looking at my list down here of questions, mainly about sculpting in Blender for beginners. So I'm going to kind of keep in that direction if you wanted to know what I'm talking about. So would you mind sharing one of your first and one of your latest Blender sculpts to get people inspired, was the first question. So if I show if I move across the side, and then I can sort of show my latest sculpt up here. Most of the time these days I'm doing tutorials, so I don't get a lot of time to do personal things. I'll keep over this side in case it's appearing. I'm going to edit this video and it's going to magically appear. You'll see it, I'm not seeing it, you see. So I don't get a lot of time to do my own personal sculpts, which is a bit disappointing. But every now and again I dip in and do my own personal work. But most of the time I try and do it as a tutorial. So if you want to learn how to make this beautiful axe, then check out my tutorial videos on YouTube. It's a series that goes through the whole process of sculpting and texturing. And it's supposed to be a detailed game asset. So it's a low poly asset that you could put into a game. That's the thinking behind it. So that's my latest. In terms of my earliest work, I haven't got any of that. It was so long ago. I started Blender about 20 years ago, and it would have been dreadful. And I can't even remember whether there was sculpting in the program at the time. I may not have even noticed it was there. It was really hard to model using Blender back then. Even things like the knife tool didn't exist, so you couldn't. As far as I remember, I just remember having so much difficulty figuring out how to make objects just out of box modeling. It was just so difficult. can't express the pain that it was to try and use 3D modeling back then. So in terms of my first ever sculpt, it was actually Maya, and it was an orange with a face on it. And I was so blown away that you could actually sculpt the topology. And I thought, wow, I don't have to be an amazing technical wizard. I can be an artist and use these programs, and that was a big eye-opener for me. But you could still only have a certain amount of topology, so you were really limited. The computers were so much slower then, so minor adjustments were quite costly. If you made a mistake, undoing took a few seconds, so it was very, very clunky and very difficult to sculpt. So in terms of my early work, I haven't got any of that anymore. It was so long ago that, and this is before YouTube and before social media, really, that we didn't really have keep many records of these things. They were like, it's on a CD somewhere around here. So yeah, just imagine some really bad work, and that was me. And I slowly built up the skill level within sculpting just through practicing and through sort of art skills. But I'll go back to the questions, and hopefully you don't need inspiration. You can just think of some really rubbish sculpt and imagine that everybody starts somewhere. So you'll have a rubbish sculpt
when you first start. Okay, so do you need hand drawing or hand sculpting skills? Well, I'm a big proponent of learning to draw and working on 2D artwork as well as 3D. I think the knowledge you get from it is, it gives your art a real boost. You can always tell the beginners, they seem to make huge strides if they've got an artistic background. They'll suddenly make something that's really cool, and they'll make it in a simple way, so low poly work, for example, but they'll know about lighting, they'll understand construction, scene construction, and so it gives you a massive jump up if you've got some art skills. And I think it's really important as well, if you want to be a master within the 3D modeling world and you want to improve your skills, well, improve those areas that you're not so good at, and it will make the whole of you better, rather than just being, right, I'm all about hard surface modeling and that's all I'm going to do. You really limit yourself, and you don't get the experience from the other areas. So if you wanted to make a cool alien that had some mechanic objects in it, you've got to sculpt the organic side as well as do the hard surface modeling. And if you want to set it in a scene, a cool sci-fi scene or something, then you've got to know a bit about photography and construction, scene construction, to make it look cool, and lighting especially. So getting all your skills there. I mean, obviously this takes time, and I'm not saying you need them all. You don't need it, but it will certainly help, and it will make you a better all-round 3D artist. So yes, I would strongly recommend doing some 2D work, some drawing and things. On that note, I've got a new drawing course out now. That's not why I'm saying you need it, and doing a bit of a sell there. But you can find links on my YouTube channel to just basic guides to digital drawing for free, and then there's a drawing course if you're interested. And it's learning to draw, creating game art, so you might be interested in that if you want to know about that. Bit of a sell there, sorry about that. Is anatomy knowledge needed if you want to start sculpting people or animals? Yes, yeah, definitely. I suppose the question was, if you want to start sculpting, you don't have to have the knowledge, but if you want to be better at sculpting, you need anatomy knowledge. Now, you don't need to know all the names of the muscles. That's really not important. What you need to understand is how the muscles work together. And you'll see it. In fact, it was in my early work. If I were to show some of my early sculpting work, my muscles in my sculpts were all over the place. But to me, I was thinking, well, the pectoral muscles and the abs are there. Yeah, that's all working around. And I had about a 20 pack rather than a 6-pack sort of thing. So if you don't know where the muscles go, it's very difficult to sculpt a realistic human, or animal for that matter. You can get away with a lot more with animals because we're not so used to looking at them, so we probably won't notice when the muscles are out slightly. But in humans, straight away you'll think, oh, that looks odd. So yes, you do need to know some anatomy. Can you recommend some traditional books around sculpting to get inspired? Well, actually, it's not traditional art book, but the best book I've seen is Anatomy for Sculptors. And it just breaks it down really nicely, so sort of blocks out areas that you need to think about, because there's quite a lot of muscles and tendons and so forth in your forearm. There's a bone to think about. Was it 2 bones down there? Whatever. See, my anatomy's not that great. But you only need to really think about the big, bulky ones, and that's where the Anatomy of Sculptors book is really good, because it says this block muscle here, this block muscle here, and it's quite expensive, unfortunately, but it's a book I would thoroughly recommend. So I think I do a review of that if you're interested on my YouTube channel and you want to know more. Most of these things, I've got a video somewhere on my YouTube channel. I do quite a lot of videos, so I'll probably keep saying, there's a video on my YouTube channel, so sorry about that if I get annoyed with that. Can you recommend some inspiring digital sculpting artists to keep an eye out for? Well, that's an interesting question. I think the main one for us using Blender is to keep an eye on Pablo, who's working on the sculpting engine within Blender, and making strides in that each day. And he does some very nice art as well. But generally speaking, I don't have one artist that I go to. I like to look at ArtStation or even Pinterest sites like that, where I can or Sketchfab as well. That's a really good one because you can go round the model in 3D. And I'll look on those sites, see how things are made, and it doesn't really matter who it's made by, it's whether it's quality or not. And you can kind of get caught up a little bit in sort of fandom, if that is a word, isn't it? Yeah. Where you just become a fan of that artist and you love everything they do, but then you lose the ability to critique, I should say, not criticize, and think about the distance from you to them and how you can improve. And that's why I look at artwork online, is how can I improve? What can I get from that and improve myself? Obviously, you have to respect these artists and like their work and share their work to support them, because it's wonderful to see and it's great that they're doing that. But I'm not much of a person who's a fan, if that makes sense. So keep a varied eye out for different things, and that will give you more different areas and different strings to your bow, and different ideas as well. That's really important. So lots of areas. Do I need an expensive and powerful computer for sculpting? Kind of, yeah, I'm afraid. Sculpting will push your PC to the max. I say PC, there's another question coming up. I've got a reasonably powerful computer here. It's a Ryzen 3700, and I suppose that's the most important because the graphics card is only for rendering, but in terms of on your screen and so forth, so it doesn't make too much difference to your sculpting. But it's a RTX 280 Ti. And the whole machine costs £2,000. So it's quite a lot, but I suppose I'm pushing the sculpting to its max, so going to 6 million polygons quite regularly, and even my machine will slow down. It does depend on a few things, that and how optimal you're working and so forth. But you can work on a low-grade machine. A low-grade machine, is that the word? You can work on a laptop even, and get away with it. And I used to, when I was showing work at school, because I used to be a teacher in a college, I work on the school laptop with a graphics tablet. Certainly that's another question, I think. But that was on a laptop, and you could sculpt away to about 500,000 roughly on this fairly good laptop, but it's still a laptop, so it's not going to be as good as a sort of cheaper desktop. So it's not a must. But if you want to go to the higher levels where there's lots of detail, then you'll need a good PC. But you don't have to. You can still learn sculpting on a lower end PC, but you can't expect to go to those higher levels of detail. That's the only thing. But in that sense, going off on one of this, the higher levels of detail you don't want to jump to as a beginner anyway. You want to understand shape and form first. So keep your sculpts lower resolution and work on getting the shapes right. I have got a sculpting playlist and sort of follow along where I make sort of things like little cats and owls, and I can't remember the other things, but they're nice sort of easy sculpts to get you used to using the tools and getting the shapes right. And it's not about going into a high resolution and getting etchings on armor and all that sort of thing. Like the axe that I showed you, there's sort of lots of detail in that, and it goes that little bit further, I would say. So you don't need to do that. Learn the basics and the form first, and that's what I always say to beginners. Learn how to do the shapes and form to start off with. What's the next question then? Yes, is a drawing tablet needed? If so, what's a good choice for a beginner with a budget? Yes, a drawing tablet is needed. There'll be people out there who tell you, yes, I can sculpt without a drawing tablet. It will take them probably twice as long to achieve the same effect. And I don't think it can be as good. They might say it is, but it's really tough to get the same quality, in my opinion. And there's some debate there, so you can, but it will take you longer, and it's very, very difficult. So just get a tablet, is what I'm saying. At cheaper end, that you've got the brands like XP Pen, Gammon, Huion, UG. I'm probably missing a few, Artisol as well. The one I've found the best is XP Pen. Wacom is the more expensive one, and I find that the XP Pen brand meets the Wacom brand fine. I don't think there's much difference between them, especially when it's just an ordinary tablet, and that's one without a screen. When it comes to laptop tablets with a screen, so you're drawing onto the screen, they are much nicer because you don't have that hand-eye coordination. When you've got just a normal drawing tablet and you're looking up at the screen, it's really tough to get your hand-eye coordination, so you're looking up whilst drawing, and that takes a good couple of hours of drawing before you've got that. However, working on a screen, you don't have to go through that stage. The problems you get with working on a screen is that you've got that screen thickness, so your pen doesn't quite meet exactly where you think it would and what you're drawing away. But it takes just a little bit of getting used to, but it's not a deal breaker. They're still really great. However, some of the more expensive screens, tablets, have a much smaller laminated screen. That's the one to look for. So the Pro brands usually. Wacom are hugely expensive when it comes to that, in the thousands, whereas XP Pen gets close to Wacom, very, very close, and you probably wouldn't notice the difference as a beginner. I'm using an XP Pen display tablet. I'm looking at it right now because it's close enough for me, especially when you're sculpting. When you're doing hand drawing and artwork, it's even more important to be precise. But with sculpting, you'd be surprised. You don't have to be precise in terms of where the stylus is pointing at, and so the calibration is the word I'm looking for. So hopefully that makes sense. But if you're sculpting, a cheaper brand is probably better to go for. If you're doing 2D art and you want to get really fine details, then perhaps going for a more expensive Wacom if you can afford it. But like I say, I'm using the XP Pen. I'm very happy with it. But go for the Pro versions that have the laminated screen. But they are still fairly expensive, looking between £300 and £500, depending on the size of the screen. In terms of the basic drawing tablet, I'd go for the XP Pen. I think there's the Deco and the XP Pen Star. But you want to go for a medium size. Don't go for a really small one. It's very hard to work on. So something about 6x4 minimum, and that's inches. Okay, and I've mentioned about tablets with screens, which was the next question. Okay, so in Blender, is it possible to match the properties of physical materials? So soft clay is manipulated in a different way to stone. And also some material is slow and some slick. So the difference between cold plastics and warm plastics. Okay, so when you're sculpting, the sculpting engines generally sort of mimic clay. And if you want to turn the clay into stone, you do that within the materials. If we were sculpting stone, then you could do it in the way you sculpt. You could just use the bisect tool and cut into your lump of stone if you wanted to call it stone. But it's much easier to work with clay and then make it look like stone or make it look like plastic. So no is the answer to that, but you don't want to. You want to sculpt in a way that looks like a certain material and then change that with the textures, and that's more about texturing. I think I might be answering and in fact I'll move on from that. So the answer is no to that. Soft clay is what you're kind of thinking and working with, and then you add a material to it. If you are only interested in sculpting, is general Blender knowledge needed? So that I'm sort of was about to answer that question. So there I'm talking about materials. So yes, you want to know about the shader editor, as it's called now. It used to be called the node editor. So understanding nodes. Check out my Nodes for Noobs, or Node School, I think I call it, playlist, if you want to know about that. There's a sculpting playlist on my channel as well. There's loads on my channel. Just go there. You won't regret it. But yes, you do need other knowledge of other areas. Not so much like the hard surface modeling or box modeling. You need to really understand topology. You don't need to know that so much if you're only sculpting. Let's say you want to print out your 3D sculpts and that's all you want to do. Then you can probably get away with just knowing about the sculpting aspects of Blender. But if you want to work in the industry, you certainly need to know a little bit about all the aspects. I think will help you greatly. If you want to know the different pipelines within making models for films and video games, then check out my video on making amazing 3D models for film and games. It goes that way. I go through all the pipeline. There's rigging, animation, all things like that. So if you want to know a sort of overview of what the different parts that you need to know are, then go and see that video. So where are we up to? There are loads of sculpting brushes in Blender. Are there one or two brushes you can recommend to start with? Yes. So the default brush is the draw brush, and that's probably the best brush just for getting used to. Combined with the just basic draw brush, there's the snake hook tool, and that's the most fun one to use. But if you're a beginner, I would suggest putting it onto the dynamic topology, which makes your mesh sort of grow as you pull it out. And then you can use the snake hook tool and sort of pull and make wonderful weird objects. And using that is much less complicated than the other process, which is remeshing all the time. So there's two ways of doing it, remesh and dyne topo. And I would suggest for beginners using dyne topo, but be very careful of the detail of your brush, because if you whack that up loads or pull it down, it's a complicated process, but put it on constant detail and put the resolution not too high, and then just play around. If it's all looking really blocky, then you've got your brush detail too low. If your computer's lagging, you've got it too high, and you want to find a sweet spot in the middle where you can sort of pull around and have some fun. So the basic draw brush and the snake hook tool, those are the two that are the most fun. After that, brushes like the crease brush is really important for when you get into the sort of lines in the face or the eyelids and also things like that. The crease brush is really great. And if you're doing sort of hard surface models, so guns or something like that, which is very hard to sculpt, and you shouldn't really use the sculpting engine for that. But then you'll want to do the crease brush combined with the pinch brush, and then you get some really sort of sharp lines. Yeah. What are some good beginner exercises? Well, I'm glad you asked. There's a great YouTube channel. Yeah, I would suggest going across to my YouTube channel, because I've got exactly that sort of beginner exercises where you can follow along making it with me. But starting off with simple shapes. So nice, cute animals like an owl, the sort of big, bubbly owl, or a cat or something like that, and make it really simplify the shapes. And that's quite fun. Faces are quite tough, but cartoon faces are okay. But where you start adding details like creases and the lines, and not that I've got any wrinkles at all, but when you start adding those sort of details, then it gets quite tough and you'll get lost pretty quickly. Get your art out of Blender, so that's the next section. Rendering looks like a steep learning curve. Is there a way to make nice looking screenshots? That's an interesting question. You know, I missed that one whilst I was reading these through. Yes, there is, because Eevee's pretty good these days, and so the what's it called? It used to be called Look Dev, Material Preview Mode. So you can get screenshots out of there that are pretty decent. But learn rendering. It won't take you too long. In fact, I've got a video on how to make your renders look really nice. And it's kind of aimed at sculptors, really. Just you set up 3 lights around your object and you press F12, which is the render, and you're away. Do you know, it's just dawned on me that I've missed a question in the technical requirements, but I'll come back to that in a second. Yeah, learn a bit of rendering, but just put an HDRI in the background and render it, because an HDRI will light your object in a nice, natural way. So that's the best way. I'll just quickly go back to the question that I missed, and it was, do you recommend a Mac or PC for Blender? I want to do some rendering in the future. And it's an interesting question though. I worked with Macs at the college I was working at, and we had to use Blender on the Macs, and it was a pain, to be honest. And if they had bought PCs for the same price, it would have been much easier. So you get so much more for your money with a PC, and in terms of Blender, you need that computing power, in my opinion. I always have to say in my opinion. So Macs are great, they're very stable, but Blender was kind of built on a PC, and if you're going to Blender, you should use it on Linux apparently, or Linux, or however you pronounce it. I don't know, I just use a Windows-based PC. But I would steer clear of Macs. They're not worth the money when you're talking about 3D art, in my opinion. Again, I'm saying all these things in my opinion, but I was disappointed when I saw Macs, that we were given Macs for at college for Blender, and we had lots of problems with them because they didn't have a very compatible graphics card. So, it was just a pain. So yeah, get a PC. Sorry to all those Mac lovers out there, but it's how it is for Blender, in my opinion. Okay, I want to print my sculpture. Anything I need to be aware of? Yes, you do. The biggest thing to be aware of is overhang. So if you've got a small block and then a big block on top of it, the printer has to think about how it's going to print those bits that are overhanging. Remember, a printer will go up and up and up like this, and then suddenly round to this big one, and it will fall down if it doesn't have supports. So it puts in supports, and supports mean kind of messy sculpts. It's not impossible, but it just needs, you need to think about that. So try and avoid it where possible, but generally speaking, you're okay. You might just want to think about how it's going to balance. So will it stand up? So if you're doing a character, you've got probably put him on a base so that your sculpt won't just fall down. So that's the only real thing to think about. But the other thing is overhang, so watch out for sort of messy sculpts, because the supports, you kind of have to break them off and it leaves a bit of a mess. I don't have a website. Where can I showcase my, or potentially sell my work? Well, selling your work, I would go onto a site like, well, there's lots of sites. CG Trader is the most used one, but you'll find it hard to sell on there because it's kind of saturated with very, very good artists. Sketchfab, I think, is a really great one because you can look around the model, and it's a good portfolio site as well as selling models. So that's where I used to sort of host my models, if that makes sense. And I sell a few of them. I don't really go out to sell, so I'm not sort of building models for sale, but it's a way of supporting me as an artist. So I do put lots of them for sale, and people can kind of use them in their games or whatever. So Sketchfab is, I would say, is the best place for both showcasing and selling. But there are, like I say, there are other sites. ArtStation is another one that's kind of just the commonly used for portfolios. So I have an ArtStation account as well, and it's just a nice, yeah, it's a nice format, nice for portfolios, and you can just send someone an ArtStation link, and that's pretty normal. So you don't have to have your own website, which makes life a bit cheaper. If I want to print my artwork, do I need to invest in a photo printer? Well, I suppose so, but it's probably cheaper because we don't produce artwork as quickly as maybe, that's debatable actually. But I would say just send it off to be printed, because then you can get different sizes. Like an A3 printer is very expensive, so I'll just send it off. I don't have a photo, well, I suppose it is a photo printer. It could be a class of photo printer. But I've just got an ordinary printer. I never print out my work. These days we don't have to, do we? We can sell it online and get millions for it with crypto, whatever it is. So to print off, you're probably not going to print off loads. So just send it off to be printed at a printer's is my recommendation there. So that's all the questions I have. Hopefully I wasn't too rambly. I felt like I was rambling on a bit there. But hopefully that's useful to you. Someone out there might have found some use for this. So thanks very much for inviting me on. Do check out my channel and my courses and all that sort of stuff. Just Gabbit Media is where you looking up in YouTube. So thanks for joining me, and well, I'll see you on Gabbit Media. You'll definitely want to go there after this, won't you? Thank you to everybody. Goodbye.
Hello, and welcome to
All right. So thanks, everyone. That is that's a Grant Abbott. I'm sorry, presenting on sculpting for beginners. Thank you, Grant, for joining our event. And yeah, it looks like we have a full house here of World Blender Meetup Day organizers, just to close out the event. So for those of you that have been staying through the whole marathon, I'm sure we have some people that have been kind of watching from start to finish. So this session is for you. David, Andrew, how are you guys feeling?
Well, I think I've had about 4 hours sleep, and I think you've had less, David. So
I'm at 3 because my manager here refused to let me sleep in, but she's over here hitting buttons, making sure that everything's working.
Awesome. And Kevin, how are you doing?
Yeah, very good. I had an early start, and it was just on
Zoom just glitched out, so I am. Well, of course it would glitch out with the last minute or so to go, right? So
yeah.
Okay, well, the stream is back on YouTube, and the stream is back on here. So leave it to that we would reach hour 20:35, and then the entire stream would shut down just at the last. I have no idea what occurred.
It said the meeting was ended by a host. We'll figure it out later.
Oh crap! Did you hit a button? Oh man, I'm sorry. Go ahead.
No, that's okay. So we're broadcasting, yes?
Yes, I think we are. It looks like we're up on YouTube again.
Okay, great. So why don't, David, can you just ask Kevin to rejoin, and we'll go through the wrap up. So thanks everybody who has stayed with us. It's been a fantastic year. I have to say, credit really goes to all of our amazing speakers. We had, can you guys see the screen share that I've shown, Andrew? Awesome. And here comes Kevin. Great.
Yep, it's all looking good.
Okay, great. So we had 38 speakers in the end. So for those of you who don't run a volunteer worldwide global online event, the schedule is very much in flux all the way up until like the day of. So basically, we ended up with 38 speakers, which is more than we started the event with, across 23 different cities, which is quite amazing. We had, and actually, I think there was somebody from one other city. I just couldn't remember where it was. He was meant to be in London, but he was really from like broadcasting from Eastern Europe. We had 13 countries. So we're like the United Nations of Blender. So we're still doing over 21 hours of live streaming. So we reached, I'm sure we'll probably go just a little bit over today. We were kind of watching the live stream metrics. At one point in time, David and I thought we saw about 150 YouTube people in the stream at the same time. So it goes up and down, but obviously we get thousands over the course of the event, and we'll see those analytics later. There's been over already, just while we've been live streaming, over 421 views, which equates to 216 watch stream hours. So we're sorry you didn't get to spend that time on your job or with your family, but we're glad you joined us. We had a website that went up literally like days before, got like finalized like days before our event, and we had like 2,700 site visitors to it. So obviously you guys are coming to check us out. We had a brand new member of the team this year, running social media marketing in the background. So, Twitter was by far the easiest way for us to get the word out about the event. We had, we created a brand new Twitter account, and literally we have like over almost 100 followers. On LinkedIn, brand new LinkedIn account. We have over 117 followers in 2 days. We had on Facebook, we reached 252 people. And on Instagram, we literally just joined. We have, I know I have the metrics here somewhere, but they're not in front of me. Needless to say, it was really impressive. It all kind of came together right at the last minute. So time to say some thanks. So first of all, thank you to the presenters. The event wouldn't be what it is without people just volunteering to present on a Saturday, which is just amazing, after a hard week of work. We do have 4 people I want to call out who are event coordinators. So Andrew Buttery, who's like the heart of World Blender Meetup Day. He's the one that gets us all mobilized every year. We have Kevin in the UK. He's a new joiner, but absolutely overperformed this year, managing Africa, Europe, the UK, Middle East. And Andrew, of course, managed Asia Pac. We have David Andrade, who's like Mr. Networker, Mr. Streamer. He's the guy who's making streaming to YouTube possible with his gigabit connection at home and his technical wizardry. In the marketing department, I just wanted to call out Cassandra Nuttall, who is working like real-time live tweeting through the event. Bart runs Blender Nation. He typically sponsors banners on his site. Unfortunately, we got there a little late to ask him for the banners, but he did sponsor our posts on the site, so we really want to thank him for that. In the back end, we had Tanya Rogers doing WordPress site development, and we had Keith Morgan, who made an absolutely stellar logo design. We absolutely love it. That's the monkey with the clouds that you see behind us. And then finally, we just want to thank all of you for joining and watching. We get so chuffed watching all of the YouTube comments, and there's just so much love in the YouTube chat that we should be an example for what the rest of YouTube comments should be for various channels. But the Blender community is just so positive. We had a lot of really great questions for our speakers. So I want to thank all of you for that. Gosh, I'll stop there and see David, Andrew, Kevin, anyone else you want to thank, or anything I've forgotten?
Well, we need to thank you as well, Sterling. So thank you for doing a lot of the emceeing and for helping coordinate, get that marketing team up and running and going. That's been central to all this. So thank you very much, Sterling.
Thank you.
I want to call out Ton again. We did that in the morning, and I think it's appropriate to call it out right at the end. For those that don't know, it's his birthday today. Mr. Ton Rosendahl, who creation of this software is the reason why so many of us have businesses, have created great art and software, and built a community around the world. So I want to thank Ton and the whole crew, and really awesome to see Hjalti and Delay and the special guest Matt Lund this morning from the foundation in the studio. It's always awesome to have their involvement with this event. So yeah, thanks to the whole crew over at Blender.
Yeah, indeed. Yeah, kudos to the Blender team, the developers, and all the artists over there. So we have an announcement. Andrew, do you want to make this announcement? Go for it.
Yes, so World Blender Meetup Day 2022 will be March 19 next year. So we've already had some people express interest in having, presenting next year. So we would love to have you. We welcome first-time speakers or people who have been doing stuff for 20 years. It's nearly always every speaker we have brings something new that one of us has never seen before. So it's always wonderful to get new and or old speakers. If you can't make it on the day, you can pre-record, we'll play the video, but get involved, and there's some contact details there. Yeah, I think that's it. That sums up what we're hoping for next year.
Kevin, any thoughts as we wrap up?
Yeah, I want to thank you all for getting me on board. It's really exciting, and it's amazing to be part of an almost 24-hour conference. And do you guys think we need to have like a 48-hour conference at some point, because this lineup is amazing.
Not without either performance enhancing drugs or cyborg enhancements to help us do it. So all of us are gonna crack open a bottle of champagne and then sleep for a week. So I think 24 hours is all we can handle, but great suggestion. All right, awesome. Cool. So yeah, we're really happy to have you, Kevin. So just a reminder to everybody, jump on your favorite social media platform and find us, especially Twitter, which is where we're sending out a lot of information, but also on Facebook. Twitter, follow us on Twitter, hashtag World Blender Meetup Day. Whoops, I probably should have put that in there. Hashtag WBMD, WBMD, there we go. That is how you find us across all those different platforms. And yeah, the number one thing you can do to make sure you don't miss out on next year's World Blender Meetup Day is subscribe to our YouTube channel and enable notifications. And that way, when it's coming up, it'll just pop up on your phone or your tablet or your PC or wherever it is, your television, wherever it is you happen to watch YouTube. All right, so unless there's anything else from you guys, whoops. I think we'll just wish everybody a wonderful rest of the remaining 2 hours of your World Blender Meetup Day. And we'll see you next year.
Awesome. See you next year.
See you next year, everybody. Bye-bye.
See you next year. Bye-bye.
Bye.
Bye now.